Good morning, everybody.
Good morning.
All right, but I can see the screen and hear me well. All right, we're gonna have a nice session today. We really have a lot of material to get through. I think what we have left to do today, we can move a little bit more quickly than we did yesterday. All right, so I have to be kind of strategic with the process today. I want to complete it today. But if we don't complete it today, then we still can decide to maybe do a session later tonight, just to finish it up, or we can come back tomorrow and have another session. But I prefer to finish it today, so that persons have an opportunity to go through and look back at maybe some of the questions that they want to look over. But let's go. So basically, it's about working the questions and explaining how they can be done quickly in the exam, and maybe clarifying, anything that person might not understand so clearly. All right, so let's go. So we're at this part of the paper now, all right, which is like the algebra, in the algebra section of the paper. All right, I'm going to see a lot of the questions in this section that are similar to one another. All right, so this first question says the product of a number, and this is the number, and its reciprocal may be written. What is the reciprocal? So if you have a fraction a over b, the reciprocal of a over b is b over a. As simple as that. The reciprocal is, as simple as that. I don't need to explain anymore. So it's like you flip the fraction. So for example, if you only have like 2 is the same as 2 over 1. So the reciprocal of 2 is going to be a half, 1 over 2. All right, so for this one, we're looking for the product of this and its reciprocal, which is 3 over 2p. That's what we're looking for. The product of this and that. We're looking for that product. So I have to look carefully now. 2p over 3. So you see all of these is 2p over 3. So we're looking for 3 over 2p. And this is it. Simple as that. This one is very similar. The product of a number and its reciprocal, and the number this time is p. So it's p and its reciprocal is 1 over p. That's what we're looking for. So it's p and 1 over p. So this is the answer. As simple as that. All right? Let's continue. Next question. So this is a number of algebra questions we're looking at now. So this question says, it refers to this diagram, which is a rectangle, and we have this side that is 2 and that is x minus 4. It says the area of the rectangle is x squared. So the question is telling us that the area is x squared. The equation that may be used to find the value of x is what? Which one of these? Remember, the area, they tell us is x squared. But generally speaking, the area is a product of 2 sides, length times width, or width times length. So it will be 2 times x minus 4, that will be equal to x squared. It's just that in these answers, they put x squared as a subject. So we're looking for the one where x squared equals 2 into x minus 4, and it is the first one. So the answer is the first one. Nice and easy. All right, next question. Althea normally saves X dollars per month, but in June, she saves $4 more than twice her monthly amount. So twice the monthly amount is going to be 2X. And she's saving $4 more. In other words, she's adding. The more means that she's adding the $4 to what she normally saves. And she's adding $4 to twice she normally saves. Her saving in June, clearly then it's going to be 2X plus 4. Twice the normal amount and 4 more than it. So we're looking for this answer. 2x. All right, so that is not there. Oh, it's right here. See there? It is right here. 2x plus 4. All right, because they could have factorized it as well. Almost looked at that one, because they could have factorized it, all right, 2 into x plus 2. But they have given us this answer, this format, but they also could have given that. All right. Instead of this, they could have given that one. All right, that finishes that one. Let's continue. Here, I wanted to show you two questions from the get-go. I wanted to look at this question and this question. See the similarity. The only difference is right here. So if you're swatting answers from past papers that you have access to, you see that those minor changes they can make. So you might have swat this question and know that the answer is whatever. So the answer is 3. And you see this and believe it's the same question and go and mark 3 again. So you have to be careful, guys. Those minor changes you can miss. So you need to work out the questions. So here we're trying to make x a subject. All right. So for this one, we're solving for the x. I'm gonna say subtract this 2 for this 3 first. And so it becomes 2 over x equals 1 minus 3. 1 minus 3 is negative 2. Negative 2. Then I can do the reciprocal of both sides, or I can multiply this x and divide under the x minus the minus 2. So I will get x equals 2 divided by negative 2, which means that the x will be equal to negative 1. So the answer is negative 1 right here. And when you finish a question like this, you can just test it. Just put by the negative 1 here so quickly. And see that this becomes negative 2 and 3 minus 2 is 1. So you know that it is correct. All right? This next one now, we try to again make x a subject right here. So again, I'm going to transpose the 3 first. And so I'm going to left with x over 2 equals negative 2. Then it's just a matter of multiplying up the 2 across here. Cross multiply with the 2. So the x equals negative 4. Across multiply with the 2. And so the answer right here is negative 4. Let me write the 2 times 2. I don't need to write that. I think everybody else. Let me write the 2 times 2. Let me write it. So I multiply across the 2. So I get 2 times negative 2. And so the x equals negative 4. So this is the answer. But the good thing about this is that this answer is not down here. So if you're looking for the negative 1, then you wouldn't see it. And that's maybe the good thing about it. All right, but sometimes the answer from a similar question is also there. So you have to be careful. All right, again, you can try the negative 4 here. Try the negative 4 in this answer. And you see that the answer, yes, is correct. All right, moving right along. But this one now is indices. And remember, when you multiply indices with the same base, you add the powers. You add the powers. All right, when you multiply indices with the same base, you add the powers. When you divide indices with the same base, you subtract the powers. So for this one, it is going to be 5 to the n plus 1 plus n plus 2. So the final result is 5 to the n plus n is 2n, and 1 plus 2 is 3. So it becomes 5 to the 2n plus 3, which is this one. And just because we're preparing for the exam, let's say they gave you a minus. What if instead it was a minus? What if instead it was 5 to the n plus 1, not minus, divide. 5 to the n plus 1 divided instead by 5 to the n plus 2. In this case, it will become 5, and you have to subtract the power because you divide it now. So it will become 5 to the n plus 1 in a bracket minus n plus 2 in a bracket. And so I'm doing n minus n and 1 minus 2. So you have to be careful now. So it becomes 5 to the n minus the n. That wipes out the n, and then 1 minus 2 is negative 1. So that's how it will be 5 to the negative 1. That's what you will get, 5 to the negative 1. If it was a division, you have to do. All right. This one now is what we call a binary operation. Binary operation. So they're telling us that a star b means a squared plus b squared. So the star means that you square the first value, which is the a, plus square the second value, which is the b. That's what star means. Right? It's an operation. So they want us to work this out. But just like in the BODMAS system, we have to work out what is in the bracket first. So I'm going to work out what is in the bracket first. We have to work out what is in the bracket first, which is the 3 star 4. 3 star 4 based on this formula, the A becomes 3 and the B becomes 4. So it becomes 3 squared plus 4 squared. And everybody should know the Pythagorean triple 3, 4, 5. Right? So this is like a piece of the Pythagorean triple 3, 4, 5. This equals 25. But this is 9 plus 16 is 25. So the 3 star 4 is equal to 25. So it means that this whole expression now is going to become 25 star 2. And 25 star 2, because we're replacing 3, 4, 5, the 3 star 4 with the 25. Right? And so the 25 star 2 now is going to become 25 squared, because like this becomes the A now, and this is now the B. 25 squared plus 2 squared. If you look at the answers, they're not working it out. Right? They're not working it out. And so the correct answer is the first one, right here. Now, this is the answer that was very popular among some students I know. They chose this one. But what makes this one wrong is that the square on this is missing. So you could have given about the same question, and don't show this, but give back this answer. But what they would do to make it correct is put a square on this. Remember, inside there would be a 25. Or would be a 3. Inside there would be a 3 star 4. So you could have given it like this format, but put the square on that to make it correct. All right, so look out for that. But that is the correct answer right here. All right, nice and easy. Let's continue. This question says, so these are some wordy questions that we're writing as equation now. Right? It says, when 6 is added to a number and the sum is divided by 3, the result is 4. So when 6 is added, mute the mic please, to a number, and that number we can call that number x. Based on these answers, they are calling that number x. So you're adding them. 6 is added to x. And the sum becomes x plus 6 or 6 plus x. The sum becomes 6 plus x. That sum is divided by 3. Divided by 3. The result means equal. The result is 4. That's what you're looking for. Just like that. The sum is divided by 3. The result is 4. All right, so the answer is this one. Next one. When 5 is added to a certain number, same thing again, and the result is now multiplied by 3, the final answer is 27. What is the original number? So here now, don't want us to calculate that number. So let's set it up. We're going to call the original number x. So the 5 is added means plus, to a certain number x. And the result, which is 5 plus x, is multiplied by 3. Multiplied by 3, so times that by 3. The final answer, meaning equal, the final answer is 27. That is it, That's the equation that we're solving. This is what they have set up here. And this question wants us to solve it. So clearly, 3 times 9 equals 27. So this has to be 9. Or you could say divide by the 3. 5 plus x must be equal to 9 if you divide by the 3. Or if you say 3 times 9 is 27. And then you subtract the 5, you get x equals 4. So the x has to be 4. That is the answer, 4. Another one, more of the same. When twice a certain number, see now twice means 2 times, a certain number is now subtracted. So twice a certain number, we're going to call it 2x. Is subtracted from 7. It's subtracted from 7, not subtracting 7, it's subtracted from 7. So it's 7 minus That's what I mean. Let me write it down here. So the twice a certain number is 2x. Subtracted from 7 means that it is 7 minus 2x. The twice a certain number is subtracted from 7. And then the result is multiplied by 3. This is the result, you know. It is now multiplied by 3. The answer is 33. The answer is 33. What is the original number? So this is what we're solving now, guys. So you set up what they have said and you solve it. So clearly inside here is 11, because it is 3 times 11 that is equal to 33. Or you can say divide by the 3 on the here. In any case, you're going to get 7 minus 2x equals 11. I can transpose the negative 2x and make it positive, and then transpose the 11. So I can get 2x over here, and then transpose the 11. So I can get 2x over here. Mute your mic, please. Mute your mic, please. All right, and this is negative 4 equals 2x. And if I divide by the 2, I get x equals negative 2. So the answer is right here, negative 2. And you can always just check it. Just check it if you like, if it is correct, if it makes sense. But that's what I'm getting, negative 2. All right? If I put the negative 2 here, I'm going to make this positive 4. And 7 and 4 is 11. And then 3 times 11 is 30. So that is correct, negative 2. All right, next one. All right, so finish that set of worded questions, right? So one of them wanted us to show the form of the statement. The others wanted us to work it out. All right, let's continue now. Here now is just some simple algebra. The product means you multiply. It is minus 2a times minus 3a. So the minus makes it a positive. And the 2 times 3 is 6. The 2 times 3 is 6. So we're going to get a positive. 2 times 3 is 6. And then a times a is a squared. A times a is a squared. So that's what they're going to get. Positive 6a squared. They don't need to put the positive, but I'm showing it because of the minus. This is the answer right here.
Sir?
Quick and fast, nice and easy. Yes?
Sir, can I go back to the question before, please?
This one?
Yes, sir. Some people are asking why you didn't use the distributive property for the 3 and the
Expand it out.
Yes, sir.
Expand. You don't need to. You don't need to, because I could easily divide by 3, or I could see that 3 times 11 is 33. So it means that this thing is must be 11. But if you expand it out, you're going to get the same answer, you know. But to me, expanding it out is making it more complicated, because I can simplify. I always want to simplify first. That's a 3 and that's an 11, a 33. I can divide 2 by 11, by 3, and simplify it down. So if I do it the other way, I'm going to get the same answer at the end. 3 times 7 is 21. We'll put R here, so. Then 3 times the negative 6, negative 2x, negative 6x equals 33. See, I have bigger numbers to work with. Take this and bring it over here. I will get 6x over here. Equals, I'll now have 21 minus 33. 21 minus 33 is negative 12. That equals 6x. Then divide by the 6, I get x equals negative 2 just the same. If I divide by 6. But I think these are larger numbers to work with. It becomes much simpler if I divide this line with the 3 right here, so. And simplify it, or recognize that 3 times 11, this inside here must be 11, because 3 times 11 is 33. But I mean, it doesn't matter. We're going to end up with the same answer anyway. And yet we could approach it another way as well. There's not one way to do it. Once you start to make x a subject, that's it. All right, hope that answers it. All right. Next question. You will do it the way you see. Just make sure you do the right steps, the right process. Not one way to solve a question. This question says p over 5 is 20. What is p? We just multiply the 5 across here. Cross multiply by 5. It is the same as saying if you have p over 5 equals 20, and you want to eliminate this 5, you would multiply both sides by 5. So you multiply this side by 5, and you also multiply this side by 5. Let me spread it out. Let me spread it out. Right. So it's like you have P over 5. P over 5 equals 20. And I multiply both sides by 5. So it's 5 times this side and 5 times this side. This one cancels this. So I end up with the P equals 5 times 20, which is same as this right here. 20 times 5, same as 5 times 20. But who went about to do that? That is long way to do it. I'm not even leaving it on the screen. Right? We're just gonna do it shortcut. We don't have to show any steps. Right? We're in an exam, that's a multiple choice. We're using the shortcut method to transpose. Shortcut method to transpose P over 5 equals 20. It's just say take this under here and cross multiply it up here. Right? Cross multiply up here. It's multiply it up. This is the same as 20 over 1. So you cross multiply this up here to leave the P as a subject. Alright, so the P equals 5 times 20 or 20 times 5. Same answer, this 20 times 5. Easy stuff. Spend too much time on that. Next question. This question says P plus Q equals -1, and at the same time P times Q equals -6. So the sum of two numbers is -1, and the product of the same two numbers is -6. And they're asking us for this. Now this can be worked out, you know, but I think it's too much time to work it out. Right? You must recognize that the sum of two numbers that is equal to -1, such that the product is also -6. Has to be that we're talking about 2 and 3, but one of them negative. Since the sum is negative, you have to make the larger one negative. The larger one has to be the 3. Those are the two numbers we're talking about, you know. So you can make P be any1 and make Q be any1. All you know is that those are the two numbers we're talking about. And so we're working this out now. So it becomes one of them square, one of them cube, right? So this becomes, so the P cube plus the P cube plus the Q cubed is equal to 2 cubed plus -3 cubed. The 2 cubed is 8. 2 times 2 times 2 is 8. And the -3 cubed is -27. When you raise a negative power to a, when you raise a negative number to an odd power, so the power is odd, it comes out negative. When you raise a negative number to an even power, it comes back positive. So because this power is odd, you know it's going to come back negative. So it becomes -27. This works out to be -27. So I'm adding -27, same as subtracting 27. So 8 minus 27 is -19. So the answer is A, -19. That is it. It's easy as that. But the good thing about this question, or the first part about this question, is getting that these are the two values that we're working with without solving the equation by observation. This is by observation. Those are the two values this is referring to. Right? And you could see because the product is 6. So the product is 6, you should be thinking about 2 and 1. And then the sum is -1. Just that product is -6, so you know one of them negative and one positive. Since the product is negative, one of them positive and one of them negative. And then when you add them, you get a -1. So you must give the larger one the negative sign. All right? If this was positive, I would give you the larger one the positive sign. If this was a positive one, I would give the larger one the positive sign. That's what I would give. All right? So if let me write it out for you. If they gave out the same question, let me write it over here for you. If they gave out the same question, or almost the same question, all right, like this. Let's look at it over here. But this time they say P plus Q equals 1. That's 1 enough. And then they say PQ equals -6. It's still the same two numbers, you know, 2 and 3, you know. Still 2 and 3 you're working with, you know. 2 and 3. But one of them negative. Which one negative? Because the product is negative, one of them must be negative. So because the sum is positive, you have to make the larger one positive this time. So this will be the negative one. If that was the case, if they give you this, if they should give you that. Right? Because it then will be 3 minus 2 is 1. And then -3, -2 times 3 is -6. right? You don't have to work out these things. Because if you want to solve it as an equation, it's too much work. And then if you're doing the same P cube plus Q cube, it would be negative 2 cube plus 3 cube. Now this time this will be negative 8. Negative 8. And this will be 27. So then it becomes 27 minus 8, which becomes a positive 19 this time. And you also have to be careful if they should maybe change this and put a negative on it. Because if you put a negative on that, then you'll be working out this instead. You'd have a minus here instead. And then the minus will make this into a plus. And then it will be 8 plus 27. So you have to be careful. Don't just think it's the same question I give you. To make minor changes all the time. You have to be careful. Work what is there. Anyway, let's continue. This one right here. So this one gives us some values and it asks us to work this out. So this kind of plug in these values into that expression. That's what it's all about and work it out. So this becomes equal to, the x is negative 2. So I'm going to put negative 2 for the x. Negative 2 upon y is 3 upon 3. And then the t is 2. So the t is a square. The t is 2. That's what you're working on. So you're squaring this. So you basically square the negative 2, you get 4. And square the 3, you get 9. So that's 4 over 9 right here. Nice and easy. I think I've seen one already where this was a negative 2. So for example, I don't want to spend too much time doing these variations in the box, we're preparing. So if instead it was x over y to the negative t, then it would work out to be negative 2 over 3 to the negative 2. Then this negative power would mean that we take the reciprocal of inside here. Negative power means reciprocal. So this would work out to 3 over negative 2 squared. I drop the negative when I take the reciprocal. See, I flip this. Right? When I take the reciprocal. And then it will become 9 over 4. I square the 3, you get 9. You square the negative 2, you get 4. That's what it will become. If this was a negative t instead of a positive t. And I'm sure that I've seen one before with a negative t there. I've seen one before with a negative t. So we have to look out for that. All right, so this is if it was this. So I'm going to put that in a different color. If it was this. So we're just looking at the various ways I could maybe change the question. Right? Same thing. All right, so we can understand. So far, so good, guys. But okay so far?
Yes, sir.
All right.
Yes, sir.
All right, good. This one. All right, I know this one not so good. Thanks. All right, so I know this one not so clear, so I'm going to write what it is, right? This one. So what this one is really, it's an indices question. I'm going to write what it is. So this right here really is 3 to the 2x plus 1 equals 9 times 3 to the x. That's what this is. And they're asking for the value of x. It's an indices question, Clearly the base that you can bring everything to is 3. You're working in base 3. I have to use the laws of indices to do it. All right, so what I'm going to do, since this side is already base 3 to a power, I'm going to bring this side to base 3 to a power, step by step. Now, this 3 is same as, this 9, sorry, is same as 3 squared. So the equation becomes, I'm solving it now. Let me solve it in blue. 3 to the 2x plus 1 remains. This 9 is 3 squared. So it becomes 3 squared times 3 to the x. Now here, it's like I'm multiplying 3 squared and 3 to the x. When you multiply numbers with the same base, you have to add these two powers. Add them. So it becomes 3 to the 2x plus 1. Write that better. 3 to the 2x plus 1 is now equal to 3 to the 2 plus x. Add the powers. 3 to the 2 plus x. And then if you have this side equals this side, and both of them have the same base, then it simply means that the powers equal. All right? Simply means that the powers equal. Not no dividing, cancel, no nothing. If the two numbers raised to the same, if the two two base are equal and they raised to a power and such that this equals this, then naturally the two powers must be the same. I don't know if I'm saying it right, but I'm just saying this, since this side equal this side, the two powers must be the same, but both sides have the same base. So we can draw the conclusion and say, therefore, the two powers must be the same. 2x plus 1 must be equal to 2 plus 3, 2 plus x. And so this is what I'm solving. So I'm going to transpose this 2 over here and this x over there and subtract it and get 2x minus x equals, transpose this 1 over here and subtract it as well. So I'm going to get 2 minus 1. So this side becomes x, this side becomes 1. So the answer is 1, x equals 1. Hope everybody understands that. That is it. Well, the video is there now. You can always go and watch it over. All right? But that is it. Next question. Moving right along. All right. So I have 2 questions side by side here, similar. All right. Now with this one, the base, the denominator is different. When you're adding fractions, whether the fractions are numeric or algebraic, you want to make them related. Fractions are related when they have the same denominator. Now some people do some LCM business and some rote learning method to do it. I'm not going to do it that way, ever. I'm going to do it using a process that you should understand. So what it is that I want the two denominators to be the same. So both of them can be raised to 15x. So if I multiply this one by 3, I'm going to make it 15x under here. I want the two fractions of the same denominator. So I'm going to multiply this fraction by 3 over 3. That will make my denominator be 15x. Multiply this one by 5 over 5. 5 over 5. Multiply this one by 5 over 5. And so when I do that adjustment, this expression becomes, this up here becomes 3. 3 times 1 is 3. 3 over 15x. And this up here becomes 10. 10 over the same 15x. Now that they have the same denominator, they are related, I can just add the numerator. So the 3 plus 10 is 13. So my result is 13 over 15x. That is it. I say, don't mark this one, and that's a square. Don't mark that one. All right? The answer is this one, 13 over 15x. All right? Now this one is nice. The reason why this one is nice is because the fractions are already related. They already have the same denominator. So there's no need to make any adjustment. Just add the numerator values. 4 and 2 is 6, becomes 6 over 5x. So looking for 6 over 5x is the very first answer. Done. That's a plus, guys. When you're adding fractions or subtracting fractions, you want to make them related. Related is when they have the same denominator. When they have the same denominator, you simply add the numerator values algebraically. When I mean algebraical, I mean consider the plus and the minus and all that. That's what I mean. All right? Moving right along. I'm trying to move quickly today, guys, because I have a lot to go through, right? So I'm trying to move quickly. All right? So if you don't understand something, just let me know. I'm not going to see it in the chat. So you have to maybe say something. Or if somebody see in the chat, they can maybe say it. This one says, 7 times the product of 2 numbers A and B may be written. So this is another wordy question. 7 times the product. The product means you're multiplying them. And those numbers are A and B. So it's 7 times the product of A and B. A and B, product of A and B is AB. So that's what you're looking for. Easy question. Answer is A. Don't need to explain that anymore. 7 times the product of 2 numbers A and B. The product of A and B is this. And you're doing 7 times. Done. This one, another question where you're substituting values. So they give us this expression and they say x is 4 and y is 2. And they want us to work this out. So basically substituting the values in there. So this becomes, the x is 4, so I get 4 squared for the x and numerator there, plus the y is 2, so I get 3 times 2 divided by the x is 4 and the y is 2. That's what I'm solving. Remember, you can't use a calculator, you can expand it out and work it, right? Because the small numbers are the same. So this is 4 squared is 16, so it becomes 16 plus, this is 6, and this under here, so it's 8. 4 2 is 8. All right, and you see these numbers that they work on. So I can simplify it here now. I can divide numerator and denominator by 2. So all right, let's write this like this. It becomes 22 over 8. 22 over 8, which reduces, if I divide by 4, reduces to 11 over 4. 11 over 4 is 2 remainder 3. 2 remainder 3. 2 remainder 3. So this is the answer. 2 remainder 3 over 4. That is it. But understand that. This becomes 2 remainder 3 over 4. That's what we get. All right. Nice and easy. That's just some simple numbers to work down. Next question over here. Moving quick and fast. So you see these questions easy. Here we're starting for x now, guys. Trying to make x a sub. So we have this equation to solve for x. Multiple ways to do it. I can divide by the 5 first. So if I divide by the 5 first, I'm gonna get 2x. I can look, I can look at it and say, okay, 5 times what equals 35? 7. So this has to be equal to 7. Can do it that way, right? Become fast in the exam. But let's say we're working it out and showing the steps. So divide by 5 first, we get the 2x minus 1 equals the same 7 we talk about. But this divided by 5 is 7. Transpose the 1 and get 2x equals 8 when you add the 1 and then divide by the 2, you get x equals 4. So the answer is 4 right here. Done. You can fast, nice and easy. Next one. John has X marbles and Max has twice as many marbles as John. So me say John has X marbles. So this is John has X. Max has twice as many. So John and Max. So John has X marbles. Max has twice as many. So Max has 2x. It says Max gives John 5 of his marbles. So Max give away 5 of his. So Max now has 2x minus 5 and John now has x plus 5. So what they ask him? How many marbles does John have? They're asking about John. So this is the answer. X plus 5. If the question was how many marbles does Max have? Then this will be the answer. So look out for that. You can change this word right here in the exam. This word. You can change it to Max. You change it to Max, then this is going to be the answer. Simple as that. Same information, but you can just simply change that word to Max, and the answer will be different. All right? But they ask for John, so we'll give them the answer for John. If they ask for Max, they will give them the answer for Max. This is what it would be. It was Max right here. This answer. All right. Enough said. Next question. Careful now. That's the difference of 2 squares, So it's a similar question this now. All right. So this says the A equals 3 and the AB is 6. So ready. And I want us to calculate A squared minus B squared. I need to find the B. I'm going to take the 3 and substitute for the A right here. I can say that the B must be 2, So based on that, the 3B equals 6. But the A is 3 right there. And so the B equals 2. And if the B equals 2, I'm going to work this out now. So we can say, therefore, A squared minus B squared simply becomes 3 squared minus 2 squared, which becomes 9 minus 4, which is 5. The 3 squared is 9. The 2 squared is 4. This is equal to 5. Answer is 5. Don't give away these questions, guys. They're too easy. Don't give them away. Right? Another question might change this to a plus. Right? And then to be instead 3 plus 4 to the 13. So them have the 13 answer there. Yeah. All right, next one. Next question. Or they could do away with the change this to a negative 6. All right, and then the B will be negative 2 instead. All right, next question. Working this one out. Solving this for y. So here now we're gonna expand out this and then group the terms in y. So expand this first. I'm gonna get 5y minus 10. Here for this negative 3 now. So it's negative 3 times the y is negative 3y. And then notice it's negative 3 times the 4. Now, plenty of people are gonna put plus 12 right here, so now, which is wrong. It is negative 12 as a multiplying with a negative 3. Negative 3 times the 4 Don't just focus on the 3. All right? Don't just focus on the 3. It is negative 3 multiplying by each of those things. So it becomes a negative 12. That's where a lot of people make the mistake right here. They put positive 12 instead of negative 12. They consolidate the values. 5y minus 3y is 2y. 2y. Oh, this equals 0, right? This equals 0. So the 5y minus 3y is 2y, as I said. Then the negative 10 and the negative 12 become negative 22 equals 0. So I can transpose the 22 and divide by the 2. So I'm going to get y equals 22 divided by 2, y equals 11. That is it. So over the 22 first, I get this over here and then divide by the 2. All right, or you could read just say where you said 2y equals 22. Y equals 11, just to see. All right, so way you want to look at it. Answer is 11 right here. Beautiful. Nice and easy. Shift this over a bit. All right, good. That finishes that page. Let's move on. Next page. Similar question. Different values, similar question. Solving equations defined. So you see, similar question. And this one now about negative that you have to be careful for. Careful about. Expand this first. We get 3x minus 3. Expand this now. It is negative 2 times x. That's negative 2x. Then there's negative 2 times negative 1. That's where a lot of people make the mistake. They're going to focus on the 2 alone times the negative 1 and put negative 2 and give it away. Don't give it away. It is negative 2 times negative 1. The number in front of the 2 is negative, so it becomes a negative 2. That becomes a positive 2. Negative 2 times negative 1 is a positive 2. And this result is equal to 7. That's what we're solving. 3x minus 2x is x. Negative 3 plus 2 is negative 1. Negative 3 plus 2 is negative 1. That equals 7. Carry over the negative 1 and add it to the 7. The x equals 8. X equals 8 right here. These are easy questions. Down here again. Careful with this negative. Let's work it out first. The negative 2 becomes a positive 2q. So this becomes a positive 2q first. So I get 2q, and then this will mean minus 3q, minus 3q. So 2q minus 3q becomes negative q. 2 minus 3 is negative. So negative q right here, negative 1q. It's the same as negative q. This is the answer. Nice and easy. Moving right along. The expression this is the same as, so I don't want us to expand it. Careful with the negative. That's what this question is testing now. Negative 2 times x is negative 2x. Negative 2 times negative 4 is positive 8. So you're looking for that. Negative 2x plus 8 right here. Don't give it away. Negative 2x plus 8. Minus minus is plus. Easy questions. This one. So you see there's a section of the paper where the questions get very easy. Right? After the consumer, the questions are very simple algebra. Again, we're going to expand this out first. So we're going to get this 3x. I'm going to put it under here. This 3x comes back first. 3x. Remember, you're expanding with a negative 4, not a 4. So many times I put that on the paper are the tempting persons to make the mistake. Negative 4 times x is negative 4x. Negative 4 times positive 6 is negative 24. Simplify. 3x minus x is negative x minus 24. Negative x, negative 24 right here. This is the answer. Nice and easy. Let's continue. Next one. This is now an inequality. And if you notice, they have made x a subject in there, in the middle. So we don't need this 2. What are we going to do? Divide all sides by 2. Divide all sides by 2. That's what we have to do. So we're going to take this inequality, and to get an x in the middle, we're going to divide through by 2. Divide through by 2. You divide all 3 sides by 2. Divide this side by 2, this side by 2, this side by 2. No, because I'm dividing with a positive number, I don't need to change the inequality sign. The inequality sign stays the same. I'm going to tell you what I mean after this. If I divide this by 2, it becomes a 2. The sign remains less than. If I divide this 2x by 2, it becomes x. This sign remains less than or equal to. If I divide this by 2, it becomes 3. This is my answer right there. Quick and fast, nice and easy. Look for it carefully. It is the first one. See, these have negatives on them? No, none of those correct. It is the first one. Let me show you what I'm talking about. If instead you had something like this, put it in purple. If you had something like this, let's say it was 4 less than negative 2x this time, less than or equal to 6. I don't want this negative 2, I have to divide it out. But in an inequality, when you multiply or divide with a negative number, you have to reverse the inequality sign. You have to reverse them. So in this case, if I divide by a negative 2, to get rid of this negative 2 here, I'm going to divide, because I want to leave x alone in the middle now. So I'm going to divide this time by a negative 2. But because I'm dividing with a negative number, I have to reverse the signs, the inequality signs. Because I'm dividing with a negative number. I have to reverse this one and this one. So I have to make the 2 of them become greater than. That's what it is. So what will happen is that this will become a negative 2. This sign is reversed to greater than. This will become x. And this sign again is reversed to greater than or equal to. This will become negative 3. Now remember, negative 3 is smaller than negative 2. So I can actually turn the inequality around and put it like this. So I can say, i.e., that is negative 3. This way, I say the x is greater than that. I'm putting my x in the middle. So you see, read it this way now. The x is greater than negative 3. And then this now, I write it the other way around. Because the x now is less than the negative 2. So I'm going to put less than the negative 2. So I could spin it around like that. That will be the same thing. All right? So if you get one of the negative there, that's what you have to do. So chances are they will put this as the answer. But this and this is the same thing, you know. If you read it from the middle, look, if you read it from the middle, read it from the middle. Read it yourself first. That is saying x is greater than negative 3, you know, which is the same that this is saying. X is greater than negative 3. X is greater than negative 3. And if you read it from the middle again, always using x as your reference. But read it from the middle right here. And read it from the middle on this side. This is saying x is less than negative 2, but this is saying the same thing. X is less than negative 2. We're saying x is less than negative 2. X is less than negative 2 because the point on the inequality sign. You have 1 point here, 2 points here. This is less than this. That has 1 point on the inequality sign. You can think of it that way. All right. So that would be your result. All right. That would be a result. So if you get a negative in there, guys, that's what you have to do. All right. Let's move on. Let's not spend too much time on that. All right. Coming up here now. More of the same. This one says no. Let's look at this one. This one says the sum of 2 positive numbers. Everything important. P and Q is 32. What they are basically saying is that P plus Q equals 32. And the 2 of them positive. Their difference is 12. That means that P minus Q is equal to 12. What is the smaller one? This has to be the smaller one, guys, the Q. Because if I'm subtracting, I'm getting a positive 12. The Q has to be the smaller one. So the Q I really need to find. So I'm solving them simultaneously. I can subtract the 2 equations and find the Q straight enough. But I can find the P first, and then based on the P, I can deduce the Q. Because to find the P first, I can eliminate the Q by adding the 2 equations. If I add the 2 equations right now, because one positive and one negative, if I add them, the Q will be eliminated. So if I add the 2 equations, add them. P plus P will become 2P. The plus Q and the minus Q, they wipe out each other. This will be equal to 32 plus 12 is 44. And when you divide by the 2, you get P equals 22. P equals 22. So if you put the 22 right here, so for the P, it must be 10 it's subtracting, you know. I'll put another way. Put the 22 right here, so for the P. You must be adding 10 to get the 32. So based on that, we can say the Q. So right here, we can deduce and say the Q equals 10. So we can say, and the Q equals 10. The answer one, the smaller one. So this is a smaller one. So the smaller one is 10. They wanted the larger one, it will be 22. So you see, this is if they wanted the larger one. That is it. What about that? But okay with that?
Yes, sir.
All right. Next question is to do this. Straight multiplication. So these are like, these you apply indices. So the 3 times the 2 is 6. I'm multiplying. 3 times the 2 is 6. Then the x squared times the x cube, you're going to add the power. So it becomes x to the 2 plus 3. X to the 2 plus 3. So it becomes 6x to the 5th power. That's what it becomes, which is right here. Easy stuff. Let me shift this down a bit. All right. Next question. This is like a small. I'll shift this up. Let's shift this up. All right. Next question. Right here. It's a binary operation again. Note that this is a cube and that is a square. I've seen questions where they put a square here. So you have 2 squares. And I've seen questions where they put a cube here. So you have 2 cubes. All right. Follow instructions. So the m becomes 5 and the n becomes 2. So this is like your m and this is like your n. So you're dropping them in this. So it becomes the square root. The m is 5, that's 5 cubed. Minus the n is 2. The n is 2, that's 2 squared. This is 125. It becomes the square root of 5 cubed is 125 minus 2 squared is 4. So you're doing the square root of 121. And square root of 121 is 11. This is the answer. All right, that is it. Easy stuff. This section of the paper usually very easy. Got this one now. Observation. It says 3 star 6 is 12 and 2 star 5 is 9. Then AB the finals. You know, which one of these satisfy both of them? That's what it is. Now look at it. I said that this 12 is 2 times this plus this. 2 times this plus that. 2 times the first value plus the second value. 2 times the first value plus the second value. I'm not even going to explain. This is an observation question or a trial and error. So what you could do, if you can't see it, you basically have to try these. Try this formula with the 3 and the 6. Try the 3 and the 6 in this formula. See if you get the 12. And then you try the 5 and the 10. The same formula. See if you get the 9. And you have to do the same thing. You have to do the same thing using a trial and error method. You have to do the same thing with the second one and see if you get the values. It's consistent. And then you have to try to the last with that one and see. So if you're doing that way, you're going to take all day. Right? But you could just take a cursory glance at it and see that this is the correct one. 2 times the first value plus the second value equals this. Right? Let's write it out. Because 2 times 3 plus, let me write it out. Because the 3 star 6 means 2 times 3 plus the 6, which is 12, that is correct. And the 2 star 5 means 2 times the 2, 2 times the 2 plus the 5, which is 9. Both of them correct. That's why that is it. If you were sort of testing them. All right, so you can look at it and see which one that makes sense and get it. But this one fairly obvious. Next one, another worded question. When 8 is subtracted from a certain number and the result is multiplied by 3, the answer is 21. What is the original number? Similar question. 8 is subtracted from a certain number. So the certain number is x. You subtract 8. 8 is subtracted from the x. And the result is multiplied by 3. The answer is 21. So it means that this is 7, because 3 times 7 is 21. So it means that the x minus 8 is 7. Take over the 7 and add it. You get x equals 7 plus 8. X equals 15. So the answer right here is 15.
I don't think your scene's working.
Mute your mic, please. Mute your mic. Mute your mic. Done. Next page. We're going into matrices now, guys. So we finish that algebra section. We're going into matrices now. I'm going to continue for a while, and then we'll take a break. All right? For just about 1 hour. Let's continue for a while because we have a lot to get done today. So let me just continue through this section straight without a break yet, and then we'll see. All right, this one now, algebra. This means determinant, guys. All right, the star A is a symbol for determinant. Determinant. And if the determinant is equal to 0, it means that the matrix has no inverse and is singular. So this is the answer. If the determinant is equal to 0, it means that it has no inverse and it is singular. A has no inverse and is singular. It is singular and it has no inverse. Has no inverse. So I could have said this instead, that it has no inverse. Has no inverse. A has no inverse. The matrix A has no inverse. When the determinant is 0, it has no inverse. When it has no inverse, it is said to be singular. If I put a value here, like for example, determinant of A equals 5, then it will be non-singular. Instead of 0, if I put a value there, instead of 0, it will be non-singular. If I put 5, any other value, even -4, any value they put half, any number other than 0, it will be non-singular. All right, I'm just saying that. I don't know what's coming on the exam, so I was telling you. All right. Two matrices A and B are conforming for multiplication. If this is just what you have to know. When the number of columns in the first matrix matches the number of rows in the second matrix, let me set it up like this for you. So if you have, for example, a 2 by 3 matrix, right? By 2 by 3, 2 by 3. I multiply that with a 3 by 4, just for argument's sake. This is possible because this number of columns matches this number of rows. So because those two equal, it is good, it is okay, they are conformable. And the resulting matrix, the result matrix is going to be a 2 by 4. Would be a 2 by 4. It will take the number of rows from the first one and another column from the second one. That's how it works. Let me shift this down and leave it there. So you want the number of columns in the first matrix to be equal to the number of rows in the second matrix. The number of columns in the first matrix is A now. Number of columns in A equals the number of rows in B. So this is the answer right here. First matrix is A and the second matrix is B this time. A and B. A is the first one. All right, that's what makes them conformable. Next one. The determinant of the identity matrix. What is the identity matrix? The identity matrix for multiplication. Symbol for it is I. So instead of writing out identity matrix here, you could have given the letter I instead. Means the same thing. That matrix is 1, 0, 0, 1. It's the identity matrix for multiplication of matrices. The determinant of that matrix is 1. If you calculate it, it becomes this product, which is 1 minus 0. So the identity, the determinant is 1. The determinant of I equals 1 times 1 minus 0 times 0, which is equal to 1. I don't have to show this calculation, but I just put in it there still. All right, next one. If A is this matrix, then the order or the size, instead of order, I could have said size. What is it? It is the number of rows by the number of columns. That's what you want. The number of rows by the number of columns. What are the rows? The rows are the horizontal value. I'm write it out for you. So it's like you have this. I'm not going to put in the values in it. So like you have 3 rows and 4 columns. I'm not putting in the values. I'm just setting it up so I can show you what you mean. So the rows are the horizontal values. These are your 3 rows. These are the rows, 3 of them. And then these are your columns, 1, 2, 3, 4. 4 columns. And you name or you give the order of a matrix by the number of rows by the number of columns. These are your columns, the vertical data. Columns. And you say rows by column. The order is written rows by column. The order is always rows by, you can put the word by, or you can put the symbol, the X. Rows by columns. Write it out. Or you can say rows by columns. That's what you name the order of a matrix, or the size of a matrix. So this one is a 3 by 4. But this has 3 rows. This example has 3 rows. 3 rows. And it has 4 columns. So therefore it's a 3 by 4. It's a 3 by 4. 3 rows, 4 columns. All right. I'm just spending some time on it for those who maybe don't know. All right. I know a lot of you know already, but bear with us. We're here to help persons who don't know. All right. If you know already, it's good revision for you anyway. Let's continue. Bang, 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 up here. This one says item 28, following matrices X and Y. What is the order of the matrix product? All right. What is the order of the matrix product? Well, this one is a 2 by 3. So what we're doing a 2 by 3. Let's write it out. A 2 by 3. That's what this one is. 2 rows, 3 columns. That's what that has. And we're doing that with a 3 by 2. 3 by 2. This is a 3 by 2. 3 rows by 2 columns. I'm multiplying them in this way. X times Y. So multiplying a 2 by 3 with a 3 by 2. The multiplication is possible because this and this equal. So everything good. The result is going to have a 2 by 2. Let me write circle. 2 by 2 is going to be the result. So the result will be a 2 by 2. It takes the number of rows of the first one and number of columns of the second one. So the answer is A right here. It's going to be a 2 by 2. Nice and easy. That will be the resulting matrix, a 2 by 2. Next question. This one says, boom, bang, boom, bang. So they give us the same 2 matrices as they did a while ago. See, same 2 matrices. And now they're asking us for the product. Which one of these is the product? So it's like we want to multiply them. So we're going to use a process of elimination. We're not going to work out fully, you know. Nope, we're not going to work out fully. So when I work out the first value first, let's look at it. How we multiply it. How we multiply the 2 matrices. So the matrix, the result is going to have 4 values like that. We're going to search for the first value. And look which one of these match the first value, right? Searching for the first value. So there's a process of elimination. So how do we calculate the first value? Let me use it already. So the first value, remember now, multiplying this one by this one, the same order, right? So the first value is in the first row, first column. Remember, up with this question a while ago, we said the result was going to be a 2 by 2. We can actually see them giving us 2 by 2 answers down here, right? Let's start over now. So the first value here that we want, it is in the first row and the first column. So to get it, we have to multiply this first row by this first column. So we always take the rows from the first matrix and the columns for the second matrix. How do you multiply them? First element by first element, second element by second element, third element by third element. So we're going to multiply them this way. Go back for the blue. Purple. We're gonna do 1 times 3, then 3 times 2, then negative 3 times 0. First element times first element, second element times second element, third element times third element. Along the row and down the column. That's what it means. Another way of saying along the row and down the column is first element times first element, second element times second element, third element times third element. Let's work it out now. 1 times 3, that's 3. 3 times 2, that's 6. Then that's 6. Hold on. That's 6. Right. So the 3 times 2 is 6. Let's put the 6 first. And then negative 3 times 0 is 0. So the first value works out to be 9. So now the answer is either this one or this one. So we can eliminate 2 of them. Let's put X on them. So it's not this one. And this is not this one. So look here now. It's either this or this, right? It don't make no sense we want to calculate that value. Because that is 25. And it also don't make any sense to calculate this value. Because it's the same. So the value that makes sense to calculate is this one now, to see which one of them it is. Because that's the only value that is different in both of them, which is the second value, which is now is right here. Let me show it on the matrix now. Go back for the blue. No, go back for the map of the blue here. So we're talking about this value over here so now. This value. That value is in the first row and the second column. So to get it, we have to multiply to get that value, we have to multiply, let me mark it. We have to multiply the first row by the second column now. See here, this first row by this second column. That's going to give us that value. And multiply the same way again. First element times first element, second element times second element. Let's go for the purple and do it in purple. So it's going to be 1 times 0 is 0. And then 3 times 1, second element by second element, that's 3. And then negative 3 times 5, that's negative 15. Negative 15. So this is negative 15. Put by the bracket. So this works out to be negative 12. That's negative 12. So looking for the negative 12 one, which is the A. So it means that this is not it either. This one is not it. So let me erase these. This is not it either. So based on the process of elimination, A is your answer. All right, I spent a lot of time on that, but that is it. All right, that is it. All right, next question. Down here. They give us this matrix and I want us to do 3 times A. So 3 times A means that you just triple those values. Triple the values. That's what 3 times A means. This is A. Then 3 times A means that you're tripling the values. So you're gonna get, let's write them out and then look for the one. Triple these values, we're gonna get 3, 9, negative 9. Triple these values, we'll get 9, 0, and 15. If we triple the values, that's what 3A is. So we're looking for that one. That looks like the first one. Yep, first one. First one. Nice and easy. That is 3A. Easy question. We're moving right along. This one now. What is the order of the matrix Q? It's a Q here, so similar question. 1, 2, 3, 4 columns, 3 rows. All right. So it's 3 rows, 4 columns. So it's 3 rows. These are the rows. These are your columns. All right. So the order is 3 rows by 4 columns. 3 rows by 4 columns. Let's put C. Let's write it over here. 3 rows by 4 columns. So that's 3 by 4. 3 by 4A. All right, 3 rows, 4 columns. What is the determinant of P? This is P. We want the determinant. Let's write it out. It is 8, 6, 7, 5. How we calculate the determinant? it is the product of the element on the first diagonal minus the product of the element on the second diagonal. That's how you calculate the determinant. First diagonal product minus the second diagonal product. First diagonal product minus the second diagonal product. So the determinant of P equals, let's work it out here. Determinant of P equals, the first diagonal product is 8 times 5. Let's write it out. 8 times 5. Minus the second diagonal product is 6 times 7 or 7 times 6. Same thing. 7 times 6. So 8 times 5 is a 40. 7 times 6 is 42. This works out to be negative 2. So the answer is negative 2. Nice and easy. Don't give it away. Next question. This one says they give us this equation and I want us to calculate the value of x and y. So basically I want to make this xy the subject. I need to divide by this 5, guys. Divide by 5. So first I'm going to divide by 5. And I can actually divide inside here by the 5. All right? So I'm going to get xy equals 4 into, and divide this by 5 and that by 5. So I get 2, 4. And I can multiply with this 4. I get 8, 16. xy equals 8, 16. So it means that the x equals 8 and the y equals 16. Fine. That's it. All right? So I simplify. I didn't want to multiply this first and carry it up to 40 and 80 and make it big. So I prefer to reduce everything. So I divide by 5 first. First thing I did was divide by 5. Divide by 5. When I divide this side by the 5, I apply it to this. Divide inside is in there by the 5. And I didn't want to make it bigger first. That is it. Next question. Next question is on the next page. All right. Down here. Some vectors now, guys. Vectors. Speak and fast. Vectors. All right. I think we'll take the break after the vectors. All right. Yes. 12 past 12. We're going to 1 hour. 1 hour. Coming to 1 hour. We'll take the break after. I think we'll take the break after the vectors. A short break. A 5 minutes break. This one tells us that P is this. P is that. And Q is this one. And I want us to work this out. So let's write what it is. It becomes equal to minus the 3, 2 minus 2 times the minus 1, 4. That's what we're working with. So care for the negative sign. Apply the negative on this. I get negative 3, negative 2 minus. I'm going to leave the minus and just apply the 2 alone. I'm going to apply the 2 alone to this one. I'm leaving the minus. Notice I'm leaving the minus, guys. So it means that I'm applying the 2 alone to this. But I'm leaving the minus. Careful now. So I get minus 2, 8. I'm going to apply the 2 alone. So it's like I'm working with the 2q, which is 2 times this. All right? Careful. And then now I'm putting negative 3 minus minus is plus. Let's put one result now. So it's negative 3 plus 2 and negative 2 minus 8. That's what it becomes. Negative 3, this minus minus becomes a plus that I have here. And then it is negative 2 and minus 8. What is work out to? This work out to negative 1, negative 10. Negative 1, negative 10, the last answer. So just some negatives to be careful with, guys. Careful with the negatives in this question. All right? Next question, there are a number of them like this. This one gives us P and Q again, but now they just want P minus Q. So P minus Q basically becomes 3, 7 minus negative 2, 5 equal. It's minus minus is a plus. So you get 3 plus 2 and then 7 minus 5. 7 minus 5. So the answer is 5, 2. 5, 2 right here. Nice and easy, quick and fast. Next one. More maths equals better maths every time. Now we're subtracting 2q. So this becomes, the P is 3, 2. 3, 2 minus 2q. So what I can do, I can just double this one time. I can just double this one time for 2q. So 2q becomes minus 2, 8. If you write this as 2q, that's P minus 2q now. The same thing again. Minus minus here is a plus. So you get 3 plus 2 and 2 minus 8. So that becomes 5 negative 6. You see all the answers different. Similar questions, different values, different answers. 5 minus 6. 5 negative 6, the last one. Easy. All right? Easy. So those are just some vector algebra, right? Here now. So here now is a real vector question. And it's a vector parallelogram. Vector parallelograms are very easy. Let me tell you why. Because whatever vector this side is, this side over here is the exact same vector, as they are parallel and equal. Similarly, whatever vector this side is, this vector up here is the exact same thing, because they are parallel and equal. That's the beauty about a parallelogram question. And then it's basically just about how you go around the vector from point to point. So let's look what it said. It said, this diagram refers to a parallelogram. In the parallelogram, R is the midpoint of XY. So R is right in the middle of this line, right? So cut it half and half. It says, based on information, what is ZR? So basically, is how do we go from Z to R? So looking at the diagram to see how we go from Z to R. That's this one to this one. Let's look at it. Remember, I know this vector and this vector are the same. Let's write it out. Let's write it out. This vector and this vector are the same. And this vector and this vector is the same, right? And usually the vectors are given in this direction. Up this way and across this way. So those are like our reference direction. You can see that in the answer. See? WY, WZ. WY, WX, WX, WZ. Those are the reference, the primary reference direction are these in this question. All right? WX, WZ. So I can mark it from now. I can mark it from now that this side is also WX. This is also WX. Let's mark it from now. This side is also WX. And since this is the WZ reference side, this side up here is also WZ. We cut half and half, right? So it means that if I zoom it up, right here is half of WZ, and right here is half of WZ. But the answers are expressed in terms of WY. Answers are expressed in terms of WZ and WX. So I need to get all my sides. This is WZ itself, and this is WX itself. So I'm good. The question says, how do I go from Z to R? That's what this means. How do I go from Z to R? That's what vectors is at this level. How do you go from point to point? I want to go from here to here. I can't go straight across here, sir. There's no vector taking me across there. I have to go along the vector directions. So it means I have to come up here so first. I'm going to write it in blue what I need to go. And to come up here so first, and then go right across here so. That's what I need to do. Mute your mic, please. So let's write it out in letters now. To go from Z to R, I have to go Z to Y first, and then go Y to R. And then I have the vectors on it. The ZY is the same as WX. I can just write WX for the ZY, WX. But the Y to Z, watch this now. The Y to Z is in the opposite direction to that half WZ. The Y to Z is in the opposite direction. And vectors in the opposite direction is indicated with a negative sign. So therefore, I'm going to write minus half WZ. So I'm looking for this answer now. And I realized that all the answers were in terms of WX and WZ. So WX minus half WZ. This is the answer right here. Man. Nice and easy. All right? That's it. Next question. There are a number of them like this. Okay, I'll move on. By the time I reach the last one, you must get it. You don't get it fully yet. Same approach for all of them. This one says, this one is a parallelogram. Again, XY is U. Going across here, So right off the bat, I can mark some other vectors. Means that this side is also U, right here. Same direction, it's a parallelogram. So over here is also U. And this is V, but notice it's coming down this way. So this side over here is also V coming down this way. Again, R is the midpoint. So it means that R divides is half and half. So let me zoom it up. Let me zoom it up. So it means that right here is half of the V going down. And here is another half of the V going down. So I put all my direction, I have all my directions on the vector on the diagram now. And what they want me to find? They want me to find double R. How do I go from double R? Just look at the diagram and see how you go from W to R. That's all it is. Going from W to R on the diagram. Starting here and I want to reach here. Easy. I'm going to come across here first. Let's mark it out. I'm going to come across to Z first this way. And then I'm going to go right there. So that's what I'm going to do it. It's not complicated. So I'm going to go from W to Z. And then I'm going to go from Z to R. That's how I'm going to get from W to R. The W to Z is just U. See, it is just U. I'm going to mark that U properly. Let's write it properly. This is just U because it's equal to that one. And this now is minus half V. Why minus? Because I'm going in the opposite direction to the V. So it's minus half V. Put it back in the blue. Minus half V. So this is a minus half V. That is my answer right here. U minus half V. First answer. U minus half V is the answer. You can look at it and know the answers, you know, guys, but I'm just explaining. So that you can, you know, if you don't understand, you can see how we get it. Next one. Similar question. Similar question. Again, it's a parallelogram, so the opposite sides again are equal vectors, right? Boom, bang. EF is K right here. So it means that this side is also K. Let's put it on the diagram right away. Put on the diagram right away. So this side across going this way is also a vector K because it's a parallelogram. Opposite sides are equal and parallel. And then M is going down here. So on this side, M going down this way again is also M. Going that way, M. So those are my vectors. They don't tell me a midpoint in this one. It says EG expressed in terms of A and M. EG. So to from E to G, you know, easy. Let's throw it on the blue. I can come across here, so, and then come down here, so, to go from E to G. That one easy. It's clearly K plus M. K plus M. So answer is K plus M. E to G is E to F and then F to G. So it's K plus M. All right, so this one is the easiest one so far. K plus M. All right, go to F and then go down. That's the only word from E to G. That's what vectors is about this at this level, guys. Looking at the diagram and see how you go from point to point. As easy as that. That's the easy way to do it right now. This one refers to the diagram below. It's a triangle this time. It says L is a midpoint here. So L is a midpoint right here. So. All right, so it divides the side in half. But the only vector direction that we know are these. Those are the vector directions that we know. Notice that they are opposite. So this one flowing up so from Q, and this one flowing this way from Q. So it's almost like Q is our reference. All right. It says QP is A, as you see, and QR is B. You can see. They want us to go from P to L. Let's look at the diagram. How do we go from P to L? Now, PL is clearly, PL is half of PR now. That's the first thing we have to realize. PL is half of PR. And we can go from P to R. Because we go from P to R, we just come across here, so, and then go up here, so. Come across, so, and then go up, so. So it makes sense to find PR first, and then we take half of it. So let's write it out. Let's write it out. So let's write it out. PL is half of PR. That's what I have to recognize first. And how do we go from P to R? Let's write it up here. Go from P to R. Let's write it up here what PR is. I come across here, so I go from P to Q first. And then I go from Q to R. The P to Q is minus A. Why? Because I'm going in the opposite direction to A. So it's negative A. So this is negative A minus A. Then I go up, same correct direction as B. So I go B plus B. And this can be spun around and written as B minus A. It's the same thing, B minus A. So this is B minus A. That is B minus A now. So my answer here becomes half of B minus A. Or same as B minus A over 2. So my answer is this one. B minus A over 2. Half B minus A is the same as B minus A over 2. That is it. Very good. But okay?
Yes, sir.
Beautiful, beautiful, beautiful. Couple more vectors questions here. Couple more. Let's go. More math equals better math. This question now says, you give us this diagram against a triangle, and then R is the midpoint of OL. Again, so the R is the midpoint. So it divides half and half. It says, furthermore, OR is this. So they give us a portion vector of this point. So what it means, you know, if here is this, then all the way up here is twice that, because R is the midpoint. They also gave us OM, which is this side. All right, they gave us that side. So let us write a couple things. Let us write a couple things. So because R is the midpoint of this line, and OR is this, it means that OL is 2 times the OR. OL is 2 times the OR, where the OR is this. I'm going to write what OR is from now. OL is. So OL really then is 2 times this, which is 6A minus 4B. I'm sure I'm going to need it. That's all these questions are. Question is asking for LM. You see it? Asking for LM. Now watch this now. I know OL now, and I know OM. Now I can use a diagram, but I don't need to use a diagram this time. Because I asked him for LM, where I know the position vector of the M and I know the position vector of the L. When you know the position vectors, you can use the formula, the vector equation formula for displacement vector. O times the last minus O times the first. So in this case, LM, I'm going to use the formula that says it is OM minus OL. Because I know the 2 position vectors, it becomes this. Look at it carefully. O times the last, M is the last, minus O times the first, L is the first. OM minus OL, last minus first. OM is this, careful now. So this becomes 2A plus 3B minus OL is this. Put it in a bracket so don't give it away with the negative signs. 6A minus 4B. Let's shift this over a bit. Good. And then you're careful with the negative signs. It is 2A minus 6A. That's a negative 4A now. Like I said, that's the only negative 4A in it. But let's not mark it yet. 2A minus 6A is negative 4A. Then 3B minus a negative 4B. Minus becomes a plus. So it becomes 3B plus 4B. 3B plus 4B is 7B. So we're going to get a plus 7B. Yes. Minus 4A plus 7B is the same as 7B minus 4A, which is this answer right here. All right? When you know the position vectors, you can use the displacement formula. O times the last minus O times the first. Displacement vector. Last minus first. That's what I did. I used the position vector because I had both of them. That's why it was so important to work out OL up here. You could have used the diagram as well. All right? Because I could have looked at the diagram and said, how do I go from L to M? I could say I could come down here so first and then go across there. So. And I could do it that way. Because I have the position vector, let us use the calculation method this time. More math equals better math. Next question up here. Similar, almost the same thing as over here. But they're asking different things. All right? Different things are asking. This question says, let's put on information. Boom, bang. It's a triangle. OLM, R is the midpoint right here. Again, OL and T are midpoints. This is the midpoint of this side of OM. Furthermore, OR is A. So if this is A, then means up here says A. Let's put on the diagram right now. I'm going to put on the arrows as well. So we're going from O to R. So this is A. So this is also A. Put on the information on the diagram. This is B. Going this way, OT is B. And over here also is B. So it means that OM is 2B and OL is 2A. Let's write it out. So based on that information, OL is 2A and OM is 2B. Based on that information. I want us to tell them RM. Well, this one is, I want to know OR to, you know, OR. Remember, OR is A now. So again, because we know the portion vector, what do we know? We know the portion vector. Just show them. We know the portion vector of R. I know the portion vector of M. See there, we know them. So because I know those portion vectors, I can use the formula method. We do it on this two, you know, R to M, you know, which is just minus A plus 2B, you know. Come down here, minus A, and then add 2B. So it's minus A plus 2B. Look at the diagram. So I don't have to use the formula this time. Let's just use the diagram. Because the diagram appears very easy. This is what we're seeing here. So to go from R to M, that's what this is asking. R to M. We're going to come down to O first, this way, which is a minus A. Come down to O first with a minus A. Why minus? Because we go opposite direction to A. And then go at 2B across here. So 2B. So it's minus A plus 2B. That is the answer. Minus A plus 2B. RM. Based on the diagram is minus A and then go 2B. Which is the same as 2B minus A. So we're looking for 2B minus A, which is the first one. Same diagram up here. They want LM now. Same diagram and I want LM. Same thing again. Going from L to M. So it's minus 2A plus 2B this time. We're going from L to M. Let me use a different color so you can see. The diagram shows it as well. To go from L to M, we will come down to O with minus 2A and then go across to M with 2B. So it's minus 2A plus 2B. Minus 2A is ready. Minus 2A. This will be my LM. Based on the diagram, will be minus 2A plus 2B, which can be spun around and written 2B minus 2A. And you can factorize the 2 and get 2 into B minus A. 2 into B minus A. So that's how this one right here. Hope everybody can see that. If they ask that, I could have given the same diagram and ask that. That's why I put it here. All right, beautiful. Next one. All right, so we're ready to take a break. We're going to a different section. We're going to measurements, guys. Solid geometry and solid and plane geometry. A lot of trapezium and area and volume and all of that. We're going to that section next. So we're going to take a quick short break, 5 minutes. I have a lot of work to cover today, so only 5 minutes to take it. Look right here, so you see it. Look. Look right here, so. See? 26 out of 61. We have 61 pages of question to go through. We're just about halfway. We're gonna move faster on the data pages, but you see what we need to get through. 21 or 26 out of 21. That's where we reach. So we can't take too much of a long break. All right. So let's take a little quick break right here. We'll bring up 5 minutes break. 5 minutes. The screen break, right? The break from the screen. 5 minutes we need. We don't need more than 5 minutes. 5 minutes. And we'll start back. All right. Get out of the water, stretch your leg, go to exercise. All right. We'll start back in 5 minutes. We have full 100 persons on the Zoom. If anybody else needs to join, they can go on YouTube. If the Zoom is limited to 100. Anybody else wants to join, then go on YouTube. All right. The Zoom my app is limited to 100. So if anybody wants to join and not getting through, then just tell them to join on YouTube. Channel is my name. See, I'm writing it on the screen. All right, that is it. Graphic K Shaw, that's the channel, name of the channel. And look for the live on there. All right. So I have to make sure I say, guys, you all know that I also teach AdMats and PureMats. My program for AdMats and PureMats will restart in September. Usually have very limited space, so if anybody interested, you need to get in touch early if you want to join that program. AdMats and PureMats. And the CSEC program will restart September as well.
Sir,
Yes?
sir, you could provide us with your number?
Oh. My number is 881-5600. All right, 876 area code. 876.
Sir, good morning.
Morning.
How can I get this paper with the solution as well?
This paper, the solution.
Yes, sir.
Message me afterwards. I'm not really so keen to reply to this paper just yet.
Okay. All right, thanks.
Yeah. All right, guys, let us continue. All right. All right, so we're going into some cylinders and so on now. So I know that the volume of a cylinder is pi r squared each, area of a circle is pi r squared, and so on, right? So we're going on the premise that we know those things. I might write it once or twice, but then subsequent to that, moving right through. Remember, we're working with radius. So if they give it the diameter, we need to put down what the radius is. The formula that we use are always radius. But as you can see in this question, they give us diameter. Let's read. It says, item 31 refers to the following diagram, which shows a cylinder of diameter 6 and height 20. What is the volume? So first I'm going to write down the radius is 3. So I don't make any mistake. The height is 20. The volume is pi r squared h. The volume is the area of the base, pi r squared times the perpendicular height. So the volume is pi r squared h. I think the formula would be on the formula sheet. So the volume is pi r squared h. If you notice, they tend to leave the answer in terms of pi. They're not working out the pi because it has a calculator. So it says in terms of pi, but they left off the pi. So this really should be 60 pi, 120 pi, 180 pi, and 720 pi in terms of pi. All right? So remember the radius is 3. So this becomes pi times 3 squared times 20. 3 squared is 9. 9 times 20 is 180. So it becomes 180 pi. So the answer is C right here. Quick and fast, nice and easy, moving right along. Another one. This time they give us the radius and the height is 8. So the diagram above not drawn to scale shows a cylinder of radius 3 and height 8. What is the volume? See, they give it in terms of pi now. Same formula again. Volume is just simply pi r squared h again. So it's pi times, this time the radius is given as 3 times the height of 8. This becomes 9. 9 times 8 is 72. This becomes 72 pi. 72 pi centimeters cubed. Done. Next question. More of the same. This one says a cylinder. So in this one now, they give a cylinder again. And the diameter is 6 and the height is 8 this time. They don't tell us what the height is this time. This time they tell us what the volume is. So basically it's a reversal of this question. This is a reversal of that question. So the height is 20, but the reverse the question. See? They give the volume this time and you have to find the height. So it's a reversal of the question. Again, we're going to work in radius. So we're not changing anything. The radius is 3 centimeters. The height is h. We're not going to have to write it. The height is h. But this time they give us the volume. The volume is 180. The volume is 180 pi. We're going to approach it. We're going to say the volume still is pi r squared h. Put in what you know. The volume is 180 pi. So therefore 180 pi equals pi times the radius is 3 squared times the height that you don't know, h. Right? So the pi's will cancel each other. And you end up with getting 180 equals 9, because the 3 squared is 9, 9h. If you divide by the 9, you're going to get the h equals 20. Because 18 divided by 9 is 2. So it's the same question, but they have reversed the requirement. All right, this one now, easy question. 1 millimeter is 1 over 1,000 meters. What is 2,500 millimeters? So it is almost as if they have multiplied this side by 2,500. So we multiply this by 2,500. So when we replace this one with 2,500, that replace this one also with 2,500. As simple as that. So the result becomes 2,500 divided by 1,000. That's what it becomes. 2,500 divided by 1,000. Move this 1.3 place to the left. 1, 2, 3. Answer is 2.5. 2.5. Simple as that. I just divide this by 1,000. All right? Simple. All right. Maybe too much work. Not necessary. How many kilograms are there in 1 ton? 1,000 kilograms is equivalent to 1 ton. That is information that you have to know. So it's 1,000. 1,000 is the answer. 1,000 kilograms make a ton. Okay? Simple as that. That's like a free question. Easy. That's just knowledge based. Done. Next question. Moving. Trapezium now. Remember, area of a trapezium is half the sum of the parallel sides multiplied by the perpendicular distance between the parallel sides. All right. So these are the parallel sides right now. And this is the perpendicular distance between them. It has to be perpendicular. So for example, you could not use this. You could not use this. It has to be the perpendicular, like this distance. Perpendicular distance between them you have to use. Half the sum of the parallel sides times the distance between them, perpendicular. Let me put some letters on this so we can reference it. So let's say that up here so is A, and let's say down here so is B, and let's say the height is H. H. The area is half the sum of the parallel sides, A plus B, half the sum of them, multiplied by the height between them, the perpendicular distance between them. That's it. That's the formula. So applying that formula. So in this case then, the area becomes equal to, let's work it out, half. The A is 8 plus the B is 18 and the height is 5. The height is 5. That's what they're working on. This becomes, half of these becomes 4 plus 9 times 5. I do half of each of those. This is equal to 13 times 5. 13 times 5 is about 65. This equals 65. So the answer is 65. Right? Nice and easy. Let's make this a little smaller. Out the way. All right, beautiful. Next one. See, I put all the trapezium questions together. Now give us the trapezium again, and then say what is the area. So what are the sides you have to use? You have to use the parallel sides. Let's call this A again, and this one B. And then we use a perpendicular height. See? Perpendicular distance between them. I have to use that. So that is our H. Right? So the formula again is half. The area is half the A plus B parallel sides and the distance between them. So it becomes equal to half. The A is 12, the B is 8, and the distance between them is 3. This right here, so is 20. Half of 20 is 10 times 3. 10 times 3. Half of 20 is 10. This is 10. This becomes 10 times the 3 out here. That is 30. 30 centimeters squared right here. This is the answer, 30. Nice and easy. Moving right along. Next question, please. Right here. So this one now, they're trying to trick you. So they want it in millimeters. The trapezium in millimeters. The perimeter they want to know. Oh, the perimeter, but they want it in millimeters. But they give you these distances in meters. So what you have to know is the perimeter they want distance. The distance around, say perimeter, not area. I'm not sure the one says here they want. For these. So we're working with like here. See area. Area. Good. So those are all area, right? Not perimeter. Good. Just making sure. No, but you know they want perimeter. So the perimeter, the distance around. So you have to add up all these sides. But they gave them to us in meters and they want to answer in millimeters. So what I'm gonna do, I'm gonna change them to millimeters one time. I kind of easy, you know. Go from millimeter, go from meter to millimeter, I multiply by 1,000. 1,000 millimeters make a meter. All right. So this side, let's put on the sides in millimeter. I could just write it, but I'm just doing it for the work. Multiply this by 1,000, you get 180. This one is going to become 210 millimeter. Let's write the millimeter beside it. Millimeter. Multiply by 1,000. This one is going to become 410 millimeter. This one is going to become 120 millimeter. So you're adding up all those values for the perimeter. All right, let's do it up over here. And just add them up. You can't use a calculator now, so you have to add them up. So it's going to be 410 up the top, plus 120, plus 180. This down here says 180. plus 210. Plus 210. Adding up those. All of these are up to 0. This one is at 10 and 2, 12 in the middle there. So carry 1. These are 5, 6, 7, 7, 2, 9. 9. Is that answer there? Yep, right here. 920 millimeters. Very good. 920 millimeters. But all right to that?
Yes, sir.
Beautiful. Next question. Beautiful. Look at this one now. So this one now they gave us these 4 diagrams, and I want us to say which one of them is the area. That's what it is now. Which of the following figures not drawn to scale is the area equal to this? Remember, the area is half the sum of the parallel sides times the perpendicular distance between the parallel sides. The key is the perpendicular distance, guys. Has to be perpendicular. The H. All right? Let's write it out with the A and the B. So remember, this has to match the formula. Half A plus B, the parallel sides, times the perpendicular distance. Remember now that the H has to be perpendicular to the 2 sides. It's not just a distance between them, it's a perpendicular distance between them. So you're looking for that now. You want the A and the B to be 5 and 4 first. The parallel side must be 5 and 4. Good? That's what you're looking for. 5 and 4. Parallel side must be 5 and 4. So we can X them out as we go. The process of elimination. This is 3 and 4. That's not 5 and 4. Can't be that one. This one is 5 and 4. What this one now? This is not the perpendicular distance between them. This is why this one is wrong. You want this distance perpendicular. All right? You want that distance. You don't want no slant distance. This one makes it wrong because you want you want the 5 and the 4. Right? This one now, this is the perpendicular distance between them. But based on this formula, the perpendicular distance between them is 2. This is not 2. So this can't be it either. So even though this is okay, the distance between them right there, so it's not 2. Perpendicular distance between them has to be 2. So this right, and this right. So this is the A, this is the B, this is the H. So this one is the answer. The last one. Imagine that. The last one. But okay with that?
Yes,
But okay?
sir.
Yes,
What
sir.
is that? That is a yes? Beautiful. Beautiful. Let's move on. Another trapezium question. They like trapezium. They like it. This one says, they give us a trapezium to the parallel sides here clearly, and the perpendicular distance between them is h. Do they want us to find h? No. They said the trapezium with a height of h as an area of x squared. So this one similar to what they gave us. They gave us a rectangle earlier. It says the equation may be written, the equation that may be used to find x. So it's the same thing again. So we're going to use the formula again for area of a trapezium. Half a plus b times the perpendicular distance between them. Let's put them on. So this is our a, this is our b, and this is the h clearly. So you're looking for that, guys, and then tell us that it equals to x squared, right? The area is x squared. That's what they said. The area is x squared. All right, let's put down what this is supposed to be now. So it's supposed to be half of 2 plus this now, which would be x minus 4, would be the b, and there times the h, and that must equal x squared. Let this shift this over. I want it to go over there. All right, that's what we're looking for. That's what we are looking for. What inside is a work out? I've got to clearly consolidate. Let's see what to work out. We're gonna get half bracket. Gonna get x minus 2 because we're gonna have 2 minus 4 is negative 2. This x comes back right here. All right, times the h equals x squared. So notice that x squared as a subject. So we are really looking for this over here. That's what we're looking for. And it is the first one. See there? Half h. Half h. Because we put those two together. We put this and this together. You get a half h. You get half h, which is h over 2. X minus 2 inside here. So x minus 2 equals the x squared. So this and this is the same. That is the answer. I think all of these questions, the A was the answer. Wow. Let's make sure. Let's check them and make sure. Yep, that is it. But I agree that is it. But I agree.
Yes, sir.
All right, beautiful. Move on. All right, now come to this now. This question says, refers to the diagram, which is a square and a rectangle. Which of the following statement is true about the perimeter of the square and the rectangle? Perimeter, now remember, the perimeter is the distance around it. All right, so which one of them greater? So they talk about which one equal, which one greater, which one greater, which one equal. All right, so kind of easy, you know. So if these two sides are up to 24, right? These two sides are up to 24. Them two over here are up to 24 too now. So right here, so we have 24 so far. But right here, so we have 25, 16 and 9, 25. Those two are up to 20. So this one must have a greater perimeter. So B has a greater perimeter, but I can see that. So the perimeter of A is less than the perimeter of B. Because these two sides, the perimeter of this one is gonna be 48. 48. The perimeter of this one is gonna be 48 centimeters. Perimeter over here is gonna be 50 centimeters. 50 is greater than 48. So that is it. So it's the last one. Perimeter of B is greater than the perimeter of A. The perimeter of A is less than the perimeter of B. Answer is this one. I don't have to explain this no more, guys. This one clear, right? This one clear, good?
Yes, sir.
All right, next one. This one says, all right, that's some nice question. This one says in which of the following polygons does the sum of the measure of the interior angles equal the sum of the measure of the exterior angles? Now listen now, for those who don't know. The sum of the exterior angles of any polygon will always be 360 degrees. Whether it's a triangle, a quadrilateral, a pentagon, a hexagon, no matter. The total exterior angle of any polygon, all if it have 1,000 sides, the sum of the exterior angle will always be 360 degrees. So the question is, which quadrilateral has an interior angles that add up to 360? Quadrilateral. So the answer for this is a quadrilateral. When I understand that, the exterior angles of any polygon will be 360 degrees. Let me write it here. Right here, sir. The sum of the, let me just write EXT, exterior angles of any polygon is 360 degrees. It don't matter number side. Regardless, I must specify, regardless of the number of sides. So no matter how many sides it has, in a triangle, total exterior angle is 360, even for a triangle. So total interior angle of a triangle is 180, but the total exterior angle of a triangle is 360. And how you get an exterior angle? That's for information. So for example, if I were to draw it right here and draw one triangle right here, so for example, let's draw a triangle like this. How you get an exterior angle? You get an exterior angle when you extend one of the sides and complete the angle with the adjacent side. That's an exterior angle right here. And if you get the next one, let's call this one A. If you get the next one up here and extend this one now and complete the angle with the adjacent one to it, let's call that one B. And if you take this one and extend it and complete the angle with the adjacent one to it, call that one C. Those three angles will add up to 360 degrees. Let me shift this down and write it. More maths equals better maths every time. More things you know, the better. Where does this come from? Don't even know where that comes from. Some of exterior angle and a polygon. I don't know. But I can write now that A plus B plus C will add up to 360 degrees. Even though the three angles in here will add up to 180 degrees. And we can write it as well. Let's write it anyway. For the triangle, let's write it. Let's call these angles X, Y, and Z. These are the interior angles. They will add up to 180, even though it's a triangle. So X plus Y plus Z will be 180 degrees. I won't go any further than that. You can prove it, but let's leave it there. Just remember, any polygon, total exterior angle is 360. Yes?
Sir, somebody was asking, so what's the interior angle of a hexagon and a pentagon, I think?
What's the interior angle for
Yes,
any
sir.
polygon? All right, let's tell you. Let's say the total interior angle of any polygon is n minus 2 triangles. Just remember, n minus 2 triangles. A polygon can be broken down into n minus 2 triangles. A polygon, total interior angle, total interior angle of a polygon with n sides, and if it has n sides, it's also going to have n angles. The number of sides will be equal to the number of angles. Is n minus 2 triangles. N minus 2 triangles. Remember this. N minus 2 triangles. That's what a polygon can be broken down. And each triangle is 180. So that is, so we can say i.e. that is n minus 2 times 180 degrees. Because each triangle is 180. Let me show you a quick example. So if you have a, if you have any polygon, like so. So we have this. The polygon can be broken down into n minus 2 triangles. So we break it down into triangles. So if I start at one vertex and draw a triangle across here, or draw a line across there, and then draw another one across here, I have 3 triangles. 1, 2, 3 triangles. Each of those triangles is 180. How many sides is have? 1, 2, 3, 4, 5. See, I got 3 triangles. So I got 3 triangles because it is 5 minus 2 triangles. 3 triangles. I got. And each triangle is 180. So the total interior angle of that to be 3 times 180 degrees. Because each of the triangles have a total interior angle of 180. So this is just an example. This is just an example. This is just an example. Example. E.g. for example. Example. E.g. This is just an example right here, guys. So it don't matter the number of sides. It can be broken down into n minus 2 triangles. N is the number of sides. So if it's 6 sides, it's 6 minus 2 times 180. If it's 7 sides, 7 minus 2 times 180. Just remember, n minus 2 triangles. This is the term to remember. A polygon can be broken down into n minus 2 triangles. Remember this. And you can't go wrong. And each triangle is 180 degrees. So you can't forget. N minus 2 times 180 is the formula for the total interior angle of any polygon. All right. That is that. Look at this one now. I'm going to need to make this smaller as I'm running out of space to do the question. So let me make that a little smaller right there. Good. So this is information, right? Based on the question that somebody asked. Just spending some time on this one. This one says, if each of the interior angle of a regular polygon is 60 degrees, then the polygon is a what? In other words, what polygon is it? They gave us the exterior angle, you know. The total must be 360, don't it? And it is regular. What regular mean? What's a regular polygon? What do you mean by the word regular? What's a regular polygon?
It must contain 180 degrees in the interior angle.
Nope. Regular means all sides equal, all angles equal. When it is regular, all sides equal, all angles equal. Like a regular quadrilateral is a square. A regular triangle is an equilateral triangle. So when all sides equal and all angles equal, the term that they use is regular. That's what regular means when it comes to polygon. All sides equal in length, all interior angles equal, all exterior angles equal. So because this one is regular and they equal 60 degrees, it means that all of them equal 60 degrees. Now let's say the polygon has n sides. We don't know what it is. We're gonna say it has n sides. It has n sides. We don't know what it is, you know. We're gonna say it has n sides. The beauty about this question that they gave us the exterior angle, I will know that the total exterior angle is 360. So all it means, therefore, is that 60 times n, or n times 60, whichever way you want to put it. 60 times n, let me write it out. The total exterior angle is 360, let me write it. Total exterior angle is 360, write it in purple. Total exterior angle equals 360 degrees. That's the premise on what you're gonna, that's the premise on which we're gonna solve this question. All right. Total exterior angle is 360. The total exterior angle is n times 60 because it is regular. It has n sides, so it has n angles. The number of sides and the number of angles is the same. And because it is regular, all of them equal 60. N sides. N sides. So it simply means that 60 times n, 60 degrees times n is equal to 360 degrees. But understand that? So n equals 6. So it's a hexagon. So the answer is a hexagon now. Hexagon. N equals 6 means that we have a hexagon. You understand this calculation, guys? It's quite simple, you know. You understand it?
Yes, sir.
Yes, sir.
Based on the premise, it's on the premise that one is regular, so all of the angles are the same, all of the sides are the same. So them tell us, so one of them are 60, all of them are 60. And it's n of them you have. And because the total exterior angle is 360, it simply means that 60 degrees multiplied by the number of angles must equal 360. And that tells us that each of them must be 6. It must be 6 sides. 6 sides we have. All right. Enough time spent on this one. Let's move on. If the sum of the interior angle of a polygon is 4 right angles, 4 right angles simply means 4 times 90 degrees, you know, which is 360 degrees. So it must be that we have a quadrilateral, don't it? Because it's a quadrilateral that has a total interior angle of 360, don't it? Agreed? The polygon is a quadrilateral. Because the total interior angle of a quadrilateral is 360. 360 is the total interior angle of a quadrilateral. 4 right angles is 360. All right, enough explanation. Let's go. Next question. All right, we'll come to some circular measures. Circular measures. Let's go. This one says, if the circumference of the circle is 15, then the length of the minor arc AB is what? Now remember, the arc is a fraction of the circumference. The arc, this arc is just a fraction of the circumference. What fraction? You can take the fraction by taking the angle out of the 360. The total angle of the circle is 360. So we're taking the 120 out of the 360 as the fraction. So the arc is a fraction of the circumference. So this arc right here, because it is subtended with the angle of 360 of 120, we are looking at it as, say, the length of the arc AB. Arc AB is equal to the fraction as 120 over 360. That's a fraction times the circumference. We're not going to write the 2 pi r this time. Let's write the circumference. C for circumference. Circumference is normally 2 pi r. Circumference is normally 2 pi r. We're not going to work out the circumference this time. Why? Because they told me what the circumference is. Right? They told me that the circumference is 15. So this then becomes 120 over 360 times 15. I would have to work it out. The answer is there. Where is it? See it right here, so B is the answer. Fraction of the circumference. The arc is a fraction of the circumference. So if you know the circumference, you just take the fraction. What fraction? The fraction taken from the angle that subtends the arc over 360. Because the 360 degrees is what covers the entire circumference. It's like a ratio. All right. Same thing happens for area. The area of a sector is a fraction of the area of the circle. What is the fraction? The sector angle out of the 360. It is 360 that covers the full circle. 360 degrees that covers the full circle. This next question says, boom, bang. It's a sector OAB such that the angle is 60 degrees right here that you can see. Sector angle is 60 degrees and the radius is R. So they're giving us in terms of letter. What is the area? Fraction of the circumference. Fraction of the area, sorry. Fraction of the area. Area of the sector is a fraction of the area of the circle. What's the fraction? The fraction is 60 out of 360 times the area of the circle. What's the area of the circle? Pi r squared. 60 over 360 is 1 over 6. I divide it by 60, you get 1 divided by 60, you get 6. So it's 1 over 6 times pi r squared. This is a fraction of the circle that the sector is. So it's 1 over 6 pi r squared. The first one, so the square there. 1 over 6 pi r squared is the answer. Easy. Spending too much time on these things. Easy. Next one. This one says, they give us this diagram again. It says if the length of the minor arc is 8, so they tell us that minor arc now. This arc is 8 centimeters. Remember that 8 is a fraction of a circumference. Then what is the length? Then what is the length of the circumference? Easy. Remember now, this 8 is a fraction of the circumference and asking us for the circumference, all right? So let's set up this way. The arc is a fraction. What fraction? 60 degrees. 60 degrees over 360 times the circumference. C for circumference. So this arc, which is 8, so we can put it now. So we can say, therefore, 8 equals, this 60 over 360 is 1/6 times the circumference. So multiply by 6 here, so the circumference equals 6 times 8 is 48. Circumference is 48 centimeters. Right here, 48.
Sir, times the 8?
Yes, multiply it over here.
Oh, so correct.
Multiply this over here. Yeah, man. Multiply it over there. All right. Just remember, the arc is a fraction of the circumference, and you get the fraction through the angle out of 360. Next one. The area of a triangle is 30, and its base is 10. What is the height? Similar question over here. The area of a triangle is 60 and the base is 12. What is the height? See, same question, different numbers. So how are you going to set it up? The area is normally half base times height. You want the height, right? So we can put in the values, you know. Put in the value, because I said the base is 10. So the 30, which is the area, is equal to half the base, which is 10, times the height. This becomes a 5. So 30 equals 5 times h. Divide by the 5. You see that the h equals 6. So the first one, the answer, h equals 6. Same calculation over here. Same thing. The area, we put it in red. You know that the area is always half base times height. You give it the area is 60, put it here so for the 60 equals half. They give it the base is 12, you put it here so for the base 12 times the height. Half of the 12 is 6, so 60 equals 6h. Divide by the 6, h equals 10. So the height is 10 centimeters. Nice and easy, 10 centimeters. Done. All right? We need to. More questions. This one gives us this diagram is a circle and then pull out the sector. This is a major arc, the big one, and this is a minor arc, the small one. The sector angle is 60 degrees. So it means around here, so right off the bat, if you want the major arc, it's 300 degrees. 300 degrees. Angle subtended, the major arc is 300 degrees. The total angle is 360. Let's see what they want us to do. They say if the area of the minor sector is 103, so they're telling us the area inside this. Then what is the area of the circle? Remember, so this one was an area one now there. Sector is a fraction of the circle. What is the area of the circle? The area of the sector is a fraction of the circle. So we can set up like this. The area of the sector is a fraction, which is 60 over 360 times the area of the circle. Let me put area of sector right here. So the area of the sector, S for sector, is a fraction of the area of the circle. We're trying to find the area of the circle. This is 1/6, and this is 103. That's what I told you, 103. So 103 is equal to 1/6 times the area of the circle. Multiply the 6 across there, so you get 618. So the area of the circle is 6 times that, 618. So then says this one. But I understand that working out. But I understand that. Want to make sure. All right, up here so now. In the same diagram, they tell us now the length of the major arc is 40. So they're giving us the length of the side over here, so the major arc is 40. Same diagram now. What is the circumference? Same thing. Even though the major arc is still a fraction of the circle. But that angle now that subtends the major arc is 300 degrees. All right? So let's set up again. The arc is built in red. The arc equals arc. The major arc this time. The arc is a fraction of the circumference. The fraction this time is 300 over 360. So it is 300 that is subtending that arc, right? Because that arc is 40 now. Times the circumference. I'm using C as the circumference. The arc, they tell us, is 40. So plug in the values. 40 equals, now see this? This is 5/6, you know. 5/6 of the circle. If 60 degrees is 1/6, then 300 degrees is 5/6. So I can divide this by 60 and divide by 60, you get 5/6. So this is 5/6 of the circle times the circumference. That's what we're solving.
180.
Mute your mic, please. Mute your mic. Mute your mic, please. That's going to be 48, you know. Mute your mic, please. Mute your mic. You can divide both sides by 5 and that becomes 8. If you divide both sides by 5, this becomes 8. 40 divided by 5 is 8. So you're going to get 8 equals 1/6 times C. You multiply the 8, you get C equals 48, just to see it. So the answer is 48. Right there. Okay. Hope everybody gets that. All right. Finito. More. This one says, so we're going to some other questions now. This one says, if it took a speedboat 9 hours to travel a distance of 108 kilometers, what was its average speed? Simple. Speed equal distance traveled over time taken, because it's average or what? So the average speed equal the distance is 108 divided by 9. Yes, this into this goes 12. So the speed is 120 kilometers per hour. So 120 right here. Okay, good. Nice and easy. Next one. So the length of the side of a triangle are x, 2x, and 2x centimeters. If the perimeter is 20, what is the value of 2x? That means that x plus 2x equals 20. This is 5x equals 20 divided by 5, x equals 4. quick and fast, nice and easy. The perimeter of the distance around it, x plus 2x plus 2x equals 20. So you set up like an equation and solve. Done. Moving on. Those questions very easy. This one says, a square has the same area as a rectangle with size 9 by 16. A square has the same area of a rectangle, 9 by 16. What is the length of the side of a square? So if we call the square x, then they have the same area, right? So if the square is x and the rectangle is 9 by 16, the area is the same. So the area of this one is x squared equals the area of this one is 9 times 16. And that's why I multiply it up and up. The x is going to be equal to the square root of 9 times 16. The square root of the 9 is 3. The square root of the 16 is 4. That equals 12. Simple as that. So the length of a side is 12. Right here. Nice and easy, quick and fast. All right? The area is the same. So don't multiply this and make it complicated. Or square root it. All right? The square root of the 9 is 3, square root of the 4 is 12. Next one. A square has the same perimeter now. So a while ago we did same area. Bang. Now we're doing perimeter. As a rectangle with a length of 15 and 11. 15 and 11. What is the area? So we sketch it again, quick and fast. Call this x again, but it's perimeter now, so we're gonna go for the 4x. And the rectangle is, we're gonna put it as 11 by 15 and 15 and 11. And we have the same perimeter, so it means a 4x equals the sum of everything over here. So now these two add up to 26. So it's 2 times 26, which is 52. That's all? 52. Don't it? So what is the area of the square? 52. So we need to find x. 52. So this divided by that is what? 13. So x equals 13. So we want the area. So from this, the area is the area that I want. Is x squared, which is 13 squared, which is 169. 169. But understand that? But go to that. This perimeter is 52. Huh?
No, sir. I don't understand.
Listen, no, I don't understand. I'm going to look slower. I'm going to look slower since I don't understand. Let me go a little slower. Let's go a little slower this time. Let's go a little slower. You understand this diagram that I draw?
Yes,
So the
sir.
perimeter is the same. So I'm representing this as my square. Make all the sides be x, right? They want me to find the area and the area they want to know, not the perimeter. The area of the square, right?
Yes, sir.
This is my rectangle now. It says 15 by 11. So I'm going to draw it up like this. And so the perimeter is the same. So I'm going to add up all of this. This one is at 30. And this one is at 22. That add up to 52. So the distance across right around is 52. Can you see that?
Yes, sir.
So the perimeter of the rectangle is 52 and the perimeter of the square is 4x. So it means that 4x equals 52. You see that?
Yes, sir.
So to find the x, I'm going to divide by 4. Right? One can carry down gradually. You can divide by 2 first and get 2x equals, what is going to work out to 26. And divide by 2 again and get x equals 13. See that?
Yes,
So
sir.
the length of a square is 13, but what is the area of a square? X times x, which is x squared. So now that I know this, it means that the area of the square is x squared, x times x, which is equal to 13 squared. And you must know that 13 squared is 169. You must know that. A 13 squared is 169. 169. 169.
Okay, no mistake.
Beautiful. That's what we want. Beautiful. All right, next question. It says the circumference of a circle is 154. That'll give us a circumference. Pi is 22 over 7. What is the radius? They want the radius. They tell us the circumference now. The circumference is 2 pi r, you know, full circle, you know. So we know that 2 pi r equals this figure, 154. I'm trying to find the r. They tell us that this is 22, so it becomes 2 times 22 over 7 times r equals 154. So canceling this down now. We just need to cancel this down and find out what the r is. Cancel it down. So we can do 2 into this first and 2 into this side. That way I multiply it up and put 44 and make it more complicated. I prefer to cancel down. Cancel it down. Cancel it down gradually. Don't multiply it up and making it more complicated. So this divided by 2 is how much? This divided by 2 is how much? I'm divided by the 2 first.
11.
No man, over here so. This divided by 2. I divide this 2 and this 2. How much may I get?
78.
77.
27 over 2 times r equals 77. Then we'll divide by 11 now, right? Divide by 11, we shift over this. I remember, you know, we can't use a calculator and I must always be mindful that we cannot use a calculator. So we learn how to cancel it down. This can be divided by 11 and this can be divided by 11, right? So we divide this by 11, we get 2 over 7, r equals, this becomes 7. We divide by 11, right? We put what I did. So here, clearly we divide by 2. Here, now I divide by 11 to go from this to this. Divide by 11. And then all I have to do now, the answer is not going to be exact. Multiply by 7 and divide under 2. Multiply by 7 and divide under the 2. So from this, the r is going to be 7 times 7 divided by 2. That's 49 over 2. So it's not going to be an exact answer, so it has to be this one. But I have a half in it. What about that? But okay? All right, take that to mean a yes. Next question says, the distance around a lake is 8 kilometers. On a map, this distance around the lake is represented with a length of 2 centimeters. What is the scale? The scale of the map is what? Simple. Scale of the map. So this side is represent the map, and this side represent the land. That's how scale is written, right? Map the land. So let's write it out this way. So it's 2 centimeters to 8 kilometers. That's what we're giving. That's the ratio. I want to bring this ratio down to one of these. Has to be that one here. Has to be that one. First, we're going to divide by the numbers. Remember, a ratio can be multiplied or divided by any constant value or any constant unit of measure. So since this is in centimeters and this is in kilometers, I want to bring this side to centimeters. So I can divide it out. All right, so I'll divide by the 2 first. So I'm going to get 1 centimeter to 4 kilometers. I want to bring the kilometers to centimeters. Now, firstly, 1 kilometer is 1,000 meters. So it's 1 centimeters to 4,000 meters. Or 1 kilometer is 1,000. And then 1 meter is 100 centimeters. 1 meter is 100 centimeters. 1 meter is 100 centimeters. Centimeter means 100 times. So it means that 1 centimeter is 4,100. Put on the 2 zeros for the 100, for the meters. Right? Centimeters. And then we can divide both sides by the centimeter. Bang, bang. And so you get this answer, 400,000. 1 to 400,000. So the answer becomes 1 to 400,000, which is this one. Could have known from the beginning, but so work it out. All right, so you get 1 to 400,000. 1 to 400,000 is the ratio. All right, nice question. We want to reach halfway now, guys. Jesus, we want to reach halfway of the papers. That is it. I'm proposing that we stop at the time we're supposed to stop and have another session later this evening. I'm proposing that from now. So have another session later on this evening. Take like a 2 hours break and I'll come back and finish off the same. I don't want to do it tomorrow. I feel that people need time to look over and stuff. So I'm proposing that from now. You can contemplate it. All right? Stop when the time comes, and like 2 hours or so, and then take a 2-hour break and start back another session to finish it off. But let's see how quickly we can move. I will just reach halfway in terms of the pages. A lot of questions. 600 questions I want to do. This question says, distance around the edge of a circular pond is 88. What is the radius? Set up a formula. Distance around it is the circumference. So basically what they're saying is that 2 pi r equals 88. And I want the radius, they want the r. All right? And so the pi here, they're leaving the pi in the answer. So we're going to divide by the 2 pi. So the r equals 88 over 2 pi, which this answer is right here. Done. Quick and fast, nice and easy. Next question. Area of a rectangle is 53.6. If the length is multiplied by 4 and the width is half, what is the area now? What is the area now? So it's like we have an area of a rectangle first. Let's draw it like this. Let's put it on a diagram so we can visualize it. So it's like we have a rectangle. Let's write here. And it has a length and a width. And for this rectangle, the length times the width, they tell us is this, 53.6. Then now, they change it. They say the length is multiplied by 4, so they stretch it out, bang. And they cut the width in half, bang. So the new dimension become half the width and 4 times the length. So we're talking about the new area of this one now. So the area of this one becomes, let's call it A, it becomes half W times 4L. So it becomes 2 times LW. Or let's put it that way. Keep it consistent. 4L times half W. 4L times half W. That becomes 2LW. That's what they're getting about. LW from the beginning was this. LW from the beginning was that. So this becomes 2 times LW. So the new area is just 2 times what it was before, 53.6.
Sir, 107.2.
Good. 107.2 cents. Beautiful. That's it. 107.2. Next one. Perimeter of a square is 56. Perimeter of a square is 50. What is the area? It's the same thing. The perimeter is 56. If we call it x, 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 x. It means 4x equals 56. It's the same question we did before, you know, almost, you know. So it means x equals what? 13. I divide by 2 first to get 28. Divide by what? X equals 13. Divide by 2 first, I get 14. 56. X equals 14. If you divide by 2 first, you're going to get 2x equals 28. Divide by 2 again, you're going to get x equals 14. Right, 14. So if the x is 14, that means that the area equals x squared, which is 14 squared, which is 196. Everybody must know the squared numbers up to 15. At least up to 15. All the squared numbers up to 15 you must know. 14 squared is 196. So the answer is this one. 196. All right, done. Next question. The perimeter of a square now is 48. What is the area? So same thing again. Same thing again. This time 4x equals 48. So clearly x equals 12. So the area for this one, same thing as x squared, which is 144 this time. 144. So same question with different ones. Area of a triangle is 60. The base is 12. What is the perpendicular? Oh, do this one already. So repeat. Did this one already. That's a repeat question. Did this one already. Same exact question we did off the top. Not gonna do it again. Not running the time. Done. Next one. We'll come to this question now. This one says, refer to the following diagrams consists of a triangle resting on top of a square. This is a square under here. So it means that this is 7 all around. 7, 7, 7. It says if the total area of the diagram is 63, total area is 63, means that area of the rectangle triangle plus area of the square is 63. What is the value of the h? Height of a triangle. Let's set it up. Let's set it up like an equation. So the total area is 63. So I can set it up this way. Area of square plus area of the triangle equals 63. Total area is 63. What's the area of the square? The area of the square is 7 times 7. 7 times 7 is the area of the square. Sorry. The area of the triangle is half base times height. Half 7 times the height. That equals 63. But good so far?
Yes, sir.
All right. What's the easiest way to solve this now? Trying to find the h. Can divide through by 7. 63 is 9 times 7. I'm going to divide through by 7. Don't multiply it up and always try to simplify it out. So divide everything by 7. Divide this by 7, I'll get 7. Plus divide this by 7, I get half h. Divide this by half h. Here's my h. Divide this by 7, I'm gonna get 9. Here about this 9, 7 subtract it. You get half h equals 2, so h equals 4. Fine, h equals 4. So it's basically write an equation based on information and solve it. That's all, right? Really. All right? That is it. Next question. This one gives us another similar diagram. See? This time it says the length of the sides of a square is 5 and the height is 4. What is the total area? This time they're asking us for the area. So the area of the square, area total is the area of the square plus the area of the triangle. The area of the square is 5 times 5. The area of the triangle is half, the base is 5 times the height is 4. But remember now, since this base is a square, it means that this is 5, this is 5, this is 5. So this base of this triangle is 5. Half base 5 times the height. Don't put the 4 for the height. You know the height is 4. The height is 4, so I'm going to put 4 right here for the height. That's what you're working on, guys. That's what you're working on. So this becomes 25 plus half of the 4 is 2. 2 times 5 is 10. 10. 25 and 10 is 35. So the answer is 35 right here. Easy questions. Easy. Easy. Let's move on. Next one down here. This one says, volume of a cuboid. Volume of a cuboid is 320. The height is 5. If the cuboid has a square base, what is the length of the side of the base? So the base is going to be the square base is area x. So like the base is like this. Right? And you have this piece in there. So the area of the base. So the volume is the area of the base times the height. You know? It's the area of the base times the height of the volume. That's right. The volume equals the area of the base times the height. The volume, the base is x, right? We want to know what x is. So we're going to call it x squared times the height of 5. The height is 5. But this volume, they tell us, is 320. So it means that 5x squared equals 320. So we can say, therefore, 5x squared equals 320. That's what we're solving. So it means that x squared, we're going to divide by the 5. We're going to get, to 64. 64. Is that? No. Divide this by 5 for me. Divide this by 5. 32 divided by 5.
Yes, sir, 64.
So 64, sir.
right?
320 divided by 5, yeah. 64.
All right. So it's my brain. Click a while ago and click off back 64. So if x equals 64, what I want us to tell them the length. So it means the length is 8. Square root of 64, which is 8. My brain clicked on and off a while ago. So it goes sometimes. That's it. All right. Simple as that. Let's move on. At a party, the number of guests were served 15 liters. A number of guests were served 15 liters of champagne. At a party, a number of guests were served 15 liters of champagne. Each guest had 2 glasses of champagne, and each glass held 150 milliliters. No, this is milliliters, this is liters. So they make that distinction right away. Can work in 2 different units at the same time. So we're going to recognize that this 15 liters is actually 15,000 milliliters. 15,000 milliliters. Recognize that before we start. So the total serve was 15,000 milliliters, right? So each guest had 2 glasses, and each glass had 150. So it means that each guest got 300. The 2 times 150. So each guest got 300. Assuming no spillage, how many guests were there? So the number of guests is n. Let's call the number of guests n. Number of guests, we're going to call it n. All right, so each guest got 300 milliliters. Right? Each guest got 300 milliliters, and there are n guests. So it means that 300 times n guests must equal the total that was served, 15,000. But I get that?
Yes, sir.
So n equals 50. N equals 50 if you divide. Divide on this and this. Divide the 150 by 3 get 50. So there are 50.
Sir?
Yes?
So you can explain this again, please?
All right. So first you understand this, right? That the 15 liters is 15,000 milliliters, right? So they're giving us information in liters and milliliters. You can't do the question with 2 different units. So I decided to convert the total to milliliters. So I know what the total syrup is, 15,000. It said each guest had 2 glasses, and each glass had 150. So it means that each guest got 300 milliliters. You understand that? Because each guest had 2 glasses, and each glass was 150. So you multiply them 2 here to know the amount that each guest got. Each guest got 300 milliliters. You have to answer me, I know so I can move on. You know?
Yes, sir.
Good. So the total that each guest got was 300. And we're saying that there were n guests, because we don't know. So we call the number of guests n. So n guests each got 300 milliliters. So this represents the total amount served. And the total amount served is equal to 15,000. That's what they told us. So that becomes our equation that we're solving right here for n. So n is the number of guests. So n equals 50. Understand now?
Yes, sir.
So put the information in equation form. It's mathematics, you know. Put the equation in equation form. Put the information in equation form. That's the best way to do with mathematics, you know. Put it in equation form. What you don't know, you call it something like we call it n. And then you put the information in equation form and solve for what you do. That's it. Another question here, the same question, this, you know. It says 50 guests. Let me get a 50 guests now. 50. 50 guests had 2 glasses. So that's 100 glasses of champagne. Each glass held 150. How many liters, the number 1 liters of champagne was? So the same question really. Right? So how many guests were there? 50 guests. Each had 100 glasses. So each had 2 glasses. So 100 glasses you had. 100 glasses. 50 times 2 is 100 glasses. And each glass had this amount of milliliters. So it's 100 times 150 milliliters.
Sir, no 15, sir. The first one.
That's the amount that was served, which is equal to 15,000 milliliters. Well, 15,000 milliliters is 15 liters, which is what they wanted, liters. So the answer is 50.
Sir, the first one answer the second one.
Yeah, there's 2 questions I say, but you're not going to see put them on the paper. It's going to say one, you might say one or the other, you're not going to see both of them. But I'm not showing you that That's how they are. Sometimes they set questions that are it's the same question, similar question, but asking a different thing, different time. So you might get a question that asking something like this, or you might get a question asking it this way, or the same information reversed, and they're asking it another way. It's based on the same scenario, basically. All right, so that's it. This one says, on leaving Trinidad, the time on a pilot's watch is 23 hours. This means 1 hour before the next day. 23 hours means 1 hour before the next day. When he arrived at his destination in the same time zone on the next day, his watch said 0300 hours. How many hours did he fly? 4 hours. Agreed?
Yes,
4
sir.
hours. 1 hour to midnight plus 3 hours make 4 hours. We don't have to work for that, right? This is 1 hour to midnight, and this is 3 hours after midnight. So it's 4 hours in flight. Good? 4 hours.
Yes, sir.
That no one no calculation. That's straightforward. Everybody know that. An aircraft leaves A at 1600 hours. That's like 4 o'clock in the evening. And arrives at B at 1930. How long it fly for? That's 3.5 hours. From here to here is 3.5 hours, right? Traveling at an average speed of 550 kilometers per hour. From A to B in the same time zone. The distance traveled is what? All right. So first, we know say speed equal distance over time. What do I want? I want distance, right? So therefore, distance equals speed times time. Question is, what is the time? From this, the time is 3.5 hours. I have to give it in hours. From here to here is 3.5 hours. Time is 3.5 hours. And the speed is 550. So this means that the distance at the watch is 550 times 3.5. Which answer is that? So it's 3 of this and then half of it. We're gonna work it out. All right, we can work it out. We're gonna work it out quick without a calculator. Somebody tell me. We're gonna work it out with a calculator quick.
1925, 1925.
Sir D.
We know, but how you gonna work it out? Tell me you're gonna work it out without a calculator. Tell me you're gonna work it out. I want to hear your method. Speak.
Sir, you'd put the 550 at the top, and you're gonna make sure that the 3.5 don't have a decimal until you finish calculate it, and then you put it in the correct decimal place.
I do like this. Something like that.
Yes, sir. No, no, sir. Look, take out the decimal point, and put it like a whole number.
35.
Yeah, 35. I have the 550 at top.
And then what?
Multiply them.
And then you know the decimal point. And then put decimal point one place to the left and done.
Yeah, one place to the left.
All right. I would have multiplied.
Sir, can I try?
Yeah, tell me that. Quick.
Sir, I would 3.5. The 5 means half, so I would find half of 550, which is 275, and add 550 3 times and add everything together.
I like that method. So I'm saying I would do the same. Like I would multiply 3 times the 550 first, and then take half of the 550 and add them. Prefer that way. I'm gonna do it right here. So I'm gonna go and say, I have to work this out in the exam room, right? And you see, the thing is, you can use a process of elimination because it can't be none of these, right? So if you 3 times the 550 past this, then there must be this as the answer, the largest one, right? But I would say 3 times 550 first. 3 times 550 first. But 3 times 550 is 3 times the 500 and 3 times the 50. I'm gonna look at it that way as well, you know. This equals 3 times the 500, 3 times 5 is 15, that's 1500. And then 3 times the 50 is 3 times 5 is 15, right? 150. So I'm adding up this. That's 1650. And then I'm doing half of this. Half of the 500 is 250, and half of the 50 is 25. So it's 0.5 times the 550.
Sir, there's another way too.
There are many ways to do it. So you do the way you're comfortable with. So I'm doing
Sir, if
half
you take
of
out the
500.
zero,
I'm doing half of the 500, which is 250. And then half of the 50 is 25. And this gives me 275. And then I just need to add these two now. Add these two. Add this to this. Add those two. And see that it's gone past the 18. So it must be the last one. Which way you say now? Talk again quickly.
Sir, what I did was take out the zero and move the decimal one place back and then multiply 55 by 35.
Right. You're gonna apply this, zero on the 3.5 and make it become 55 times 35. Yes, you can do that yourself. All right. So whichever way you prefer, you work it. You have to work out something, but it is a process of elimination as well. But that is it, guys. That is it. All right. Let's continue. This one says, a man leaves his home at 22:15. This is quarter past, right? 22:15. That's like 45 minutes to think there, to midnight. And reach destination 4 hours on the following day in the same time zone. How many hours did each other? Let's set it up. So 22:15. You need 45 minutes. 45 minutes.
5 3/4.
Yeah, but we need 45 minutes to reach 23 hours, right? Let's just set it up to reach 23 hours. Then they need 1 hour. They need 5 hours to reach over here to the next day. 5 hours. 5 more hours to reach 0400 the next day. I need 1 hour to reach midnight and then 4 more hours. So yes, it's 5 3/4. This is 3/4 of an hour. This is 3/4 hour. So it's 5 3/4 hour. So that is the answer, 5 3/4 hour. Hope everybody understand that. All right. Many ways to do it. It's not the only way, but good enough. This question says a rectangular garden plot, 15 meters long, 12 meters wide, is used to plant fruits and vegetables. If 80 meters squared of the plot is used to plant vegetables, what area of the plot plants fruits? This guy have to subtract it, right? So you multiply these first to get the total area. So basically it's 15 times 12 minus 80, you calculate it. This is the total area and you subtract that. That's all? But only calculate the 15 times 12. To do this calculation, I'm going to say it is 10 times 15 first is 150. And then 2 times 15 is 30. That gives me 180. So I'm doing 180 minus 80. The answer is 100. So this is my answer. That's my answer. So the total area minus the 80, that's what it is. Total area is 15 times 12. The volume of a cube of edge 6 centimeter is 6 times 6 times 6. That's 216. 36 times 6, 216. Then that one here, volume of a cube of 3 centimeter becomes 3 times 3 times 3. That's 27. This one is 27. Same question, different value. Volume of a cube of edge 10 centimeter is 10 times 10 times 10. That's 1000. Same question. Volume of a cube is always x times x times x. I can say x cubed. Next one. We did this one already. 250 milliliters expressed in meters divided by 1000. You get 2.5. This is the answer. 2.5. We do the one like that already. Same thing here. 3800 millimeters expressed as meters divided by 1000 again. You get 3.8 divided by 1000. I get 3.8. Because you want it in meters, you divide by 1000. Millimeters to meters, you divide by 1000. Same question, different values. Same question, different values. This one. It took us people who do this question already. It's a repeat. This is a repeat. This is a repeat. 9 hours this time. I want this. I think the answer was 120. That we did a while ago. Let's put it as a repeat. So we can take it out the document. This one says no. This one refers to the following diagram, which shows a compound shape made up of a rectangle and 2 identical semicircles, one on either side, either of the short sides. Now this is 27, this is 15, everything symmetrical. I want the perimeter figure, which is the total distance around the figure I want. So since this is 15, this is 27, then 27 minus 15 is how much? 12. So it means that right here so is 6, and right here so is 6, which is the radius. So the radius of this thing is 6. Now this is half of a circle, and this is another half of a circle. Circumference is 2 pi r. So this therefore is just pi r. This is pi r. This is just pi r. And the r is 6. So this equals 6 pi. 6 pi. So over here is also 6 pi. Also 6 pi. All right. You write yourself 15, and write yourself 15. So you have 15 on this side across here, and 15 on this side across here. So the perimeter then becomes 15 plus 15 plus 6 pi plus 6 pi, which is 30 plus 12 pi is the perimeter. They factorize the 6. So you get 6 into 5 plus 2 pi. Factorize 6. 5 plus 2 pi. So the answer is this one right here. 5 plus 2 pi right here. 6 into 5 plus 2 pi. When I start not working out, what go to that?
Yes, sir, where you get the 6, sir? Bracket 5 plus 2 pi.
All right, well, on the overall distance here says 27, right? And
yes, sir.
Inside it says 50, right? 27 minus 15 is 12. So the side here and the side here are up to 12, but them equal. So each of them must be 6. That's the first thing, right?
Yes.
So it means that the 6 is the radius of this semicircle. The radius is 6. Well, the circumference of a full circle is 2 pi r. 2 pi r is the circumference. But this is half of a circle. Therefore, the length of it is just pi r. You understand that?
Yes, sir.
Good. And the r is 6. So length of this side, this arc around here is 6 pi. But over here is the same identical thing, so it's also 6 pi. So the two arcs are 6 pi each. So you have 6 pi and put it in blue. You have 6 pi around here, so around this edge. 6 pi around this edge. 15 on this side and 15 on this side. So you get 2 15s and 2 6 pi's. That gives you the perimeter. But the perimeter is the distance around it. Understand now? Understand now? You okay now? All right, no answer. Let's assume that's a yes.
Oh, yes, sir. I understand it now.
All right, good. Statistics. Moving straight into statistics in again. We're not stopping. It's 2 o'clock now. We're gonna take a little break after the statistics. All right, we reach. Let me see where we reach. Reach page 35 out of 60. We're gonna get some quicker movement near the end. But let's continue. Let's go through the statistics, and then after the statistics, we'll take a break. We have to push it because we're running out of time. All right. Statistics. This one says. It gives us this table, number of books and the number of students, all right? And there are 58 students in this, right? So these are the number of books that the students have. Refers to the following table, which shows the number of books that's bought by students, and number of books bought by 58 students. So this is the data and X, number of books. This is the frequency. So what it's saying is that 9 students bought 3 books. 9 students also bought 4 books. 13 students bought 5 books. That's what it means, right? It says the mode number of books bought, the one with the highest frequency. The mode is the score that matches the highest frequency. These are the scores. These are the frequency. So the mode is a score. The highest frequency is 13. 13 students bought 5 books. So the mode is 5 books. The mode is 5 books. The mode is not 13. The mode is not a frequency. The mode is a score. So you have to look at the data and say, what is your score and what is the frequency? The data is about the number of books bought. So that is your X. The data is about the number of books bought. All right? So the X, that is your X. So and the mode is a score. So the mode is 5. For the same question, I say, what's the median number of books bought? So the median number of books is the number of books in the middle if you put it in ascending order. Right? Number of books bought by the person in the middle. Let's put it that way. All right. So since there were, let me erase this now. Since there were 58 students, like you divide the 58 half and half first. You want to find the students in the middle. So divide the 58 half and half. What are you gonna get? 29 and 29, half and half, right? Half and half. We divide it half and half. So since there's an even number of students, you have to take the average of the two middle values. The two middle values is going to be the 29th one, which is the last one in the first half, and the 30th one. The 30th. So you want the average of the 29th and the 30th. You average them and you put that over 2. So you need to find how many books the 29th person bought and how many books the 30th person bought, and you average them. How do you find that now? The books, in terms of the number of books bought, the data is ascending this way. So you have 9 persons who bought 3 books already. So you're trying to find the 29th person. So add up the persons this way, left to right. You're trying to find the 29th person and the 30th person. You have 9 students here, so who bought 3 books each. They have 18. So by the time you reach here, so you're going 18 students. 18 and 13 make how much? 18 and 13 make 31. So when you finish right here, so you reach 31 students. You're going 31 students already. So you actually passed the 29 and the 30. So it means that in this group you have the 29th student and the 30th student in this group. So the two of them buy 5 books. So basically the mean would be 5 plus 5 over 2. The median, 5 plus 5 over 2. So the median is 5. The two middle values is 5 and 5. So the 29th person bought 5 books, and the 30th person also bought 5 books. 5 books and 5 books. So the median is 5 books. Median is 5 books. You can understand that, guys?
Yes, sir.
Yes, sir.
All right.
Yes, sir.
All right, good. So, all right. We're gonna see it again. Next question. So the following table shows the scores obtained by students in a test. Again, these are the scores, that is the X. These are your frequency. So 8 students scored 2 marks, right? 4 students scored 3 marks. So the data is ascending from left to right. All right. What is the range of the scores? The range of the score is the highest score minus the lowest score, which is 8. The range is 10 minus 2, which is equal to 8. That's the range of the scores. 8. What is the modal score? Score that occurred most frequently. So the most frequent of that's the highest number of persons. That's the highest frequency, I should say, corresponding to 8. So the mode is 8. The modal score is 8. The mode that matches the highest frequency is also 8. So the range is 8, and the mode is also 8. But understand that. Understand that, guys?
Yes, sir.
Mode is a score that matches the highest frequency. That's what the mode is. The one
Yes,
that matches the highest frequency. Good. All right. So the mode is 8. Next question. The median of these numbers is what? Are they in ascending order? First, you have to look at that in ascending order. Yes. How many scores are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the average is 2 middle ones. If you divide the 5 and 5. 1, 2, 3, 4, 5, and 5. And you're going to take the average of the 2 middle values inside here. Average of 6 and 7 is 6.5. So the median is 6.5. What go to that?
Yes, sir.
Next one. It refers to the following scores obtained by 11 students in a competition. These are not in ascending order. What is the mode? The mode of score that occurred most frequently. Looks like the 3 to me. 3. 3 occurred 4 times. No other value occurred that number of times. So the mode of score is 3. Mode as a frequency of 3 as a frequency of 4. No other value occurred that number of times. So the mode is 3. Simple. Next question. The pie chart below shows how students use 12 hours in studying English E, Mathematics M, and French F. All right, and it is drawn to scale. It is drawn to scale. So it is drawn to scale, meaning the angles are what they look like if it is drawn to scale. That's what it means. You can put a protractor on it if it is drawn to scale, right? It says the amount of time spent studying mathematics. So mathematics is inside here. Looks like 90 degrees. If it looks like 90 degrees and it is drawn to scale, it is 90 degrees. 90 degrees. 90 degrees represents 1/4 of the data because it's 90 over 360. 1/4. So 90 degrees is equivalent to 90 over 360 of the total, which is 1/4 of the total. All right? So the total is how many? 12 hours. Total is 12 hours. So the mathematics is 1/4 times 12 hours. That's 3 hours. So the answer is 3 hours. So 3 hours was spent on mathematics, 1/4 of the 12. Total was 12 hours. Mathematics is 1/4 of the circle. All right, because it's 90 degrees. Let's continue. Easy stuff. This question here now says, question says, the diagram shows a pie chart which shows the popular games played by 720 students. So the total in there is 720. How many students play cricket over here? Cricket. Now, this information, this pie chart, they give it in terms of angles and also give it in terms of degrees, and this is 90 degrees. All right. Now, if we're going to work in percentages, the total is 100%. We're going to work in degrees, the total is 360 degrees. Based on this, it looks to me like easier to work in percentages. Because this is 36 degrees, that is just 1/10 of the circle. You know? Because remember, the total angle of the circle is 360. 36 degrees is 1/10. 1/10 is 10%. I'm going to work in percentages. I'm going to find out what this is in percentages. I want to know what percentage play cricket. And I apply that percentage of the 720. So let's add it up. Right here is 10%. Because it's 1/10. 360 is 1/10. This now is 1/4 of a circle. This is 90 degrees. This is 90 degrees. 90 degrees is 1/4 of a circle. 1/4 of a circle is 25%. But understand that. I'm working in percentages. But good at that?
Yes, sir.
So my total percentage so far is 10 and 30. That's 40 and 25. What is that? 65% so far, right? So cricket occupies 100% minus the sum of these three, which is the 10 plus the 30 plus the 25. Working in percentages. Makes sense to work in percentages this time rather than degrees. Right? So this is 65. So therefore cricket occupies 35%. Agreed? So we're trying to calculate 35% of 720. 35% of 720. But I agree with that?
Yes.
So cricket, go for the blue. 35% of 720. 35% of 720. Which are those answers they look like? Which one?
C.
C. Yes, C is the answer. How will you work it out quickly? How will you work out the 35% quickly? Huh? 35 over 100
35
times
over 100 times 720.
Cancel
yes.
out the
How would you work
zeros.
it out? You calculate it and you try to estimate it quick.
Cancel out the zeros.
And so 0.
The zeros, and you're going to say 5 into 10 goes 2 times, and 5 into 5 is 7.
All right. No problem. Watch this now. 10% is 72. You want it? Agreed?
Yes, sir.
You want to find 35%, right? I'll show you a
Yes,
quick way to do it. 10% is 72. So therefore, what is 30%? 30% is 3 times that.
2 times 3.
3 times 7 is 210, and 3 times 2 is 6. So it's 216 that you reach already. Want it? Agreed?
Yes,
2
sir.
times 70 is 210, and 2 times and 3 times 2 is 6. So you reach 216 already. So I'm saying instead of doing all that calculation, you can say, okay, we want 30%, 35% of 72. 10% is 72. Therefore, 30% is 3 times 72. 3 times 72 is 3 times 70, which is 210. And 3 times 2 is 6. 210 plus 216. What we need now? We need 5%. 5%, if 10% is 72, then 5% is half of 72. 5% is half of 72. Half of 72 is how much?
36.
36. So we're adding up these two now. See it? 252. I think it's less calculation, but you can do it your way still. But sometimes, you know, you can just break down the percentage like this. It's 35% you want, you know. So you can go down to 10% and build up the 10% back to 30%, and the 5% is half of what the 10% is. So to me, it's easier calculation to do it this way. All right, but if you want to multiply it out and do it, no problem. No problem. All right, I just start with a 10% is 72, right, Jason? So therefore, 30% is 3 times this. 3 times this easily is 3 times 70 plus 3 times 2. 3 times 70 is 210. 3 times 2 is 6. 210 plus 6 is 216. Then I want 5% now to make up my 35%. 5% is half of the 72 because 10% is 72. So half of 72 is 36. So that's my 30% and that's my 5%. I add them up to get my 35% right here. 272. But anyway, that's it. Let's continue. This is the same question, same information. See? So this time I put in 10% for us on the tennis. Up here they gave us the angle. See? 25% is a football. Up here they gave us the angle. The same 25%, you know. See, it's the same information. Right? And then the basketball is 30%. Did you have basketball on it? Yes, 30%. So it's the same information really. And the same 720 students. Same information. How many students play cricket? It's the same information, but this time they gave you everything and have to figure out anything. Right? So the same cricket is 100% minus the sum of those three. So I'm gonna have to work it out, right? It's the same question. Whereas the same question, right?
Yes, sir.
Yes,
Minus the 30 plus the 10 plus the 25. So you're looking for 35%. So you're doing 35% of the 720. Right? And you get the same 252, the same question. But this time they give you more information. Less working out needed of you. But they gave us these as angles. You have to work them out as percentages, represent them as percentages. All right, same question. Over here, same question again. Look at it. Same question again. But look what they ask now. They say if 180 students play football right here, 180% students play football. How many students are in the group? Now, 180 students represent a quarter of the students in football. It's a quarter of the students. Right? Or 25% of the students. You could set up like this. Set up like this. 25% is equivalent to 180 students. And this is a ratio. You want 100%. You just need to multiply by 4. See it? I want this side to become 100%. So I multiply by 4. multiply by 4 to make this side become 100%. So it becomes 100%, which is all the students. Therefore, 100% of the students, which represent all the students. This stands for the same 720.
720.
720 students. You multiply this by 4 to get 720 again. All right, same 720. So the same question asked in different ways, but the same question relating to the same information. All right, next question. Ms. Clark arranged 15 test scores of her students in order of size. So arrange them in order of size and select the 8th one. So if it's 15 people divided half and half, you're going to get 7 and 7, which is 14, and you're going to get the 8th one in the middle. 7 and 7, and you have the 8th one in the middle. So the 8th one is the median to find. You know. Realize that? So divide the 15 people half and half first. 7 and 7. 15 people divided 7 and 7 first. So it's 14 that. And then the 8th one is in the middle. Because it's an odd number of values, odd number of test scores. The median is one of them. It is the 8th one. So the 8th one is the median. The one in the middle of the data. After she arranged them in order. She arranged them in order first. Order of size. And selected the 8th one. The score that is selected, the statistical measure that is obtained is the median. This one. So the median should pick out. The 8th one is the median. Why do you go to that? More questions. In a box, there are 8 red, 7 blue, and 6 green. How much total is that? How much is that? 8 and 7 are 15 and 6 is 21. So 21 total, right? 21 is the total. We're going to need it. Statistics. It says one marble is picked up randomly. What is the probability that it is neither red nor green? Meaning it is red. Meaning neither blue nor green. Meaning it is red.
8 over 10.
It means that it's a red one or one. So it means that the probability of getting a red is 8 out of the 21. 8 over 21. Answer is A right here. Good. Total is 21. So neither red nor green means that you want a, neither blue nor green means that you want a red. So probability of getting a red you want. Next question. All right, this graph. This question says, it shows the amount of fish bought in kilograms by the first 60 customers at the fish market. So there are 60 customers. So these are the customers up here. And these are the amount of fish to buy in kilograms. Right? If you look at the scale, for example, they're going up by 2. So right here says 11. Right here says 10. So we can literally put them on 11, 10, 11 again. This is 9. Right down here so is halfway between 407. 456 is 5. This one is 4. This one is 7 up here, so 7. This one is 3. 3. So those are the number of persons, right? In each measure. For each kilogram of fish. Those are the number of persons. Let's put them on. It says how many customers bought at least 6 kilograms? Now, at least 6 kilograms means greater than or equal to 6 kilograms, you know. Which are these? These are the ones. These are the measures greater than or equal to 6. So you want to add up these persons. So those are the ones that are adding up. So you're adding up those. So it becomes 11 is the top. 11 plus 5 plus 4 plus 4 plus 7 plus 3. You understand that?
Yes, sir.
That looks like 30. Because this is 10 and this is 20. So it's 20 plus 10 that, 30. So basically add them up. At least 6 kilograms means greater than or equal to 6. 6 or more. So add up the persons who got 6 or more. Add up those. All right, that is that. Next question. Or same question. What is the median amount of fish bought? Same data. The median. So remember now, the median, you want, again, you have to go to the middle, right? So there are 60 persons. So the median is like you have the 60 persons and divide it half and half first. 30 over here, so, and 30 over there, so. So because you have to get the one in the middle, it's an odd number of persons, odd number of measures, right? You have to average the 31st, the 30th, and the 31st. So the median would be the 30th, the last of this one, and the first of this one. So the 30th measure plus the 31st measure divided by 2. So you're looking for the 30th person and what that measure is, and the 31st person and what that measure is. So you have to count the person from left to right to find the middle, to find the 30th. All right? You have to count them up. The 30th and the 30th person and the 31st person. What measure fish the bar? What size fish the bar? So this is 22 so far. Actually, you reach 30 days already, don't it? See that? By the time you finish here, so you reach 30 persons. 30 persons you reach, yes. So the 30th person is right here. 30th person. And for the 31st person is one of these. But understand that? Understand that, students?
Yes, sir.
So the 30th person bought a 5 kilogram fish, and the 31st person bought a 6 kilogram fish. Right? So it becomes the 30th person bought a 5 kilogram fish. That's the 30th score. And the 31st score is a 6 kilogram fish. And you average them. So you get 5.5 kilograms. That's how you get the median. Hope you understand that, guys. I hope you understand it. Hope you understand. All right, let's continue. It's more of the same. This one says, what is the modal age? So this one shows, boom, 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 boom. It's a histogram which shows the number of children of ages that took part in a survey. So these are the number of children and these are the ages. So for example, 3 persons have an age of 4 years. 4 persons has an age of 5 years. 2 persons has an age of 6 years, and so on, right? So these are the ages and these are the number of persons up here. Read it at the top of the histogram bars, all right? Let's continue. What is the modal age? The modal age is the one that most persons at that age. 5, the highest bar, corresponding to the highest bar. The modal age is 7. 7 years. The modal age is 7 years, corresponding to the highest bar. Most persons at the age of 7. So that one easy. 7 years. Don't put 5 in, guys. Right? The mode is a score. These are the scores. These are the frequencies. The frequency values are up here. The mode is one of the scores. So the mode has to be one of these values. Median has to be one of these values. Mean has to be one of these values. Range has to be one of these values. Mode, median, range, interquartile range, semi-interquartile range are your score values. They come from your scores. They don't come from your frequency values. Mean, mode, median are scores, not frequencies. You have to be careful. Don't give frequencies as your answers for those things. So the mode is not a frequency. The 5 up here is a frequency. This 5 is a frequency. These are your frequency up on your y-axis. These are your scores on the x-axis. So the mode has to be one of these. Cannot be one of these. No. Cannot be one of these. So don't give it away. All right? Please. Let's go. How many children took part in the survey? This is now asking for a frequency. Total number of children. So you're going to add up these children. You have 3 years so. You have 4 years so. You have 2 years so. You have 5 years so. And you have 1 right there. So you add up the children. So it's 3 plus 4 plus 2 plus 5 plus 1. That's the total number of children in the survey. You add them up.
15, sir.
Add up the 15, you sure? You want to be
Yeah.
around, you know?
Sure.
7, 2, and 9, and 1, make 10, and 5, and 15. Thank you very much. 15. 15 people add up in the survey. Beautiful. All right, done. Next part. More frequency. So we don't accumulate the frequency curve yet now. We're finishing off the frequency. Finishing off the statistics and we take a break. It's coming up to 2:30 now. More maths equals better maths. Study hard, pass easily. Want to pass it well on Tuesday, guys. Remember, only the multiple choice, they'll set, they'll mark. So you have to get it, you have to nail it. You want 60 out of 60, no less than 58. Let's go. This question says it refers to the following chart. Show the number of books students bought at a sale. Sound like someone do already. How many students bought exactly 4 books? So these are the books. These are the number of students, right? Note the scores. So you want 4 books. 4 books here, so 4 books is already. 4 books is already, so you can see. 4 books were bought by this number of people. 9. 9. Answer is 9. 4 books were bought by 9 persons. 9 students. 9 students bought exactly 4 books. Good. Next one. The median number of books bought by the students. Again, you want the median again, right? So you want to find one in the middle. There are 58. Same process again now. Right? Same process again. So you have the 58. You have the 58 students. You want the number of books bought by the one in the middle. So you divide the 58 half and half, you get what? 29 and 29. So, because you divide 29 and 29, you want the average of the last one up here, so, and the first one up here, so. 29 and 29 are 58. So you want the average of the 29th student and the 30th student. The number of books bought by those two, you're going to average them. So you need to find how many books the 29th student bought and how many books the 30th student bought. The data is in ascending order from left to right. That's either the books in terms of number of books bought and ascending from left to right. So you're going to count the number of students from left to right until you reach 29 and 30 and you see how many books them buy down. So let's add them up now. Ready? Let's go for the ready. So you have 8 right here. So what total are we trying to reach? We're trying to reach 29 and 30. You have 8 right there. So they have 9 right there. So they got 17 already. They have 13 right there. So 17 and 30. That makes 30, you know. 30. So it means that the 29th and the 30th one, both of them inside here, so you know. The 29th and the 30th one, both of them is inside this group right here, so. Both of them. Because when you reach here, so you reach 17 people already. And you have 13 more people go inside here, so. So it means that the 29th and the 30th person is inside here. Because you already reached, this is 17 and 30, right? The 30th person is in here. 29th and the 30th. So both of them bought 5 books. The 29th and the 30th of them both bought 5 books. All of them buy 5 books. Let me write it. 29th and the 30th person, the last 2 persons in this group. The last two persons that they want are in that group. The 29th and the 30th are the last 2 persons in this group. And each of them buy 5 books. So it means that the median number of books is 5. So it becomes 5 plus 5 over 2. 29 person bought 5 books, 30 person bought 5 books as well. So the median amount of books bought is 5. Not because the middle bar is 5 and not because the tallest bar is 5, guys. All right? Not because the middle bar is 5 and because the tallest bar is 5. I just explained it to you. But the median number of books bought is 5. All right. Next question. All right. Some cumulative frequency curve questions coming up now. So I arrange them out like that for you, in groups, put them out like that for you. All right, so this one says no. This one refers to the following diagram, which shows the cumulative frequency curve based on the marks of 200 students. So the total number of students is 200. These are the marks to obtain. These are the students from the ones who get the low marks at the bottom down here, the ones who get the high marks at the top. The cumulative frequency curve is the best way of lining out the students in ascending order from the ones who get the low marks to the ones who get the high marks. So the low mark students down here got these low marks. See, it corresponds to the low marks down here. The high marks up here corresponds to the ones out here who got the high marks. The top students at the top got the high marks up there. So the students are in ascending order from the low marks ones to the high marks one. And that is why you can use it to find the median, the interquartile range, and your quartiles. What is the median mark of the 200 students? So like you want the mark for the one in the middle. So the portion of the median is the one in the middle, the 100 students. Since there are 200 students, the one in the middle is the 100 student. Look at the scale properly. This is 8 and this is 120. This must correspond to 100. This is not the median, you know. It is just the position of the median. The symbol for the median is Q2 because it represents, it also corresponds to the second quartile. So you come across on a graph and you want to know the mark that this 100 student got. Come across on a graph. And you come like it's right in between here, and you're reading right in between here down. Like it's right in between there. In between those two marks. And you have to look at the scale as well. Look at the scale. So look at the scale right here, so you have 10 of these small lines over 10 units. So each of those small lines is 1. So like 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I've established that first. The scale of the graph. So every small line is 1. So this is 30, 35, 36, 37. Looks like 37 and a half to me. Looks like 37.5 to me. 37.5. Look for that. 37.5 marks. Let's look at that. Is the bang right there. You see there? Love that when you find some on the graph and it match that size there. That is the median. Next question. The highest marks on the test. The highest mark on the test. So these are the marks, you know. So the highest mark on the test. Look like it's out here, so correspond to this. The highest mark, like around 60, you know, guys.
60 or 58.
But based on the answer, it's 60, right? This one. So that highest mark. I see that somebody get that. See there? Go up there now. It went up there. It went up there. Out there, so 60. Bang. Highest mark on the test is 60. 60. Next one. What is the interquartile range of the marks of the 200 students? The interquartile range. The interquartile range is Q3 minus Q1. So we need to find Q3 and we need to find Q1. What is now? This mark divides half and half. So the lower quartile is halfway between on the bottom half. Halfway between 0 and 50 and 100 is 50. So Q1 corresponds to 50. Or you could say it is 1/4 of 200. So the position of Q1 is 50. The 50th student got the first quartile mark. So you find the 50th student. So look for 50 carefully now. You can't. This is not 50, you know, guys. Wrong if you put 50 right there, so you know. Right there, so it's 60. Right here, so it's 60. Look at it. Halfway between 40 and 80 is 60. This is 60. Don't give it away by taking the wrong scale. So you're going for 50. So 50 is halfway between this and this. So 50 is right here. That is 50. That is the position of Q1. Read the scale properly. Plenty people going to put that as 50, you know. I come right off at the 40. You know. Be careful. Don't give it away. All right, so we're going right in there now. Mathematics is the most exact science. I'm going to do it precisely. Precisely. Especially when they give you a graph. So you're coming right in between here. Bam! Look like it dropped right on that line. Looks like it is right at this 30 right here. So let's say that this is 30. Circuit, I'm going to put Q1 on it. Then I'm going from a Q2 now. So my Q1 is 30. Going from a Q2 now. Q2 is halfway between the 100 and the 200. But it's halfway the upper half of the data. Or it is 3/4 of 300, of 200. 3/4 of 200 is 150. I could say halfway between 100 and 200, which is 150. Again, you have to be careful. So this is 120 and this is 160. So right here, so it's 140. You know. This is not 150, no, guys. It's a 140. This is 140. So 150 is halfway between these two. So 150 is halfway between the 140 and the 160, which is right here. So this is my 150. That is the position of Q3. So next I will do a question. I'm now going to do some explanation, explaining this one. All of them is the same. See another one like this. Come across on a graph right in between here. Don't give it away. Mathematics is the most exact of all the sciences. The other sciences have to estimate sometimes and guess and assume. Mathematics, no, very exact. Come down like it's on this line, you know, guys. To me, it like it's on this line. So you come down on it, read it all the way down here. Read it all the way down here. That is my Q3 position, which looks like 43. 43. So I'm going to say it is 43 minus 30. 43 minus 30. And this is giving me 13. All right, I get 12.5. Maybe my thing a little bit off. Come on, that's enough. Come on, that maybe one of my lines are a little bit off, one of them, you know. If I look closely, maybe I go over a little bit too much right here. So I want to, but no matter. Give them the 12.5. Give them the 12.5. Maybe down here, so maybe it stopped a little bit. Maybe it came, maybe it should be right here. All right, but no matter. Close enough. I'm going to give them that 12.5. Calculation give me 13, the closest one to this 12.5. Yeah, give them that. He's clearly out of it. Can't be none of this. All right, that it says if 38% of the students pass the test, what is the pass mark? Now, if 38% of the students pass the test, it must be 38% at the top. At the top. Top 38. Top 38. Top 38%. Top 38%. 30% at the top. What is 38% of 200? Top 38 of the 200. What is 38% of 200, guys? 38% of 176. 76. So the top 76 students. Top 76. Top. So the top 76 students. So basically, to find the pass mark, you want the top 76 students. So you're gonna do 200 minus 76 to see what that position is at the top. What position is on the graph? 200 minus 76 is how much?
124.
122. So you're gonna find a 122nd student. That's his pass mark, his mark, or anything near his mark is the pass mark. So 122nd student.
There is 124.
124. So
124. 124. So the 124th student is the last student who passed the test, or the first of the top students who passed the test. Something like that. All right? The top 76 passed the test. So you're going to 76 from the top. So you go from the 124th student, basically is the first student. Find his mark. Any mark near his mark is a pass mark. You know this mark near that is a pass mark. You're going to go 124. Let's go. 124. Let's do that one in blue. 124. Let's do that one in blue. All right. So it's 120 here, so. So the question is, what is each of these marks? One of these marks is 4. 124, because you have 20. Mute the mic, please. Mute the mic. Mute the mic. Mute the mic. Mute the mic, please. Mute the mic, please. Right. So you have 20. You have 5 lines in 20, in a space of 20. You have 20 divided by 5. So each of these lines is 4. Because the total units covered is 20, and you have 5 lines covered 20. So each one is 4. So right here says 124. 124. So you have the 76 students up here who passed the test. 76 students up here who passed the test. No, 76%. 76, right? Yeah, 76, 38%. 76 up here. So the pass mark is a mark that corresponds to this right here. This is 124. 124th student. So come across here on the graph and read what this mark is. Come across on the graph and read that mark. Correspond to this right here, so line it up nicely. Pass the test, you have to get 40. Pass mark. This is the pass mark. You have to score that or more to pass the test. And that corresponds to the top 76 who pass it. 38%. The 38% are the top 38% up here. They want 38, they want 76 students from the top. So you subtract the 76 from the 200, you get 124. So the mark that what the 124 student got is the pass mark, 40. So look down here, so have 40. Bang, see there? That is the pass mark. All right, guys. Hope I don't have any more like that. We have so much things to do. I spent a lot of time on this one so far. All right, some more here. Hey. Let's go. This one refers to the following diagram which shows cumulative frequency curve of the height of 20 plants. Height of 20 plants. These are the heights, these are the plants. All right, what do you want us to tell them? The interquartile range of the set of measurement is what? So the one interquartile range again. So since there are 21, 1 quarter, because this 20, this will be the halfway mark. This will be the halfway mark since there are 20 plants. Let's do this quickly. All right. And the bottom half is this, and the top half is that. This is the halfway mark. So this is the position of Q3 right here. That is the position of Q3. And this is the position of Q1. Not Q1 itself, it's the position of it. So you're gonna come and read this across here. That's Q3, giving you Q3 right here. And this one giving us Q1. Q1 inside here. Read the scale properly. So there are 5 marks between 0 and 2. So this color is 2 divided by 5. This mark is 2 divided by 5, which is 0.4. So each of these is 0.4. It's like 0.4, 0.8, 1.2, 1.2, 1.68, right? So right here is 2. This is 2.4 and 2.8. 2.4, 2.4, and this is 2.8. So in between here, that we want is 2.6. Right here says 2.6. That's the first mark, 2.6. All right, so right, this says 2.6. And then this one now is 4.4, 4.8, 5.2, gone up by 0.4. So right, this says 5.2. You have to read the scale carefully. So right, this says 5.2. Right here, 5.2. 5.2. Right here is 5.2. So this is Q3 and this is Q1. All right, so it's 5.2, Q3 minus Q1. It's Q3 minus Q1, which is 5.2 minus 2.6, which is 2.6. So the answer is 2.6. All right, more of the same thing. But say no more, ask me that, I'm not going to do it now, because you must understand by now. So we can move quickly. This one asks us for the interquartile range again. Same calculation. I'm not going to do this one, guys. All right. This is a similar question to this, but the measures are different. This one asking for length. So I'm going to skip over this one for experience. It's the same thing that we did over here. Come to this point and you read it down. Come to this point and you read it down and you subtract to get the interquartile range. Skipping over because we're running out of time. Then the semi-interquartile range, it's the interquartile range divided by 2.
Time, but sir, question. What do you mean the Q1 and the Q2? What the Q we use for?
Quartile. Quartile. Q is a quartile. Q is a symbol for quartile. So the data can be divided into 3 quartiles, Q1, Q2, and Q3. So the Q is for quartile. Then we want the interquartile range, it is Q3 minus Q1.
Okay, sir.
All right. So if you want it here, if you want the semi-interquartile range down here, so like someone want the semi-interquartile range, it will be the interquartile range divided by 2. The semi-interquartile range is the interquartile range divided by 2. Semi means half. So it's like half of the interquartile range. So you have to get the interquartile range here and then divide it by 2 down here. We could just do this one. So the interquartile range Q3 again. So again, it's 20. So the position of Q3 is 3/4, which is a 15. This is the position again of Q3. And the 5 down here again is the position of Q1. You want to read it on the data now. Come across on the graph here. Zoom it up. Come across on the graph here. Looks like it is right on this line. That's Q3. And then come across on the graph of this one, 1/4 of the data, and read it down here. You have to read the scale. There are 10 lines now between 0 and 1. Notice 10 lines between 0 and 1. So each line is 0.1. 0.1, 0.2, 0.3, 0.4. This is 0.5. 0.6, 0.7, 0.8, 0.9, 0.1. So each of those small lines is 0.1. 10 lines, like 1 divided by 10. So each line is 0.1. Each of those little lines is 0.1. That's why I work it out. 10 lines between 0 and 1, so it's 1 divided by 10. So this right here says 1.2. 1.2, that is Q1. And right here, so is 3.567, it's 3.7. This is 3.7. This one is 3.7. 3.7. That is Q3. So the interquartile range down here is Q3 minus Q1, which is 3.7 minus 1.2. That is 2.5. Bang, 2.5. Then the semi-interquartile range is half of the interquartile range. So it is 2.5 over 2. 2.5 over 2, which is 1.25. 1.25. Bang, right there, 1.25. The semi-interquartile range is half of the interquartile range. So you're not going to ask both of them on the paper, guys. It's going to ask for either this one or this one. I just put them together for you. All right? So it's asking for the semi-interquartile range, I find the interquartile range and then divide by 2. Yes?
There a question for when you're finding the quartile, sir. And so first you find the second
Position.
quartile.
So again, the second
Sir,
quartile, not, I don't need the second quartile.
Sir, I'm asking a question.
Yes.
Sir, so first you find like the second quartile, sir, and then you find half of the below half, and above you find half again, or something like that.
You can do it that way. You can do it that way, but you can also say that the position of Q1 is just 1/4 of the total data. And the position of Q3 is 3/4 of the total data. You can just do that too as well. So that the position of Q2 is half of the data. So if you check this, for example, 1/4 of 20 is 5. That's what we get the 5. See that? And 3/4 of 20 is 15. 3/4 of 20 equals 15. That's the position of Q3. So we could calculate it that way as well. Some people said 25% and 75%. We can have 1/4. But you can also use the method of divide it half and half first, which is a 10. And you have a top half. Halfway between 10 and the 20 is 15. Halfway between 0 and 10 is 5. All right? Anyway, any method you use is the same result. We have to get the position first. That answers the question, you good? So you could just use it.
Yes,
1/4 and 3/4. And if you want the median, the position of Q2, the median is half of the total. You find the position upon the y-axis and cumulative axis, and then you read the score across and down. All right? That's that. Let's continue. This one says, a fish is selected at random. What is the probability that it is at least 1.8? This is from the same table, you know, guys, from the same graph. What is the probability that it is at least 1.8 kilogram. At least 1.8 means greater than or equal to 1.8 kilograms. So you need to find how many fish measure greater than or equal to 1.8. Look how you're gonna do that now. This is talking about the fish up here, 1.8. So at least. What's the probability that it is at least 1.8? All right. So we're talking about, let me use the blue. So 1.8 will be right here, right? Right here. This is 1.8. 1.8. So you're talking about all the fish up here, so you know. All the fish that want up here, so up at this end. But what you can do, you want to, so you can do is find how many persons. The graph is going to show you how many persons get less, measure less. You know. You come and read, it's going to show you how many measure less. The rest of them at the top measure more. So let me show you now. You're going to come on the graph for 1.8. So it's 1.8 here. Come on the graph, 1.8. Takes me to this line. And then read it across here. All right. So this is a 5, 6, 7, 8, 9. No, so there are 10 lines. There are 10 lines between 0 and 5. I will get the scale first, you know. So it's 5 over 10, which is a half. So each of the line is 0.5. Each line is 0.5. So this is like 5. Each line is 0.5. 10 divided by 10 divided by 5. 10 line divided by 5. So each line is 2. Each line is 2. So this is like 5. Hold on. Clear this. Right. All right. So this is like 5, 6, 7, 8, 9, 10. All right. So every 2 lines is 1. Let's put it that way. Every 2 lines is 1. All right. So this right here so becomes 5, 6, 7, 8. This is 8. Oh man. Right here so it's 8 that we want. Put back in blue. Right here so 1, right? That is 8. So 8 persons got less. So the rest of them got more. So the rest of them got more up here. Which is what? 12 persons, because 8 and 12 make 20. 12 persons got more. Measure more. So you want the probability of getting one of these 12 persons. Right? So it's 12 out of 20. Probability is 12 over 20. See there, 12 over 20. Understand that, guys? We want the ones who got more. If the question is say less, question is say less than 1.8, then it will be 8 out of 120. But it said more, greater than. It said at least 8 kilograms. So at least 8 kilograms means 8 kilograms or more. So you want the ones who got up here. These are the masses 8 kilograms or more. Corresponding to the part of the graph up here, corresponding to the students up here, 12 of them. Because the total is 20. So 8 got less, so 12 got more. All right, approximately. So it's 12 out of 20. 12 out of 20. Hope you understand that. 12 out of 20. All right. Then we have a different kind of statistics test now. We're gonna finish statistics soon, and I'm saying. Right, we're gonna finish statistics on the next 2 pages. We'll finish statistics. Don't necessarily a different topic. Don't necessarily coming into some quality geometry and stuff. We're gonna do that after the break. We're gonna have our session, another session later. Have to. We're gonna have to finish. We'll finish. We're gonna take a break, and then break for about 2 hours, and then we'll come back and do another session. Just finish it today. Don't make no sense to wait until tomorrow. I'm prepared to do that. I'm prepared to do that. All right. All right. So we'll come to another type of statistics now. This kind of data. This question says, refers to the following table shows the results of a survey of 100 persons from 2 major ethnic groups, P and R. Respondents were interviewed about their attitude towards mathematics. Like, my attitude is very, very positive. Not just positive, very, very positive. Why not? Mathematics is the absolute best subject ever. It says a respondent from from ethnic group P, numeric P is from ethnic group P. So the statistics now is just about here. We're analyzing just here, guys. Talking about ethnic group P. So we're coming out of 60 persons. If the data was out of 100, this analysis is out of 60 persons. Because ethnic group P, a respondent from ethnic group P is selected at random. What is the probability that he has a negative attitude towards mathematics? Negative. 11 out of 60. No, that is neutral. Neutral. Negative. 24. 24 out of 60. 24 out of 60. 24 out of 60 are a negative attitude. What that reduces to? 24 out of 60 reduces to what? Divide by 6. Divide this by 6, we get 10. This can divide by what? 12. Divide this by 12, we get 2, don't it? Divide this by 12, we get 5. 2 over 5. Answer is 2 over 5. 2 over 5. But understand that. Because it's just out of ethnic group P. So it's out of 60. Not out of the full 100. The focus was on ethnic group P. Let's continue. Same data. A respondent is selected at random. What's the probability? So it's at random now. So it's because a respondent is now out of the 100. Because it's a respondent from the entire group. What is the probability that he has a positive attitude towards math? So it's out of everybody now. They didn't specify a group. Positive attitude. They want total number of persons with positive attitude was 37 out of the 100. So it's 37 out of 100, because out of everybody now, which is 0.37. So the answer this time is this one. So this one now, this question refers to the entire data. Pay attention. This one was referring to the entire sample. Entire sample. A respondent, never specified from any group. A respondent is selected at random, must be from the entire data. So you want out of all who have the positive attitude, out of the 100 persons, 37 out of the 100. But understand that. Positive out of the 100. Positive out of the 100. Bang. Next one. Same data again. No, this one cannot differ. This one says refer to the following two-way table which shows the mode of transportation to school on a particular day by a group of 200 students. 200 students. All right. So you have some who take the bus, some who take taxi, some who walk, and you have male and female. So it's a two-way table, right? It says a male student is picked at random. So our focus is only on the male. We are focusing on the male, which total 108. We don't want everybody. We're focusing on the male. A male student is picked at random from the group. What is the probability that he does not walk? Does not walk. So if he don't walk, it means him do one of them 2 years. So if he don't walk, it's 80 out of 108. But understand that?
Yes, sir.
80 out of 108. What I divide by? Divide it down and 10. What you get? Bang, 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 bang. Divide it down, quick. 80 divided by 108. Divide it down. Anybody? Divide it by 4, no man. Divide it by 4. Divide it by 4.
20 over 27.
Get 20 divided by 4, get 27. I'm lazy, you know. Nobody know want to know work. I want me to do everything. Come on, man. It's your examiner, not mine. Next one. This one says it refers to a frequency table show the time taken by 20 students to solve a math problem. Okay. So the lower boundary in the interval 3 to 5. The lower boundary is 2.5. The lower boundary is 2.5. The average of these two, 2.5. The lower boundary in this group is 2.5. 0.5 the standard. You don't want the lower limit. Don't want the lower limit, it will be 3. The lower boundary is 2.5. Why is that? Let me show you something. So the 3 to 5 group can take values from 0.5 up to less than 5.5. Because a value of 0.5 or more will approximate to 3. Not 0.5, 2.5, sorry, my mistake. 2.5, 0.5 less than this. 2.5. Right. So you can take values from 2.5, because anything 2.5 approximates to 3. But because 5.5 approximates to 6, we have to take values that are less than 5.5. So this is a range of values that can fit into this group. And the lower boundary there is 2.5, lower boundary. This is the upper boundary. The one to get to be 5.5. The one to the upper boundary. Upper boundary, UB. Upper boundary. All right, let's continue. This next question says, 600 students write an exam. 600, let's put it in value. 600 students write an exam. The probability of random selecting a failing student is 1/5. So if 1/5 fail, 4/5 pass. How many students pass? 4/5. If 1/5 fail, then 4/5 pass. 4/5 of the 600 students pass. But understand that? But I go to that. That looks like 480. That looks like 480 to me. That's right. 480. Because 4/5 is as 8 over 10. 8 over 10 times 600. 480. That's it. All right, this one now. If the mean of 4 numbers, 4, 8, x, and 12 is 10, then what is the number? Can I set up like an equation? The mean would normally be 4 plus 8 plus x plus 12 divided by the number of values there, which is 4. And they say the mean is 10. So it means that the sum of them is 40, multiply the 4 across here, the sum of them is 40. Make this a little smaller. Some of them is 40. I'm trying to find the x, right? So some of them is 40. So what is add up to? This and this are 20 and 4, 24. So we get 24 plus x on the top here. Multiply the 4 across here. You get 40. You get 40. Now move right about this line. Yes, sir. And therefore the x equals 40 minus 24, which therefore is what? 16. So x is 16. So you set up where you normally find the mean and then you calculate the unknown. Simple as that. Next one. When 3 coins are tossed simultaneously, the possible outcomes are these. You can get 3 heads, 2 heads and a tail, a head, a tail, and a head, and so on. You can get all these possibilities. H is for head and T is for tail. What is the probability of randomly obtaining at least 2 heads? That means greater than or equal to greater than. Sorry. What's that meaning? What's that meaning? Oh, see here, so. Sorry about that. Right. This means greater than or equal to 2 heads. Greater than, let me write it like this. Greater than or equal to a head and a head. That's what you want. Greater than or equal to 2 heads. So let's count them. How many? What's the total outcome? 1, 2, 3, 4, 5, 6, 7, 8, right? Total outcome is 8. So there are 8 possible outcomes. Total is 8. But how many heads, how many times can get 2 or more heads? So this is 1, 2, 3, 4, 4 of them. All the 4 of them can get 2 or more heads. So the probability of getting greater than or equal to 2 heads, let's write it like this. Probability of getting greater than or equal to a head and a head is 4 out of the 8 possibility, which is a half, equals a half, 50% chance. Bang right here, 50% chance. But go to that. But okay?
Yes, sir.
Total is 8 possibilities, right? 8 possibilities. Next question. Finish off the statistics and we'll take a 10 minutes break. We're coming back because more maths equals better maths. Shut up the exam Tuesday. Shut it up. 60 out of 60, we say. 60 out of 60. All right. Item 39 and 40 refer to the following distribution, which shows the average mass in kilograms of children. Remember, always note your score and your frequency. All right. It says the upper limit of the modal class. So the modal class is the one with the highest frequency. The modal class is the one with the highest frequency. This is the modal class. This is the highest frequency. So the modal class must be this one, right? So the modal class is bang, that one right there. Bang, one with the highest frequency. And the one the upper limit. The upper limit is just the value there. The one to the upper boundary, it will be 60.5. The one to the lower boundary, it will be 50.5. 0.5 less than the 51. The one the upper limit, which is just this value right here. The one to the lower limit, it will be 51. The one the upper bound, the upper limit. So it's just the 60. 60 right here is the upper limit. Bang. That is the answer. How many children have a mass greater than 40 kilograms? Greater than 40. We're talking about greater than 40. Mark that in blue, so we can make the distinction. Mute the mic, please. Mute the mic. Greater than 40. Talking about. So 40 stop right here, sir. Right? 40 kilograms stop right here, sir. These are the measures that are greater than 40. Up there. So talking about these students up here. That is the number of students. So it's 24 plus 40 plus 18. What that add up to? This is 64. 64 and 18. 64 and 20 are 84. 84 minus 2 are 82. So this is the answer. But good at that? But
Yes,
okay?
sir.
All right.
Yes, sir.
Beautiful. I think this is the last statistics question now. Yes. This is the last one right here. Similar to one that we just did. Let's go. This question says, item 39 and 40 refer to the following frequency distribution which shows the average mass in kilogram of number of children in a school. All right. Similar kind of data. This is the mass of the students. So these are your scores. This is the number of students, which is the frequency. Frequency, right? Frequency F. First question says, right here. First question, right here. The number of children who have a mass less than or equal to 40. Let's do that one in blue. 40 stop right here, so. So talking about these. Less than or equal to 40. Talking about these, which are these students. That out of the 68 is the 28 plus 40. 68 students that right here. Bang. Nice and easy. The upper boundary of the median class, not the modal, you know. Look at this. Median class. Let me put this in red. Normally they don't say the modal class, you know. So if that said the modal class, we're talking about this class, and you want the upper boundary, it would have been 40.5 if it was the modal, let's say. It was modal, but they never say modal, let's say median. So we need to find the median class. So in other words, which class is the median in? Right? That's what we're gonna find. We need to find which class the median is in. So what would be the median? What would be the position of the median? So how many students are there? How many students are there? We need to add up these to know how many students, right?
7.
Huh? Tell me.
70.
Add up to 70, sure? 70 total, right? That's what you're saying? Add it up at 70 you get? Can't be 70, man. Remember I said them at 68 already, you know? Come on, man. Add them up, add them up. You have to add up the total number of students here, so. This is already 68. That's 68 already, you know. You have to add up these.
132.
132. 132, you say?
Yes, sir.
132 total. 132 is the total number of students. All right. Now the median is going to be halfway. So 132 divided by half and half is how much? Is 50 and 16, right? That's 76. So 76 and 76. No, that's not right. 66
sir,
and 600.
you can please repeat.
Ah?
You get, sir, so after you got the 132, sir, what did you do next?
I do not yet. What I'm going to do is try to find where the median is. So the median is about halfway where that is, which is 66 and 66. That's all.
Yes, sir.
We divide into 132. I'm going to do it up here. We're trying to find where the median is, right? You're trying to find which class is the median class, right? Let me do it here. So you have the 132 students. All right, this equal 132. 132. And you divide half and half. You want to find where the median is, right? So you're going to get 66 and 66. So because an even number of data, you want the last person in this group, which is the 66th person, and the 67th person. First one in this group is the 67th person. That will be the position of the median. So you're trying to find the 66th and the 67th person, or which group have these persons in it. So you're gonna have to add up the values from left to right. But guess what now? We already reached 68 already in the first one, so that's what the question helps you know. The first two groups will already add up to 68. Right? The first, I'm right about that. The first two group was already 68 from the first answer. So when we finish here, say we reach 28 person, but by the time we reach here, say we reach 68 person. So it means that the 66th and the 67th person are in this group, don't it? See that?
Yes, sir.
The 66th and the 67th person are in this group, right here, so. So the median is, so this question is talking about that group. See that? See it? That's where the median group is. The median class is that class. That's where the median is located. And the upper boundary. So the upper boundary of that class, upper boundary of that class will be 40.5. So this is the answer. 40.5. So I tried to find where the median would be. The median would be in that group. That's where the 66 and the 67 person would be. I never asked for the median. Well, you have to estimate the median. But that is the median class. That's where the median would be. All right? Hope everybody understands that. So the upper boundary of that class is 40.5 kilograms. All right, so that finishes the statistics, guys. I'll take a break. Somebody have a question?
Yes, sir, me.
Yes.
When me did calculate it, I get 50.5. So may I ask if it's because it asks for the median. So I am saying, is it because it's near to the 40?
No.
Or
Watch me now.
how much reaching to 50?
No. All right. So remember, you know, the median corresponds to the score that the middle student had, or the measurement of the middle student in the middle. So because you have 132 students, the students are lined up from left to right in ascending order this way now. Because the measurements are in ascending order this way. So imagine that the students are lined up from left to right this way in ascending order. So what you want to find, because there's 132 students, you will say, okay, which students are in the middle of 132 students? So you divide the 132 half and half, you get 66 and 66. 66 and 66. First half is 66 and the second half is 66. So the middle students are the 66th student and the 67th student. So if you were to calculate in the median, you'd have to calculate the measurement of the 66th student and the measurement of the 67th student and average them. That will be the median. So to find where the median is, or which class the median is in, we basically start add up the students from left to right until we reach 66. When we finish the first set of students, we already past 28 students. But then there are 40 students in the second group. Remember, after you finish the two first group, you already reach 68 students now. So it means that the 66th student is in this group, and the 67th student is also in this group. So it means that this becomes the median group. That's where the median is located. The median is a score in this range, between 31 and 40. They're not asking for the median. They're asking for the upper boundary of the median class. This has to be the median class because that's where the median students would be. The students in the middle would be somewhere in those measurements. Understand what I've said?
Yes, sir.
All right. All right. Let me leave that. Take this off. All right, so we're gonna pause now. Let's pause. 10 minutes, you know, we don't have time for no long break. 10 minutes. So 3:40 now, we're at 45. I could do an extra hour and we'll take a break because it's still a lot of work to do. Still a lot of topics to look at. We're gonna do this properly. Right? You have to binge it, guys. You have to binge it. Reach page part 1. Only 20 pages left, you know, 20 pages left. Let's finish it now. No break. Let's finish it. Only 20 pages. And some of the questions down here. So it's it. Easy. Some of the questions down here, easy. Functions. You can finish it, man. Some of them have 1, 2 questions on a page, 1 question on a page, and so. This is some transformation. We can finish it to them, man. Yeah, we can finish it. We might need an additional hour to finish it. Right? I remember the flyer said until we are done. So we could just go straight until we're done. Right?
Sir, but I never think so translation and them something they come on paper too.
I might come on paper 1 to man. What's the matter with you? But them easy, you know. Them easy,
No, them
man.
easy.
Yeah, come on paper 1 to
More admit, sir. Honestly, did we say it teach me from early because it was my first time doing the CXC maths paper too, so kind of messed me up.
Yeah, the beauty about it is that only multiple choice coming, so you're kind of fortunate, right?
Yeah, that may I say too.
So all you need to do is make sure you get 58, between 58 and 60, and you're good. All right? So this will help you to get that. Just make sure you pre them question here, yeah? Pre them question up, pre them.
I'm gonna send in the group, right? Considering stay live.
No man, never say the video is on thing there now, on the channel.
On the channel, but I never inform about the channel.
Yeah man, it's on the flyer. I'm right out again. So if we go on YouTube, one of we can bring it up on the screen and show you. We're in a break now, guys. We're in a break. Bring it up on the screen and show you. If we go on YouTube, if I can bring it up on the screen. Live. What is going on the screen? Let's see. Let me see if I can bring it up on screen. Let's see. So go on my channel. So this is my channel, right? So the name up there at the top left-hand corner, that's the name I'm gonna put in. And this is the live. Yes, as you see on the top left-hand corner. So this is the live going on. This is the live going on right now. See it there? See it?
Yes, sir.
So this is the live going on right now.
Sir, do you think that most questions will be repeated or they'll come with new questions? Mostly new questions.
I'm gonna repeat just as I always do. I'm gonna repeat as I always do. So when you do this, latch on to these questions. Make sure you latch on to these questions here that we're going through, all right?
Sir, we can get the paper to answer them, sir.
Yeah, I need the paper answer. How can we get the paper answer?
How come what?
We can get the paper with the solutions.
Oh, can I get the paper with the solutions?
Yeah.
I don't know that I want to share that one, you know, to be honest with you. I think it's kind of risky. So let's work with the video, man. The video is there. I'm not so certain I want to share that one.
Okay.
No, I know it will be very useful, but you want this document, right?
Yes.
Yes, sir.
Nobody want this document. I think hard about it. I think kind of risky. I think kind of risky. But remember, the thing is there. Just watch the video. The video is there. I know kind of hard to go through the video because 5 hours and stuff. I don't know. No, but reach out to me individually. I don't know. Kind of doubtful about it. To share this document. But to be honest with you, this document comes from a lot of different sources over many years. Understand? So
But sir, it's Tuesday's exam, so I don't know. It's Tuesday's exam.
That's why we're having this session, right? To give you assistance.
Exactly so.
I can play the video, fast. But the video is there, you can fast forward the video, rewind the video, anything. I mean, it's and remember the questions are by topic. Questions are by topic. Can I risk it to share this document? I don't know. I think hard about it. I'm going to take a look at break now. We're on a break now. I want to put 5 minutes on the screen. 5 minutes. We've been talking for more than 5 minutes. So I'm going to put 5 minutes on the screen. I'm going to take a 5 minutes break and I will start back. All right? I want to finish this thing today. Start 5 minutes. I want to finish it today. I really want y'all to do well in the exam and I want y'all to nail it. I want you to nail the exam. I really want to help. I really want to help everybody. I cannot put myself at risk too much. I think about it. All right, guys, let's continue. I was just thinking, I think we can maybe have a session tomorrow. We are working on an actual paper, right? One of the most recent ones. You know, maybe one or two of them tomorrow. I'll decide by the end of this class. All right, and maybe have a session tomorrow. We'll do that. But it will be during my normal class, but what I could do is just set it up as an online. And so, you know, process could join just to see it. I'll decide by the end of the day. It will be the same link. And it will be, I'll make the live on YouTube as well. I'm not certain of the time as yet, but maybe we'll start around 4 o'clock or so, Jamaica time. 5 o'clock, maybe for about 3 hours, do 1 or 2 papers. Two of the most recent papers where, you know, the majority of the questions would be repeated if so be the case. All right, so let's see. Let's finish this and then we can decide what we'll do. Let's finish this today, and that will give us the opportunity to do that tomorrow. I think that's what we should do. Let's finish this today. There's about 20 pages left. All right, yeah, let's finish this today. Can move fast, quickly through here. These questions are very easy. All right, let's go. This question said the point where a linear function crosses the horizontal axis is called the x-axis intercept. So like you have a graph, I have a line, I have a line going like that. We're talking about this point where it crosses the horizontal axis. It's called the x-axis intercept. All right, or the x-intercept. Where it crosses the y-axis, we have one angle like that that crosses here. That's a y-axis intercept. But this one's asked about the x-intercept, x-axis intercept. Y-axis, x-axis. Next one. The equation of a line passing through a point is and have this gradient. Passing through this point and has this gradient. Easy question. Since this is 0, 5, it means that this is your C value. C value is 5. And then this is the gradient, that is your M. Equation of a line is for form y equals mx plus c. And so it's y equals, the gradient is 4, and the c is 5. Y equals 4x plus 5 right here. Bang. Nice and easy. Questions get easier towards the end, you know, guys. They get easier towards the end of the paper. It says line L is parallel to this. So the parallel have the same gradient. Parallel lines have the same gradient. Same gradient. If it was perpendicular, they would have negative reciprocal gradients. Since they have the same gradient, what is the gradient of line L? It's the same gradient as this. We need to put this in the form y equals mx plus c. Make y the subject. Transpose this 7y over here and make it positive. I'm going to make y the subject. I'm going to get 3x minus 9 equals 7y. Then I have to divide through by the 7. Divide everywhere by 7. That's right. Divide through by 7. I need to get y alone as a subject. Divide through by the 7. So I'm dividing each thing by 7. So I divide this by 7. It becomes 3 over 7x minus 9 over 7 equals the y. Now that y alone is subject, I can flip it around. This is the gradient. I can flip it around now, right? Y equals 3 over 7x minus 9 over 7. This guy right here is a gradient. This is an m. Gradient. 3 over 7. Answer is this one. Because it's parallel. If it was perpendicular, watch this now. If this instead was a perpendicular, if this was perpendicular instead, perpendicular, then they would have negative reciprocal gradients. You see this gradient? We would have to flip it and change the sign to get the perpendicular gradient. It will be negative 7 over 3. Flip it to get the 7 over 3 and change the sign. That's how you get the perpendicular gradient. Flip the one that you have and change the sign. The answer would be that if it was perpendicular. Okay, but they did say parallel. Parallel lines have the same gradient. So this one was a parallel. So they should say perpendicular. You'd have to calculate the perpendicular gradient, which is to flip the one that you have and change the sign. All right, next one. Similar question. Almost the same question, different values. So the same working out again. Line L is now parallel. What is the gradient? Same thing again. What is the gradient? Same thing again. Same as gradient as this. Transpose again and make y the subject. Just do it down here. I'm going to carry the negative 5 over here. I want to make it positive. 2x minus 8 equals 5y. Divide 2 by the 5 to make y alone the subject. 2 over 5x minus 8 over 5 equals y. Y equals mx plus c. So this again is your m. Y is a subject. This is your m. Y equals mx plus c. This again is your m. 2/5 right here. Bang. That is your gradient. Next question. What is the gradient of a straight line? What is the gradient of this straight line? See, this is 2y now. Plenty people going to run and put -3 now. Wrong. You have to make y alone the subject, not 2y. We need to get rid of this 2. So if they divide through by the 2 or multiply through by half, divide through by the 2, we have to get y alone as a subject, not 2y. Must have a y by itself as a subject. This divided by the 2 gives me the y that I want, equals. Divide this by the 2, I get -3 over 2x minus this divided by the 2, I'm going to get 4, but I don't want that. I don't care about that. I care about this. This is my gradient, circled in blue. This is my gradient m, -3 over 2. This one right here. Who does know by dividing by this 2 a long time? I'm just showing somewhere. All right? Don't need all this work on the paper. We just divide the 2 on a here and just say -3 over 2 done. But I'm not showing you the work still. See, we'll move quickly through these last set of questions. This one right here now says, to give that straight line, it says the straight line AB cuts the y-axis. That's talking about right here at the point A. That coordinate at that point is 0 and the y value, 0, -2. It becomes 0c, 0c, which is 0, -2. The y value there is -2. The x value is 0 because it's on the y-axis. On the y-axis, let's look at it. On the y-axis, x is always equal to 0. That's the equation of the y-axis actually. On the x-axis, y is always equal to 0. That, in fact, is the equation of the x-axis. So you see, the x value is 0 there. So it's 0, -2. Don't give it away. Right here, 0, -2. That's the answer. Next one. Which of the following pairs of lines are perpendicular? If they are perpendicular, the product of their gradients must be -1. Or one gradient is the negative reciprocal of the next. So we're looking for this. We're looking for a case where m1 times m2 is equal to -1. So we need to find the gradient of each line, and the product of the gradients must be -1. That's what we're looking for. All right, there's a process of elimination to go. So it can't be this one because see y is a subject alone, and them two gradients are the same, them two are parallel. So this is not it. These two are actually parallel. These two are actually parallel. They have the same gradient. So we're not looking for that. All right. Sorry about that again. Right. Let's go. Then this one now, gradient of this one is -3 over 2. If we divide by this 2, I get -3 over 2. So for this one, gradient of that one is -3 over 2. -3 over 2. And if we make y the subject of this one by carrying the -1 over here, -2, and then divide by the 2, the gradient is going to be 3 over 2. So the gradient of this one is just 3 over 2. But multiply these two things and not getting -1 in it. All right, so that doesn't work. For this one, the gradient is -4. Y is a subject already, so the gradient of this one is -4. And if I divide by this 4, the gradient of this one, M2, is a quarter. And voila, we have found it. We have found it. It's a quarter. If I multiply these two, I'm going to get -1. Or I can say this is the negative reciprocal of that. Whichever way you want to look at it. If I multiply them now, -4 times a quarter is giving me -1. So these are the perpendicular ones, guys. These are the two perpendicular lines. Let's look at the last one still. If I make y the subject of this one, man. Make a mistake. All right. If I make y the subject of this one, carry the negative y over here, make it positive, and then divide by the 2, I'm going to get the gradient of this one equals a half. Gradient of this one is a half. If I make y the subject of this one, carry the 3y, the 3x over there, and then divide by the 5, I'm going to get negative 3 over 5. It's gradient of this one. This one become negative 3 over 5. So those are not correct. So the correct one is this one. That is the one where the going perpendicular because the product equals negative 1. All right, that is that. Beautiful. All right. If they ask for parallel, if they said parallel to be this one would be the answer. If that said parallel. All right, because the gradient will be the same. All right, so that's it. That one finishes that. All right, functions now, guys. Functions. Let's go, functions. This question gives us a diagram and it says, the relationship that best describes the mapping diagram above is what? All right, let's look at it. When I look, I see these two values mapping to the same one value right here. And that's all I need to know that it is many to one. Bang. Many to one. Let's look at just one case I need. Many to one. Two values mapping to one. So it's a many to one function. This one. They give us this function I want h of negative 6. Let's go for the blue. It means that we're going to take the negative 6 and we're going to drop it for the x in the h right there. In the h function. So careful the negative sign. It becomes 3 times negative 6 minus 2 divided by 5. This is negative 18 and negative 2 as negative 20. Become negative 20 over 5, which reduces to negative 4. Voila. Answer is that one. Quick and fast, nice and easy. Gonna say more like that. Next one up here. Similar question. Different values. Take the negative 6 again and drop it for the x right there. Same thing again. This becomes equal to 7 times negative 6 minus 3 divided by 5. This is negative 42. Negative 42 and negative 3 is negative 45 over 5. Negative 45 over 5 is negative 9. So the answer is this one right here, negative 9. Beautiful. Let's continue. More maths equals better maths. This one gives us this mapping diagram. It says, which of the following best describe the function? Which of these formally basically shows how we go from x to y over there? Let's look at it. Which of them? The first one, you know. If I add 3 to this, I get 5. If I add 3 to 5, I get 8. If I add 3 to 8, I get 11. Sorry, if I add 3 to 11, I get 14. So clearly, it is an x plus 3 happening here. Y over here is equal to the x value plus 3. So this is the answer. Y equals x plus 3. Straightforward and clear. Straightforward and clear. Done. Moving right along. Next one. I like this question. Let's learn something from this if you don't know before. This one says, which of the following best describes a function? Which of them is a function? Which of them is a function? All right, I'm going to tell you why, which ones are not functions. Why? For a mapping to reveal a function, these are the domain values. Why are these the domain values? Over this side is a domain, over this side is a range, or a codomain. Over this side is a codomain. Codomain. All right? To decide the function or not, your focus is on the domain. And I know that this is the domain because the mapping is in this direction. The map from domain to codomain. If the mapping arrows were this way, then over here would be the domain. Over here would be the domain. If you were mapping from the left to the right. But this time we're mapping from, if you were mapping from right to left, but this time we're mapping from left to right. Now, how you know what a function is? For a mapping diagram to be that of a function, each element in the domain, each of the elements in the domain, and this is the domain, so your eye should go to the domain and see what is that in the domain. That's where you're busy. That's where you care about. You don't care about what's in the codomain. Codomain is irrelevant when it comes to deciding a function. Each element in the domain must have a mapping on it, must have an arrow coming off it. And you can only have one arrow alone coming off it. Any element that has 2 arrows coming off it fails, cause it to fail as a function. Any element that does not have an arrow coming off it also causes it to fail. So all of the elements in the domain must map, and when they map, they must only map one time. The rule says a function is such that each element in the domain must map one time. Each element in the domain must map to the codomain one time alone. I won't say each, it means you can't have any free element in the domain that is not mapping. Each element in the domain must map. Every element in the domain must map. And when they map, they must only map one time alone. They must have one arrow alone coming off each element in the domain for it to be a function. All right, enough said. Let me illustrate it now. I'll tell you why each of them is not a function. Let's look at the first one, zoom upon it. The first one failed twice. This element has 2 arrows coming off it. That causes it not to be a function. For it to be a function, each element must only have 1 arrow coming off it. So that first element fails it because it has 2 arrows coming off it. So we'll make a mark it. This one fails it. I'm marking what fails it, 2 arrows. This one also fails it because it has no mapping. Each element in the domain must map one time, and each of them must map. You can't have any free element in the domain. If you have a free element in the domain, it is not a function. Let's look at this second one now. This element fails it because it has 2 arrows coming off it. So this element fails it. It is not a function because that element has 2 arrows coming off it. In this one, the third one, all 3 elements fail. This one don't have no mapping, so it fails. This one has too many mappings. It has 3 mappings. The element must only have 1 mapping. And this element also fails it because it has no mapping. So this one passed the test. This element map one time. When I mark them, this one tick it. Map only one time. This one map only one time, and this one map only one time. So that's why this is a function. This last one is a function. Even if the codomain had another element in it, with no mapping going to it, it is still a function. You don't care about what happened over the codomain. You only care about what happens in the domain. When you start to do math at a higher level, you will have a care about what happens in the codomain, because we go into what we call surjective and onto functions. If a function is surjective or not. That math at a higher level. At CSEC level, you really only focusing on your domain to decide if it's a function or not. So this one is a function. Pass the function test, this one. Because all of the elements, they map, and each of them only have 1 arrow alone coming off it. That's why it's a function. Everybody understand that? Everybody understand what I just explained?
Yes, sir. Yes, sir.
Clear, right? All right, beautiful. So don't get a question wrong if you see it, and make sure. All right, look there. Now we're going to talk about mapping diagram with these now. This question says, the set of ordered pairs below represent the relation. This. All right? It says, which of the following points, when added, which of these points, if we add it to this set of values up here, this pair, which of these, if we add it up here, would form a relation that is now not a function? What will cause it not to be a function? You know what will cause it not to be a function? Any one of these that cause you to have 1 value in the domain mapping to 2 values in the codomain. Any one of them that cause you to have that. Remember, you know, these are your domain values. You know, right? Those are your domain values, your X values. So any one of them that will have a case that has 1 value mapping twice will fail. Not a function. Not a function if you have this. Any value that will cause you to have this will cause you to not have a function. So you're looking out for that now. All right, watch this now. I wanna know. Let's look at it. If I use this one and add it up there, and put it right beside this one, like this. Let's add it up here. 2, 8. If I add 2, 8 up here, so now. 2, 8 are the answer now. 2, 8 is the one that will cause it to fail. If I add 2, 8 up here, so what will happen is that I would have this 2 mapping to 7 and this 2 mapping to 8. I would create a case where you have 2 mapping to 7 and 2 also mapping to 8. See that? And I would have failed because I would have 2 mapped to 7 and 2 mapped to 8. That's why this is the one that is, you can't add that to it, otherwise you're not going to have a function. But understand that?
Yes, sir. Yes, sir.
Sure. Anyone that will create a situation where you have one thing mapping to 2, we call it a one-to-many mapping. One-to-many is not a function. One-to-many is not a function. So if you add this pair up there, it will result in the set of ordered pairs no longer a function. It is a function now because each element maps to a different element. But if I put this up there, I'm going to have the 2 mapping to 2 different values. 2 is going to map to 7 and the 2 is also going to map to 8.
Sir?
So it is that one that will cause it to fail as a function. Yes?
Sir, it's a question. If we flip the 8 and the 2 around, sir, can it be a function? It can be a function then, right?
If I give you 8, 2 instead, then that will be good. Because we don't have no 8 up here, so I map it. It means that the 8 will be mapping to 2. You see it? When you have the pairs, you know, the first value in the pair is the domain. Domain. The second value in the pair is your codomain, or your range. They form your range, or code, you form your range. You understand? So if it is like this, then the 2 would not be a domain. The 8 would be a domain. And the 8 will be mapping to 2. And you'll be good. That answers the question for you?
Yes, sir.
Good.
Sir, so the answer is A, right?
The answer is A. A is the one that will cause it to fail as a function. It's no longer a function. You want to know which one is going to make it no longer a function, not a function. Which of these pair, if you put it up there with this, it is no longer a function. This one is it. Because it is creating a situation where you're mapping the 2 to 7 with this pair. I am also mapping 2 to 8 with this pair. You see that? If you add that to it. You want to understand this before we move on. You want to make sure you understand it. You get me? Because it is creating a situation where you're having a one-to-many mapping. For something to be a function, you have to map to 1. Is that a 1-to-1 or many-to-1 for it to be a function? 1-to-many is not a function because 1-to-many will create a situation like this. 1 to many. You don't want that. Fails the definition of a function if you have that. Right? Fails the definition of a function if you have that. All right, so can we move on? It's another example right here. So it's another example here. So to give another one right here. So I want to tell me now, if I have this pair up here, so and I'm gonna fail as a function, which of these will cause this up here to fail as a function? Which one?
C.
C. Good. C. Because the -2 already mapped to 7. You can't bring a case where the -2 go and map to something else. So C will fail. All right, so I'm gonna get it now. Beautiful. Because the C will cause the -2 to map to 7 already, and then I map to 8 as well. And this will cause it to not be a function, not a function if you get this mapping. And you're trying to find the one that will cause it not to be a function. All right, not a function. All right, beautiful. Can we move on now then? Body good.
Yes,
Body
sir.
good.
Yes, sir.
Beautiful.
Yes, sir.
All right, lovely. All right, let's continue. All right. We're going to talk about not a function and function on graph next to now. So we'll talk about what makes something not a function on a mapping diagram. We're going to look now at what makes something not a function on a graph soon, right? Coming up to that soon. Must know everything. I want to get 60 out of 60. Which of the following points lies on this? Is whichever one satisfied, you know, whichever one where you plug the values in there, it satisfies. That's what they want. So in other words, when you plug these x values in there, the y must come out to one of them. That's all. So this kind of trial and error, like a test, like you have to test it and see which one it is. So I'm gonna try this one. Let's try trial and error. Let's try this one and see what we get. What is it? Which one of them go? If I plug in the x value there, so the y value gonna come out to be that. That's what we tested. Not the first one. Let's try. We plug it in there. We're gonna get 2 times. We're gonna get 2 times 2. 2 times 2 minus 3. We're plugging it in the equation. The equation is y equals 2x minus 3. We want to see if we plug it in there. We plug the x in there. What we get? What we're supposed to get? We would get 1. We would get 1, but this is a 3, right? So it's not right, right? Because this is actually a 3, right? So it's not right. If we plug the negative 2 in this, we're supposed to get 2 times negative 2, 2 times negative 2 minus 3. That will be negative 7. But this is a negative 1. So it's therefore not this, that's not on it. Plug the 4 in there now. Plug the 4 in there. Plug the 4 in the line. It will become 2 times 4 minus 3. That will become 5. And this is a 1. So it's not it either. Shall just look on it and know. The last one, because this is the y-axis intercept. See it? Shall know that that is the answer right out the bottom. 0, negative 5, even negative 3. Because that's the y-axis intercept for this curve. Y equals mx plus c. So the answer is the last one. Should have just look and see it from the get-go. So I will try all of them. Last one is this one. Can you plug the 0 in there, so you're going to get y equals negative 3. This is actually the y-axis intercept for that line. So that is it. That is why that is the answer. I don't like that we did so much work to get the answer, and the answer was there all the time. I'm not leave them upon it enough. This is the y-axis intercept. I don't like doing it the long way, the wrong way. This is the axis. This is the y-intercept. This is the c. This is the y-intercept. Y-intercept. C equals negative 3. All right? So to look and see it. All right, good. This one says, what is f of negative 3? We're going to plug the negative 3 inside here. So it's going to become 2 times negative 3 squared minus 1. This negative 3 is going to become a positive 9. So you get 2 times 9 minus 1. 2 9 is 18. 18 minus 1 is 17. 17 right there is the answer. 17 right there. Easy question, easy question. Let's look at this. Which of the following show the following arrow? It says our diagram above describes what relation? Let's look at it. Which of these it describes? Let's look at it. All right. So we see that the 2 map to 8 and the map to 10. And the 3 map to 9. And the 4 map to 8 alone, right? So it look like these are multiples of these. That's what it look like to me, multiple. But the 8 is a multiple of 2 and 4. The 9 is a multiple of 3 alone. And the 10 is a multiple of 2 alone. So like the ones on the right are multiples of the left and the ones on the left. Or you can say these are factors. These are factors of these. All right, the x are factors. Let's look at it. It says y is less than x, which is not true. Because this is greater than that. So this is not true. There's a process of elimination. This is not true. It says y is a factor of x. No. These are actually multiples of these. So the second one is not true either. So this is not true. It says x is a factor of y. Yes, this is true. X is a factor. This one says x is a multiple of y. No, that is not true. So the multiple there will be greater. So this is not true. So the answer is C. X is a factor of y. May I ask a question? Suppose one of the answers was x is less than y. Could you accept that? If this was one of the answers, x is less than y. Could you accept that as an answer?
I mean, x is less than y, sir, by right.
I
So,
think so, yes, sir. I think. I'm not sure.
by right.
All right, so I'm going to show you something. You see, if you're using x is less than y, that means that the 2 would have come up to 9 as well. Because 2 is less than 9. And the 3 would have come up to the 8, and it have come up to the 9, and it have come up to the 10. And the 4 would have come up to the 8, and it have come up to the 9, and it have come up to the 10. You understand that? It would have to, this would have to be true for all the values. That's why this could not be the result. It's not that is not the result because the mapping does not declare that. Understand the point I'm making?
Okay. Yes, sir.
If this was true, then the 2 would have to map to the 8. It would also have to map to the 9 as it maps to the 10. But there's no mapping to the 9. So therefore, it is not true for this inequality. If it was true, the 2 would also map to the 9. You get me? Because it has to be true. It has to be true in all cases for it to stand up. And there's no mapping to the 9 where the 2 is less than. All right. Hope that explains. Let's continue. So if you see a question and put that as an answer, you can't accept it. Good? That's not consistent for all the values. Cover yourself now. Same thing. Same thing. So this one says, let's use the red. Same thing, you know. So this one, the larger values on this side now. The mapping is this way again. So these are where you look at the multiples now. See it? So the X are the multiples now. See that? Same figures, you know. But I switch around the sets. So 8, 9, 10, 2, 3, 4. You switch them around. You now put the 8, 9, 10 on this side. Right? So 8 is a multiple of the 2 and the 4, which is true. 9 is a multiple of the 3. 10 is a multiple of the 2. So the multiple situation now. So X is a multiple of Y. So this is the answer. X is a multiple of Y. Y is more than X, not true. Y is a multiple of X. Y is a multiple of X. No, they are actually factors. So this is not true. X is a factor of Y. No, X are actually multiples. So this also is not true. So if it's a process of elimination, you're good to go. Let's look at this one now. Which of the following line graph represent this? Which of the following line graph represent this? Now let's look at it. There is no equal on the -2. So you have to put an unshaded circle on the -2. There is a equal on the 4. So you have to put a shaded circle on the 4. And then this is an interval. You're going in between the -2 and the 4. So the answer for that one, you're looking for an unshaded circle on the -2 and a shaded circle on the 4. And you're going in between them. All right, that's what you're looking for. Let's look for it. Let's look for it. The last one. See there, the last one. Shaded circle on the 4, unshaded circle on the -2, and then your region is between them. So the answer is the last one. Everybody good at that?
Yes, sir.
Yes, sir.
All right, beautiful. Remember the unshaded circle is when the equal is not there. The shaded circle is when the equal is there. Let's look at this one now. Now they give us a line and one equals. So we're going to the left of 1. So we are less than 1. But the circle on the 1 is unshaded. So it means X is less than or lower than the 1. It's not including the 1. We're going to the left of 1 because these values are less than 1. So your X values are less than 1. That's what you want. That's less than 1 alone. Don't put this one in now. Not shaded. If it was shaded, if this was a shaded circle, then the answer would be this last one. But it is unshaded. So the answer is this first one. X is less than 1. All right. That explains that. Next question. It says, oh, this is a variations question. I should have done this question. We did variation the other day. We did variation yesterday. But no problem. Come now, we'll do it. It says, given that Y varies inversely as X. What that means? It means that, let's do it in red. Inversely. 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 It means that Y is equal to a constant divided by X. Inversely, K over. If it was directly, it was Y equal K times X. If the word was directly, to K times X. All right? Direct. Let me leave directly. If it was directly, it would be K times. If it was this. If it was directly, it would be K times. Y equals K times. K is your variation constant. They say Y equals 16 when X equals half. That is for you to find the K. I can take this and make K the subject by multiplying the Y across here. It means that my k is always equal to x times y. Plug these values down here now to find the k. So it means that my k is equal to half of 16. The k is equal to 8. Now that the k is equal to 8, I can take the 8 and drop it back on the formula up here. So my relationship, because the k is a constant, it's not ever going to change. So I put that back now, the y becomes 8 over x. Y equals 8 over x, which is the last one. Because the k is a constant. But understand that? Very good?
Yes, sir.
All right. So I'm always using known values to find the k, right? Use the known values to find the k. All right. Beautiful. Nice. Remember, inversely is k divided, directly is k times. All right? K times. All right. Let's continue. Down here now. Coming to the end now. So finish. Reach page 46. With a 60, we have less than 20 pages to go. We're coming now. So we have about 10 pages to go. I'm going to fly through these quickly. This one says, I give us this quadratic graph, it's a front graph, the maximum point. This one comes on almost every paper. The maximum point is right here. I don't want the coordinates. Let me zoom it up and make you see it clearly. They're asking for the maximum point. It is right here. Bam. That's the maximum point. The maximum point is clearly 2, 4. 2, 4. 2, 4 is the answer. Easy question. Right here. 2, 4. No calculation needed. The values of x where this intersect the line intersect y equals 0. You see line y equals 0? See this line y equals 0? You have to know. Y equals 0 is actually the x-axis. Okay? X equals 0 is the y-axis. So y equals 0 is the x-axis. So this question is talking about these 2 points here and there. That's what it's talking about, those 2 points. Where it crosses the x-axis. Y equals 0 is the x-axis. So we're talking about this point here and this point here. Those 2 points, y is equal to 0 at that point, and y is also equal to 0 at that point. But at this point, the x value is 0 as well. X equals 0. And at this point, the y x value is 4. X equals 4. So these are my 2 x values. 0 and 4 at those 2 points. 0 and 4. X equals 0, x equals 4. X equals 0, x equals 4. The first one. First one is the answer. As you can see, I indicated on the graph. Remember, y equals 0 is just the x-axis. Which of the following equations represent a straight line? Straight line is one that can bring the form y equals mx plus c. Any equation that can be transformed or transposed into that form is the equation of a straight line. It must not have any xy in it. No product of x and y. No products or quotients or powers of x and y can be in it. The only power that can be is 1. No products, like no xy. Can't have no xy. Must not have. The line can't have any of these. None of these. None of this. None of these. Can't have xy. Can't have x squared. Can't have y squared. Can't have x over y. Can't have the square root of x or the square root of y. Can't have nothing like that in it for it to be a line. Once it don't have any of these, yeah, more than likely it is a thing there. So see what this one fail this one. It have a xy. This one fail that one, it have a x squared. This one fail that one, it have a x squared. So it has to be this one. This one can be transposed in the form of y equals mx plus c. Let's show you. Move over 3, it becomes y equals 2x minus 3. See it? That's what it becomes. Can be transposed into this form. All right, that is the answer. Let's continue. So remember, the line can't have any of these guys. Straight line can't have any xy in it. Can't have no x squared. Can't have no y squared. Can't have no x over y or no y over x. And can't have no square root of x or x to any power or y to any power. Can't also have no y root y. Can't have anything like that. for it to be aligned. Must be able to transpose into the form y equals mx plus c. All right, enough explanation. I must get that by now. Next one says, which of the four represent a straight line? Same thing again. This one is not a straight line because I multiply the y across here, so I'm going to get xy equals 4. So no, this one can't work. This is it, you know. This is the answer, the second one. Y equals mx plus c. Here, same again. Y equals mx plus c. For it to be aligned, must be write in the form y equals mx plus c. This one have an x squared in it, so it fails. This one have an x squared in it, so it fails. This one have an x squared in it as well, so it fails. And this one could be written as xy equals 4, so it fails. All right, done. These now. Which of the following set represent the function where these are your domain values? So x is a member of these. So in other words, which of these pairs, you plug these x values in the formula. You plug these x values in the formula, this one and this one and this one. You're getting the corresponding y value. So we can basically work it out. Getting these corresponding y values. So I could plug in 1 first, plug in the 0 first, for example. 0, let's write it. Let's write it. 0 is going to give us, plug the 0 in this, we're going to get 0 squared plus 3, which is 3. So this is good, this is good, this is good, this is good. So that's good for all of them, right? Well, it's a process of elimination. Let's try the 1 now. So we never have to work out the 1, the 0, because the 0 give you 3 for all of them. Let's try the 1 now. 1 map onto what? This 1. Plug the 1 in there, that's where map onto. Map onto 1 squared plus 3. So 1 map onto 4. So therefore, you can eliminate this one, because this one fail it, and this one fail it. So you see we have a 4 yes and a 1 and a 4 this two. So one of these two is the answer now. So we need to go to the third value and see what the 2 map onto, whether 5 or 7. Plug in the 2 now. 2. What the 2 map onto? The 2 map onto 2 squared plus 3. This is 4 plus 3 is 7. This is a 5. So this 5 fails it. So the 7 there, I don't have to work no more. This is the answer. Answer the last one. 5 failed. But understand that working out quick and fast. We never have to do the first one. You know. We did not need to do the first one. The first one is very obvious. 0 map onto 3. So let's not show it. I don't need it. Just them 2 that we need to work. Look at 1 map onto and look at 2 map onto. It's a process of elimination. Right? 1 map onto 4. So this one fails. And this one fails because the 1 map onto 4. And then the 2 map onto 5. The 2 map onto 7, sorry. So this 5 right here is a fail. So the answer is the last one. We don't have to work out for the 3. We don't have to waste time and work out. That's it. We have eliminated those. Similar question down here, so. Alright? But this one asks us which are the pairs it is. So it's basically like you're plugging in the negative 2 in there. And then you plug in the negative 1. Pretty obvious, you know. The negative 2 is going to map onto negative 2 cubed, which is going to become negative 8. The negative 1 is going to map onto negative 1 cubed, which is going to be negative 1. So I already answered the last one. You know. Only this one alone have a negative 8 in it. So I don't have to do anymore. Right? I don't have to go anymore. This is it. That's it. I don't have to go anymore. It's the only one that has a negative 8 in it. Okay, the negative 2 is going to give a negative 8. Done. Next one here, so same thing again. This now is negative 2 squared. No, it's not squaring the negative again. So the negative 2 right here, so let's do this one in red. The negative 2 here, so first. The negative 2 is going to map onto. Put by the negative here, so first. And then you're squaring the negative 2. And this negative is coming back. This is going to work out to be negative 4. This negative is this. And this is the 4. Yeah, negative 4, right? So we can't eliminate nothing yet because all of them have negative 4. All right? We can't eliminate them either because all of them have negative 1. We can't eliminate. We can't eliminate this. This is not a 0 because 0 going to give you a 0. So we can eliminate this one. This is having a 0. Look at the last one, guys. Last one. Let me continue. All right, let me continue. The negative one is gonna map onto negative 1 squared, which is negative 1. All right. So we have all of these so far, right? Now we have to look at negative 1. 0 is gonna map onto negative 0 squared, which is 0. So there's no 0 in this. This gone. It's gone. All right. And this one have the negative 1 and the 0. But what about the 1 and the 2? No. The last one, I answer again. I'm just fooling around. The last one is the answer. Really. All right. Because if you plug in the 1, we're gonna move on to negative 1 squared, which is negative 1. No, I know. Not the last one, you know. See there? The last one, because 1 is gonna map onto negative 1. Gonna map onto negative 1. Negative 1 still. This negative cause it to be negative. See that? Not the last one, you know. So the answer is this. B is the answer, you know. B. Wow. B is the answer. B is the answer. And if you plug in it to 2.
What happened to the 2, sir?
Yeah, you don't have to work it out. Because the 2 going to give you negative 4 again. 2 going to give you back negative 4. So negative 2 squared still going to give you negative 4. So the fact of the matter is that the only values that you can get out of it are 0, negative 1, and negative 4. That's why this is your codomain, your range. So I say, when the people might put that, it is wrong. I must put it as it said. But this negative in front here, so means that all the values can have to be negative or 0. And the negative, because the negative is not squaring. So it's like and this will always be positive. Because a number squared will always be positive. So the end result will always be negative or 0. That's why that set is a third one. So yeah, I like this question. I like it. I look upon this one and make sure that's not the case, right? This is not the case because if you cube the 2, you're gonna get 8. So that is not the case of yours. All right, I like this question. I almost marked the wrong.
Sir.
Yes.
Sir, sir, I really don't get it right now.
Huh?
Sir, I don't get it right now.
You don't get
answer
it?
just not there or something like that.
You don't understand this one?
Yes, sir, because like
no, but look here. You cannot put a value twice in a set. You cannot put a value twice in a set. These are sets. The domain is a set and your range is a set. You cannot put a value twice in a set. So you can't put 2 negative 4s in the set. And you can't put 2 negative 1s in the set.
Oh, okay.
You understand? If we were to do a map, if we were to do a mapping diagram for this, right? Let me show you a mapping diagram for this. If we're doing a mapping diagram for this, it will look like this. You'll have the domain. Let me zoom it up. With the negative 2, the negative 1, the 0, the 1, and the 2. And your codomain will only have the values negative 4, negative 1, and 0. And your mapping would go like this. The negative 2 map to negative 4. Right? The negative 1 map to negative 1. The 0 map to 0. But guess what now? The 1 also maps to negative 1. And the 2 also maps to negative 4. That's what your mapping diagram would look. It's still a function because each element over here, if you look at it, each of them only have 1 arrow coming off it. See it? Let's zoom up on it alone. Each of them only have 1 arrow coming off it. If you look at this side alone, that makes it a function. If you focus on the domain, it is a function. Each element only has 1 arrow mapping off it. Just that, you have a case where 2 different values map to 1. See? 2 different values map to the same one over here. These are different colors so you can see. 2 different values, 2 different domain values map to the same 1 value. So it's a many to 1 mapping. It's a many to 1 mapping, but it's still a function because each element in the domain maps only once, 1 and only 1 time, right? That would be a mapping diagram, but it's still a function. That's it. That's what it will look. You cannot put a value in a set twice. All right? You cannot put a value in a set twice. The domain is a set and the range is also a set. All right, let's continue. What is the value of x at the point of intersection of the system of graphs? So you basically doing f of x equals 3 and this equals that. So basically, point of intersection is where them equal, right? So it's where f of x equals g of x. So basically solving this equals 3. You're solving g of x is already. You really know solving g of x equals f of x. That's what you're solving. Right? So the g of x is 5 over 2x plus 1 equals 3. So you're solving that for x. Okay, over this one I subtract it, you get 5 over 2x equals 2, multiply by 2 and divide under the 5. So you're going to get x equals 4 over 5. 4 over 5 is same as 8 over 10, which is 0.8. So the answer is right here, 0.8. Easy question. The simultaneous equation. This one. This one says a parking lot charges $1 plus 0.5 cents.
Scroll up for a second, please.
Right here.
Yes, sir.
Okay now. All right now.
Not really, sir.
Where do you understand? Then where do you
You got
understand?
the answer.
I'm get this answer. From here, sir. From right here, sir. Multiply the 2, I'm gonna get 4. And then I divide another 5. So it becomes 4 over 5. And then now, 4 over 5 is 0.8. But if I multiply this up by 2, multiply this by 2, just because I want this to become a 10. So multiply this by 2 becomes 8. Multiply this by 2 becomes 10. So it becomes 8 over 10. Everybody knows it's 0.8. But this I could know that this is 0.8 as well. See that? See it now?
Yes, sir. Thank you.
All right, good. Because I realized that the answers were in decimals. But the answers were in decimals. So I'm having this over 5, I want it over 10. So it's multiply it up. Multiply this by 2, I multiply that by 2. So the 4 over 5 becomes 8 over 10. And then it becomes 0.8. All right, this one now. It says a parking lot charges $1 plus 25 cents for every hour or part thereof in which a vehicle is parked. The function CH that represents the parking cost is what? All right. So them charge $1 to begin with, plus 0.25 for every hour. So if you spend 8 hours, then it's H times this. All right? And this is a fixed price. So it's $1 plus 0.25 each. That becomes the charge. I don't see that there. Oh, see just. Okay, I was frightened a while ago. $1 plus 0.25, which is this. The parking lot charges $1. $1. So as you go in there, pay $1. Plus 0.25 for every hour each that just stay in there. So if I multiply the hours that just stay in there by 0.25, that is a variable charge. The $1 is a fixed charge. So as you enter the parking lot, they might charge you a month, $1. Just to drive in, you pay $1. And then every hour after that, you pay 25 cents every hour after that. So this is the formula to calculate the charge. That's what they say.
Sir, but suppose it could have been D, because you said hour over 25
It could have been what? D?
Yeah,
D?
D.
No, I can't think there because it says it's 25 cents for every hour. So you can't divide by the hour. 25 cents for every hour, you know, for
Sorry, so what about
hours
B?
8. Huh?
So why can't it be B?
Why it has to be what?
It be B.
Why couldn't it be B?
Yeah.
Because read the question. Read the question. Let's see. A parking lot charges, read it carefully, you know, charges $1 plus $1. No. $1 plus.
Oh, target.
Good.
Yeah.
$1 plus. And then they charge 25 cents for every hour. So if you stay 1 hour at 25 cents, if you stay 2 hours, it's 2 times 25 cents. If you stay 3 hours, it's 3 times 25 cents. So it's always an hour times the money. It's a variable charge. Hope everybody understands it now. But good?
Yes, sir.
All right, good.
The
So
hour
it's
times the money is the variable charge.
Right, this is a variable and this is a fix. So as you enter there, if you go in there for 1 second and if you go enter there and come out back, you have to pay them $1. Just to drive in, you pay $1. And then now every hour or part thereof. So it means say if you spend half an hour, you still have to pay. Every hour or part thereof, you have to pay 25 cents. So if you spend 1.5 hours in there, you're going to spend $1 plus. You have to pay 2, you know. You have to pay for 2 hours, you know. Every hour or part thereof. So you pay for the 1 hour plus the half an hour. You pay 25 cents for each of them. So it will be 2 times 0.25. Every hour or part thereof in which the vehicle is parked, you have to pay. So these are the formula right there. So that is the formula. All right?
Sir, and you said C is the variable cost.
Huh?
You said the answer C is the variable cost?
No, this is a formula. This is a formula. What I'm saying is, if you look at it, if you break it down, this part of it is a variable cost. This is the variable. This one that varies with time, it changes with time. So this is the variable cost. It's the variable part of the formula. This part is variable, varies with time, and this is a fixed cost. This is fixed. Because this don't change regardless of how many hours you spend in there. You always pay $1. So if somebody who spend just 1 hour in there, have to pay this. Somebody who spend 10 hours in there, have to pay this just to see. So as you enter the park, you have to give them $1. And then you pay now based on how much time they spend in there. So this is a fixed cost, and this is the variable cost, because it varies with time. It varies based on the amount of time that they spend in there. So it's a variable, and they come together to give it a total charge. The fixed and the variable come together to give it a total charge. Can we move on? Everybody go with this now? Can we move on,
Yes.
right?
Yes, sir. Yes, sir.
All right, good. This one now. This one says, give us this graph. It says the gradient of the line, the graph of this one. The gradient of AB. So give us that graph AB and asking us for the gradient. We don't have to calculate nothing in guys. That's on a graph. You can measure it. Gradient is rise over run. Remember, it's from left to right. Always safer when you do it from left to right, right? Do it from left to right. Going from left to right on the graph. Rise or run from left to right. What do I mean by that? So this line from left to right is this way. This way. I want to know the rise over the run this way. So this is the rise. Now we're going to count the unit on the x-axis and the unit on the y-axis. Make sure you know the scale of the graph first. So 1 box is 1 unit horizontally. 1 box is 1 unit vertically as well. So what is the rise? My rise is this. And my run is this. From left to right. So I run 1, 2, 3, 4 units. My run is 4 units. Run 4 units. And my rise is 2 units. Rise 2 units. Gradient is rise over run. So my gradient is rise 2, run 4. That becomes half. This is the answer. You have to calculate it. Some people put on the corners at this point, and so that point is A is a point 2, 1, and B is a point 6, 3, and do y1 minus y2 over x2, x1 minus x2 and all. You don't need to do that when you have a graph. You can actually see the rise and see the run. So that let's not waste any time. Just count the rise and count the run from left to right. Think of it going from left to right. And the gradient is positive because it's sloping up as we go from left to right. If the gradient sloping down this way, the line was sloping down this way, it would have a negative gradient because going from left to right on the line, you would have been sloping downwards, which means you have a negative gradient. Always think of a graph, whether it be a straight line graph or a curve, as if you are going from left to right along the curve. If it is going up, as you go from left to right, the gradient is positive. If you are going down, as you go from left to right, gradient is negative. If going from left to right, you're going horizontally, the gradient is 0. You're not rising or you're not falling, gradient is 0. If the gradient is a vertical line, then the gradient is undefined. Undefined. All right, that is it. So always think of a graph as going from left to right. You just want to count the rise over the run. That is a gradient as you go from left to right. We do this question already.
So the rise over run going down is negative and the rise over run going up is positive?
Yes, yes.
And
Go like this. If we were going like this from left to right, look what we do. You go from this point to this point, for example. So the rise will be negative, see? And the run will be positive. So this would be like a -3, for example, over +2. So the gradient will be -3 is a rise, over +2 is a run. So the gradient will be -3/2. So when you come down, the rise becomes negative. Good question. I like that question. So that's how the negative will come into play because your rise will be negative. Once you're going down, the rise is negative. In this case, we're going up. So the rise is positive. I'm going to the right, the run is positive. Also, if you're going to the left, the run is negative. But if we take it from left to right, the run will always be positive. If we take the graph and take do the direction along the graph as if we're going from left to right along the line, then the run will always be positive. And so it is the rise that will change between being positive or negative. If the rise is coming down, it's negative. If the rise is going up, as in this case, then it is positive. That's a very good question to ask. I like that question. Give her a chance to explain and some stuff. Understand it now? Let me leave it on the screen. Understand it now?
Yes, and it's undefined.
Sorry, so basically it's like the right angle triangle where I normally see it on the graph sheet.
No, it's just a way of measuring the slope of a line. It's you putting the rise and putting the run. You count the rise and count the run. These lines are put in here now. It's a way of just counting the rise and counting the run. They're like virtue, it's just counting. To go from here to here, I count how much I rise 2, and I run 4. So my gradient is 2/4. So I count the rise and count the run between those 2 points. That gives me the gradient. All right?
Yes, sir.
All right, cool. Down here, so I think we did this question already. We want the gradient of this line. We're going to divide by the 2. And so we're going to write in form y equals mx plus c again. And divide by the 2. So it becomes y equals -3/2x minus 4. This is the gradient. You don't want the y-axis intercept it with 0, -4. 0 and the c value. You don't want the y-axis intercept. But this time we just want the gradient, which is -3/2 right here. We did that question before. Then comes this graph now, opportunity to talk about the graph, function graph. This question says, which of these is a linear function? Which of these is a linear function? Let's talk about each of them. Now, to test if the graph is that of a function, we do what we call a vertical line test. Vertical line test is to test if you have a function or not. Vertical line test. Tell you if you have a function or not. Then we have what we call a horizontal line test on a graph. That tells you the kind of function that you have, type of function. It tells you if it's a one-to-one or a many-to-one. So that's right. So the horizontal line test tells you what kind of function you have. It tells you if it is one-to-one or if it is many-to-one. That's what it tells you. Because a function can either be only one-to-one or many-to-one. So you normally do the vertical line test first. You have to decide if you have a function or not first. You do this first. Do this first. Do first. Because if it is not a function, then you don't bother do this. All right, so first you want to know if it's a function or not. All right. So when you do the vertical line test, what are you looking for? Your vertical line must intersect the graph only one time for it to be the graph of a function. When you do the vertical line on a graph, if it is a graph of a function, your vertical line is only able to intersect the graph one time alone, one point only. If your vertical line intersect the graph more than one time, then it is not a function. It means that you have a one-to-many mapping. It is not a function. So always do the vertical line test first. If you pass the vertical line test, then you do the horizontal line test to see what kind of function it has. Now, if your horizontal line intersects the graph only one time alone, then it's a one-to-one function. If your horizontal line intersects the graph more than one time, then it's a many-to-one function. All right, let's go look at these now. So the question asks us, which of these is a linear function? Which of these is a linear function? Linear means line. Which of these is a linear function?
So
some person, huh?
B.
You say B. So people say B and B wrong. Because B is not even a function.
Sir, I think it's C.
Sir,
And you say C and C wrong. C is not even a line.
Yeah, D.
And them say linear.
Sir.
It's A.
All right, but we don't want to guess, right? We want to know what to say, right? We don't want to guess. So I'm going to talk about each one, just to emphasize the topic and understand the topic. Because we don't know what they're going to give us today. All right, why is this one not a function? That's not even a function. So it's a line, but it's a function. It's a line, you know, but it's not a function. Why? Because it will fail a vertical line test. Let's zoom it up. Zoom it up. If I draw a vertical line on it, V line. Do the V line test first. The V line touch it several times, an infinite number of times, so it fails. So it is not a function. It's a line, but it's not a function. Not a function. Because it fails the vertical line.
What you call a function?
Huh?
What you call a function?
A function is a relation in which each element in the domain maps to only one and only one element in the codomain. And that's what I explained earlier. On a mapping diagram, it is represented when you have each element in the domain have only one arrow coming off it. That is what makes it a function. On
That
a
means
graph,
answer a D.
well, no, man, not because to talk about the answer then. We try to understand this first. We try to understand this first. Good. So I'm saying this one would fail a vertical line test. So even though it's a line, it is linear. It is linear, you know. It is linear because it's a line. Yes, it is linear, but it's not a function. Question said linear function. This is linear, but it's not a function. It fails a vertical line test because a vertical line on it will intersect at an infinite number of times. So it's not a function, but it is linear. So you don't answer it's not the correct thing. We're looking for a linear function. Let's look at this one down here. Any vertical line I draw will intersect the graph at only 1 point. 1 point, 1 point, 1 point, 1 point. Any vertical line I draw on this one is only able to intersect the graph one time. So it passed the vertical line test, V test. It passed it. But guess what? It is not linear. It's a one-to-one function. And watch me now. Know that it passed the horizontal vertical line test. I can now do the horizontal line test. And any horizontal line I draw will also intersect at only 1 point. So this is my H line test now. H test. Intersect at only 1 point. That means it is 1-to-1. So it is a function because it passed the vertical line test. And it is a 1-to-1 because the horizontal line intersects at only 1 time. So it's a 1-to-1 function. This is a 1-to-1 function. But guess what? It is not linear. So that is not the answer we're looking for either. Not a line, it's a curve. So that's why we can't choose it. It's a function, it is 1-to-1, but it's not a line. So we can't use it. Let's come across to this one now. Talk about this one. Here's the answer now, but I'm just trying to make you understand some things, right? This one now. Vertical line test first. Any vertical line I draw on this will intersect the graph only 1 time. So if I draw it right here, just for illustration purposes, it intersects the graph at only 1 place. Put it up here, sir. So it passed my V-line test, V test. It passed it. It is a function. So because it passed it and it is a function, I want to know what kind of function it is. I go to my H test, horizontal line test. A horizontal line will intersect it twice. That's my H test. So because it intersected twice, this says it is a function. This horizontal line says it's a many-to-one function. So this is a many-to-one function graph we're looking at. A positive graph is a many-to-one function. It's a many-to-one function. So that is a many-to-one function. But guess what? It's not linear. It's a function, you know, many-to-one, but it's not linear. Because it's a curve. Question said 1, linear. It is not linear, it's a curve. So the answer is A. It passed the vertical line test. If I draw a vertical line on it, any vertical line I draw can only intersect it at 1 time. So yes, it passed the V test, the vertical line test. It passed the vertical line test. Only intersect at 1, so we know it's a function. It also passed the if you do the horizontal line test, horizontal line only intersect at 1. Anyway, I draw an horizontal line, can only intersect at 1. So the H test tells me that it is a 1-to-1. So it's a 1-to-1 function. Put over here, sir.
And it's a line.
And it's a line, it's linear. This is 1-to-1, a 1-to-1 function. So it is a function, it's 1-to-1.
Sir, so all 1-to-1 functions is a linear function?
No, I'm just show you that one you saw a while ago. Now pay attention, man. You sure that one a 1-to-1, but it's not linear. That's a 1-to-1 function that is not linear. Good. Get it in your brain. Get it, make it stick, you know. Now pinch it, you know. See if everybody got a straight A's for an exam, yeah? Yeah, you. Oh. You, Miss Laurie, watch me. All right. So it's a 1-to-1 function, right? But and it's linear because I line. It is linear. So I'm going to zoom it up now and you look on it. Good. Look on everything. See there? You can learn a lot from this one question. That's why I've spent some time on it. Learn a lot from this one question.
So a function have to pass through the X and Y axis.
No, I don't have to pass through no axis, X and Y axis. Nope. Nope. Okay. Let me draw one graph like this. Okay, so one graph here. Watch this. I draw one graph here. And my graph is just from here to here. So bang, I'm done. My graph is from here to here. I'm stop. That's a function graph. It passes the vertical line test. It passes the horizontal line test. That's a 1-to-1 function. Watch again. I can have a graph. I'm going to just come and draw it from right to right to and stop. This is my graph, you know, my y-axis and my x-axis. I just come to boom, I'm going to stop. Now, there's nothing. Start here, so and stop it here, so. That's a minute-to-one function, you know. It passes my vertical line test, so it's a function. And my horizontal line cross it 2 times. That's a minute-to-one function, you know. You know, pass my x-axis and my y-axis. Right? What it needs are the things that I told you. So if the x-axis and the y-axis were relevant for it to be a function, I would have stated that. So only what I've stated is relevant. V-line test. Anyway the graph is, if a vertical line crosses it only one time alone, is a function. Horizontal line test. If a horizontal line can only cross the graph one time, it is 1-to-1. If a horizontal line can cross it more than one time, it is many to one. Don't do the horizontal line test if you fail the vertical line test like the first one. I don't bother do no horizontal line on it because it's not a function. Because if I go and do a horizontal line on this one, no. I go one thing says it's a 1-to-1 function because the horizontal line going across it one time. You see that? So don't do the horizontal line test until you pass the vertical line test. Because if you do the horizontal line test first, I might have been saying that that's a 1-to-1 function when it is not a function. That's why down here I said do the vertical line test first, and you only do the horizontal line test if you pass the vertical line test, if it's a function. When you know it's a function, you want to know what kind of function it is. This or this, you do the horizontal line test. But after when not ever do the test, you can just look at me. All right, but to illustrate it like on a paper 2, you could do these tests. Suppose a question, so for example, determine if this function is a 1-to-1 and then give it a graph. Or whether a 1-to-1 or many-to-1. You can do the horizontal line test and show it. As I suppose them said, determine if this is a function or not. You could do the vertical line test and a graph and show it. All right, let's look at this question now. Enough. Now still late to me today. We have done the paper here today. We're finishing it today, and I'll do 1 or 2 papers tomorrow. Look at this question. This question says, which of the following represent a function? If you don't want to know if it's a function, you have to do the vertical line test, do the V-line test, and all of them. Do the V-line test. Right? V-line test. Let me shift this over. To know if it's a function or not, we're going to do the V-line test on each of them. V-line test. Because that is how you test for a function. Look at them now. Look at this one. When fail and fail. So these are the points on this one. Right? You can see them. Those are the points on that function graph. If we do a V-line on this one, passing through these 2 points right here, passing through this point and this point. These are some other points on this graph. Not so clear on the diagram, but these are some other points on it, right? My V-line test right here so failed. My V-line test right here failed because it passed through 2 points. V-test failed. Not a function. So this one is not a function. Let's look at this one down here. Again, see there, these points are all on a vertical line. See? Them point there, them give us on this graph. See the points that give us on this function? If I put a V-line through here, it's gonna fail again because it passed through all those points. What that means, it means a 1 X value map to 3 different Y value, That's what it means, That's a 1-to-many mapping, 1 X value, I give me a Y value here and a Y value there. That's 1-to-many. That's what it means. That's a 1-to-many relation, which is not a function. So the V-line test again, the V-test failed. So this also is not a function. And then this one again, if you look at it, it show me the vertical section again. That's how you know that these are the wrong ones. See, show me some vertical sections right there. Those are the points on this graph. So I'm going to draw a vertical line through them. It passed through several points. It's a 1-to-many relation. So it failed the V-test again. Failed. So none of those are functions. Look at this guy here now. See the points up on this one now. These are the points. 1 point there, so 1 point there, so 1 point there, so 1 point there, so, all right? Anywhere I draw a vertical line here, so 1 point alone it pass through. Draw a vertical line here, so 1 point alone it pass through. Draw a vertical line here, so 1 point alone it pass through. Draw a vertical line here, so 1 point alone it pass through. So my vertical line test it pass it. Any vertical line I draw can only intersect at 1 point. V-test.
And the same
Which
thing would
one pass
reflect
the
for
B
the H
test?
line, the H test, right? Terry?
Huh?
The same thing would reflect on it if it was the H test.
So the H test now will tell me it's a 1-to-1, but they never ask me if it's a 1-to-1. They all ask me to tell them it's a function or not. If the question they go on to say what kind of function it is now, then I would go to the H test. And an H test to horizontal line through here, 1 point. Horizontal line through here, 1 point alone. Horizontal line through here, 1 point alone. And a horizontal line through here also would be intersecting at 1 point. But it is already a function, you know. That's what the question is asking me. Which one is a function? This is a function. Happens to be a 1-to-1 function because my horizontal line test is showing me that it's a horizontal is a 1-to-1 function. That's my H test. So this is telling me that I have a 1-to-1 function. This is a graph of a 1-to-1 function. Even though it's just a series of points. A function can just be a set of points, you know. There have to be no graph, no line, or nothing like that. This set of points is a function. 4 points from a function. I don't need to have a line going through them for it to be a function, you know, like that, you know. You don't have to have a line. The function can just be those 4 points right there. Meaning I don't care about the section between the points. It's still a 1-to-1 function. A function can just be a series of points. So anyway, this is the answer. This is the function. Spend some time on this just for us to understand this thing. All right? So the answer is A. Time is it? Past the time. 1 hour past the time already. Guys, we say we want to go until we're done. Let us finish it. About 12 pages left. We're going to finish it soon. And some of the questions, like 1 question on a page. We can go faster. This one is only 2 questions here. This question says, this is a circle here, right? Angle at center is twice angle at circumference. Both are there something by the same arc. Angle at the center is twice angle at circumference. Center rule. This angle is 2 times the 50 degrees. Angle at center is twice angle at circumference. The angle at center is 100 degrees. Both angles are subtended by this arc. Angle at center is twice angle at circumference. So the angle Y is 100 degrees. This one. Finish this one quickly. This is a Z angle. Once you have parallel lines, and a transversal line, this is called a transversal line. You have Z angles forming, you have what we call co-interior angles forming, you have corresponding angles forming. So for example, these are what we call co-interior angles, these 2 that I'm marking now, these 2, this one and this one. Those 2 add up to 180 degrees. Those 2, the co-interior angles. Yeah, we call them U angles because like there are angles in a U, like there are 2 angles in a U, like this, like we have a U and there are 2 angles in it. So we call them U angles. They add up to 180. Then we also have the Z angles, which are also called alternate angles. They look like a Z. If you go along one side, go along the transversal, and then go along the other side on the other end, you form like a Z. The angles inside the Z are what we call alternate angles. They are equal. And that's what does that mean in this question. They are equal. X and Y are equal. So that's how for this one is A. They are Z angles, or we call alternate angles. That's the relationship between them. Z angles are equal. Easy. Next question. We come to some transformation now. So this one is translation. I'm going to run through this quickly. I'm going to finish. And transformation the last time. Transformation and some basic tricks. I'm going to finish. Let's move quickly. We're going to just go through and finish it today. Want to take a break before I start this back? Start about this one. Want to take a short break?
Yes,
huh?
yes, sir.
Yes, no, sir. Run it, sir. Run it hot. Yeah, bro, run it. I was soon done, so why stop?
Because we're tired.
Them say them brain tired. Them say them brain. 5 minutes break. 5 minutes break. 5 minutes break. 5 minutes break. Right? Teachers and the studies must always give screen break. They must always give screen break. Right? That's what the studies say. Give a little short break. 5 minutes. Bang. 5 minutes. I will also run it right after this till we're done. All right? 5 minutes break and I will just run it till we're done. 5 minutes and I will just run it till we're done. We did say we want to go until we finish. That's what we said about it. The 5 minutes and we'll just finish it. Tomorrow, I'm going to set up a session for tomorrow. So we can do a session again tomorrow. We're going to do an actual paper or two. Right? We'll do a paper or two tomorrow. Tomorrow evening, or 4 o'clock Jamaica time, 5 o'clock Jamaica time. Let's do a paper. All right, guys. Let's go again. All right, one more lift to the end, like Chucky. One more lift. Let's finish this. All right. Remember, you can reach out to me if anything. Write my number one more time. My number is 8815600. Area code is 876. Area code 876. You can reach out to send me a message or whatever if you have any issues.
Sorry, what's your name?
My name is Rafik Shaw.
Unless somebody think I just your code name for you, you know, on YouTube make a video of them. That me think.
That's my real name. My middle initial is K. Rafik Kanai Shaw is the name. All right. So you make one.
Man, special
All right.
name.
All right. Let's do some special maths now. So remember, I teach add maths and pure maths as well. My program restarts in September. Anybody interested? You have to get in early. All right. Don't wait till the class full. All right. All right. So let's go now. So this translation. So this translation, under this translation, what is the image of this? Mute the mic, please. Mute the mic. Mute back the mic, please. Right. So all that happens with the translation is that this value is added to the x value and this value is added to the y value. So if we were to set it up, it's like we have the vector for this point is 3, -5. That's like the point, and you're moving it with this matrix, the 2, -3. And so it's going to go to 5, -8. That is 5, that is -8. -8. This is the column vector for the image point, which is now 5, -8. So the answer is 5, -8. And all of them is the same way, same thing for all of them basically. All right, that's how the translation works. You add this translation vector to the vector for the point, and it tells you where the image is. All right, it's another one right here. Under this translation, what's the image of that? We don't have to do all of that work, you know. We're gonna add this to this value. I can set it up just to make sure. -5, 3, and you're adding the translation matrix to it. -2, 3. So it goes to -7, 6. So the point is -7, 6 right here. So this is the vector, the column vector, or the position vector of this point. All right. Just that when you're doing transformation, you have to work the point as a column vector because of the non-conform. Because if you use it as a point, generally speaking, it becomes non-conformal to multiplication in particular in vectors, in matrices. All right, and that's why you use a point in the column vector format, right here. We're doing any calculation on a point in transformation. All right, I ensure that you want to keep the calculation so that it is conformable. All right, next one, the image of this point under this translation, same thing, more the same. So the point is -2, 3, and you add the vector 3, 4. So you know all I've done is written the point in column vector format. All right, and the result is going to be -2 and 3 is 1, and this is 7. So it becomes 1, 7 right here. 1, 7 is the point, matching that column vector. All right, is very easy, right? This one, let's do again. This one says the image of this point under translation is this. So they're giving us the image now, right? What is a translation? In other words, what do we change this by to get this? Clearly we subtract 6. What do we change this by to get that? Subtract 6 again, but you can set up like an equation now. So like you have the point, which is 1, 2. You add the translation vector to it, you don't know, so we can call it xy. Call the translation vector xy. The image point is -5, 4. You can set up like you're doing the translation, and you try to find this. So you can carry this over here and subtract it. So you get xy equals -5, -4. And you have to subtract this. Because same like how you transpose in math normally. You subtract this. And you see that you get -6, as I've said. Because this and this is -6. And this and that is -6. So the translation vector is -6, -6. We could look at the values. And so to go from this to this, what did I do? You have to subtract 6. And to go from 2 to -4, what do I have to do? I have to subtract 6. So the vector is -6, -6, which is A. So the answer is A right here. So you could look at it and know the answer as well, right? But this is just to show how it would be by calculation. If you were to show calculation. All right. Next one. Yes.
You're right. The image different from the translation.
So how the translation goes, right? Is you are, so it's like you have the point P, and you put the translation on the P to see where the image is. That's how you apply the translation to the point to see where it is going. So this point is moved by this translation to this point. So this is like an equation of what is happening. So the point is 1, 2. So I put it here. But when you're doing the calculation, you don't write the point in that format. You put it as a vector form. You put the values in a vector format. Right? The main reason for that is that in transformation, there are also a lot of transformation matrices that are 2 by 2. 2 by 2. And you can't multiply a 2 by 2 with a row matrix like this. Because this is a 2 by 2, 2 by 2 multiplied by this would be a 1 by 2. And so the 1 and the 2 here so would not match. Because remember, for it to be conformable, the number of columns in the first one must match the number of rows in the second one. But if you take the same point, instead of writing it as a point like coordinate, you write it as a column vector like this now and put the values in there. Then you'll be doing a 2 by 2, and this will be a 2 by 1 matrix with a 2 by 1. 2 by 1. And then because you have 2 columns and 2 rows there, then the multiplication is possible. So that's why when you're doing the calculation with points in transformation also, you write the point as a column vector. Don't leave it as coordinates. All right, so that's the main reason. You have to ensure that it remains conformable for multiplication. But this is what is happening, guys. You apply the translation to the point and get the image. So this is the translation. This is the translation vector. This is the object point, and this is the image that they tell us. And we're trying to find a translation. So I just call it translation XY because we don't know what it is. Understand? Understand?
Yes, sir. But one question. I think they might give a reflective translation from the exam.
I don't know what they might give you. I don't know. Well, if you just make sure you know everything. Where's a reflective what?
Translation.
There's no such thing as a reflective translation.
No, sir. I textbook I get it from the math textbook I get at school.
Reflective translation?
Yeah, you know, like the mirror. Yeah, reflector.
Oh, you mean transformation, a reflection, transformation.
Yes, transformation.
When I come up to reflection, I'll show you. You can pick it easy. Or soon come up with 1 or 2 examples and show you. So one here, so it's a reflection. It's a reflection, you know. Oh no, that's a reflection. I'm gonna tell you what a reflection. It's a reflection in a line reverses orientation. So what is the orientation of this object? P to Q to R. If you look at it, it goes anti-clockwise this way. On the image, P to Q to R, it is going clockwise. Once you have that happening, you know that you're having a reflection in a mirror line. The mirror line is going to be halfway between the corresponding points, halfway between those 2 points and halfway between those 2 points. So clearly the mirror line would be down right down the middle here. So that would be a mirror line. So I know that this is a reflection in a line, simply because the orientation is reversed. Orientation speaks to how the letters go around the object. So if we have a rectangle, for example, or a square, and it is A, B, C, D. Then this has a clockwise orientation. This one. Orientation is clockwise. We call orientation how you go around the object. If I have a same square, again, but this time I put A, I put the B, so now C, D. Then my orientation is anti-clockwise on this one, because I'm going around the object this way now. So orientation is different. So orientation is how you go around an object, right? That's what we mean by orientation. So the letters usually tell you, and the letters usually go in alphabetical order. So P to Q to R, and this one, as you can see, is this way, anti-clockwise. P to Q to R on the image is clockwise. So once the orientation is reversed, the reversal of orientation is only caused by reflection in a mirror line. No other transformation will cause the reversal of orientation. So once orientation is reversed, you know, so you have a reflection in a line. All right, so this one, the transformation for this one is a reflection. See there? Understood? Good at that?
Yes, sir.
Yes, sir.
All right, beautiful. Beautiful. Look at this one now. This one says, the diagram above, the line CD, this is the image of the line AB after what kind of transformation? So them say we want to use a process of elimination. Now this one's a reflection in the y-axis. That looks like it to me. Looks like a reflection in the y-axis. Now look up over careful with the points, all right? Because they don't put the prime on it, you have to be careful with the points, right? So what it is that line AD is the image. So this is the image. So it means that AB map onto CD, right? AB map onto CD. Let us line up the points. So it means that A map onto C. A map onto C and B map onto D. So A map onto C, B map onto D. That's like a reflection in the y-axis. Now look at it. As if this is my y-axis right here. If the y-axis is my mirror line. How reflection works calculation-wise is that image distance equals object distance on mirror line. So this distance is equal to this distance across here. Press the wrong thing again. Right. So this distance is equal to this distance. And the distance from here to the mirror line is the same distance over to here. And that's what does that mean? So that's why I would say it's a reflection. But look at that, let's look at the other options that are there. Because sometimes the transformations can look alike, you know. And sometimes two different transformations can give you the same result. It's possible. Right? It's possible, depending on the angles and so on, right? But this one is look like a reflection. Let's use a process of elimination. It's a rotation of 90 degrees through O. 90 degrees through O. All right, let's leave that one through O. Let's leave that one. And it didn't give any angle, right? Let me state something now. I talk about rotation. Let me just state. Listen good enough. Anti-clockwise rotation is positive. Clockwise rotation is negative. So if this says 90-degree rotation, and it don't say clockwise or anti-clockwise, it is taken to be anti-clockwise. But understand that. You have to understand that, right? Generally speaking, in some territories, we teach direction as clockwise or anti-clockwise. But in some other territories, they teach rotation in terms of whether it is positive or negative. So I just want to make sure that we're clear it up. Positive rotation is anti-clockwise. Negative rotation is clockwise. Anti-clockwise rotation is positive. Negative rotation, let me say it again. Anti-clockwise rotation is positive, clockwise rotation is negative. So this one that only says 90 degrees, because it did not specify a direction, I'm taking it to mean positive 90 degrees, which is anti-clockwise. All right? Okay. So let's see if that one would work. And it said 90 degrees. All right. So if it's 90 degrees, if I extend this line, let's take this off. If I extend this line and extend this line, then if it's 90 degrees, this angle would have to be 90 degrees. The rotation will be 90 degrees here. All right. I'm gonna waste the time on it. It is the second one, reflection in the y-axis. It's not a translation, because translation would only move the object and don't turn it. Clearly this turn, right? This was rotated somewhere, the turn. There's some turning there. Translation is the one that does move it. So if this was a translation, it would still look like so. It was a translation, right? It would still look like the original object. Two of them would look the same. It was a translation. Reflection in the x-axis, no, it can't be a reflection in the x-axis, because if it was a reflection in the x-axis, it would have come down like this. It would reflect down this way. Right? So the answer is this one. Let me not waste the time. We'll talk about the rotation, some other question if necessary. All right. So that is that. Let's not waste any time on it. Our next question. This question says, diagram refers to line y equals x and the line y equals x. It says, what is the image of the line y equals x when it is rotated anti-clockwise about the origin through 90 degrees? So basically, taking this line and rotating it this way 90 degrees, it's gonna go like this. And rotating about this origin. This angle is 90 degrees. So this line is the line y equals minus x. That is that line, y equals minus x. The line that is perpendicular to this one and pass through the origin is the line y equals minus x. So that is the answer. Y equals negative x will be the image. Simple as that. All right, next one. It's a translation here. So this question says, following diagram refers to the following diagram of a translation. So this one is translated to that one, right? And asks us, in the diagram of translation which maps A to B, AB and to A prime, B prime is what? So let's look at it. Just need to focus on what happens to 1 point. You don't have to look at the entire thing. So this x value increased by 2. So I know that the translation increases the x value by 2. I'm gonna write what the translation is right here now. It increases x value by 2. So I know that x movement is 2. And this y value increased by 1 to 6. So it increases the y value by 1. So that is the translation, simple as that. X value increased by 2. So this translation moved x value by 2. Y value increased by 1. So this translation value is 1 for the y movement. So that's 2, 1. 2, 1, 2, 1, which is right here. Easy stuff. Easy stuff. Next one. This question says, OAA prime, OBB prime, and OCC prime are straight lines. ABC is mapped onto A prime, B prime, C prime by an enlargement. So going from this to this by an enlargement. Question says, what is the scale factor of the enlargement? Scale factor is just basically the multiple by which it got larger. That is all. As a positive scale factor this time. So for example, this side, this length was doubled. So scale factor is 2. Let's look at another thing. This side was 2, it turned 4. Scale factor is 2, it was doubled. I'm sure another thing that is also doubled. What is now? Which is something that a lot of persons don't pay attention. So for example, from the center of the enlargement, which is the origin right here, to C, that is 2 units, right? But from the same origin all the way out to C prime is now 4 units. So that's why the scale factor also is 2. The scale factor of 2 will change the size on the object and double it, but it also affects the distance from the center. So this distance, for example, is doubled out to here. Doubled with a scale factor of 2. In any case, the scale factor is 2. This is the answer. Scale factor is 2. Or the thing is twice the size. All right. Let's look at this one. So we'll finish now. This one says, refers to similar triangles. So these are 2 similar triangles. I don't know them similar because the angles are the same. Angles are all the same, right? Only thing that different are the sizes. So the thing is, if you notice from this to this, you half the size, half that size. You apply a scale factor of a half. So therefore, they're asking for MO. So the same scale is going to change it by now. So this 7 is going to half as well to get to this side. This 7 over here, you have to half it as well to get to 3.5. So the answer is 3.5 after 7. So from 6 to 3 is a halving, so the half the 7 as well. All right, because the scale factor, the ratio of the corresponding sides will remain the same. All right, the angles stay the same, but the ratio of the corresponding sides will stay the same. So this divided by this is 2, for example. So this divided by this must also be 2. And therefore, this has to be half of that. So it is 3.5. Easy question. Almost like common sense. Look over here. So give us the same information, but this time we're talking about area. All right, talking about area now. This question said the area of triangle ABC, as this one, is 20. What is the area of MON? Now, you can view this as an enlargement still. From this to this. Right? Now watch this now. This is something that is good to know for enlargement. So from this to this is a halving again. From this to this is like we apply a scale factor of a half. We half this to get to that. Apply a scale factor of a half. What's the relationship with area of enlargement or change in size of object? Enlargement. This is just like an enlargement. The area of the image, this is the image, will be equal to k squared, have to remember this, times the area of the object. This is a good formula to remember for area of enlargement. Area of image is k squared times area of object. All right, they tell us that the area of ABC, this is the object and this is the object and this is the image. All right, and the scale factor is a half because you see, they multiply this by a half to get that. And they tell us that the area of the object is 20, that's what they're telling us. So I want the area of the image now. So the area of the image is going to be half squared times the area of the object, which they told us was 20. They told us that the area is 20 right here. This becomes a quarter of 20, which is 5. So it becomes 5 centimeters squared. But this is the answer right here. I want us to remember this one, guys. Very important. This formula right here is a good formula to remember for enlargement. When it comes to area. When it comes to distance, or length, length of image is just simply equal to k times the length of the object. That is for length. But when it comes to area, this is for length. But when it comes to area, it's a squaring relationship. I remember area is a product of 2 sides. So when you apply the enlargement to the length, you basically multiplying the length twice. That's why you have to get the k squared. You multiply the k twice, I mean. All right? Okay, you have to do the product of 2 sides to get the area. So the scale factor is applied, multiplied by itself. I multiply it twice. Our next question is 54, going up to 61.
Yes.
We have like one question. You have a question?
Yes, sir. I thought the answer would be 10 instead of
a quarter of 20 is 5. Can't be 10, you don't have the area. Quarter, I'm give an example. Give a live example. Let's clear this up. Let's use some actual values and clear this up, right? Become fast. Let's say the area that they had originally was 20, right?
Yes, sir. In similar triangles, you quarter the area when trying to find the area for the smaller one.
No, no quarter. It's a scale factor. It depends on the scale factor. Area of image is k squared times the area of the object. This is what you must know. Once there's a change in size by a scale factor. Area of the image will be k squared, where k is the scale factor times the area of the object. I'm going to use some numbers and prove this here now, so that you remember. Just remember. So let's say this area, or to get the 20. Let's say this was 2 by 10, right? Let's say the area of the of one object is 2 by 10. I'm going to work with the same 20 now. This is the object. I'm going to make it a rectangle. 2 by 10. 2 centimeters by 10 centimeters. We apply an enlargement on it with a scale factor that is equal to half, as was the question a while ago, right? For half the size. If for half the size, it becomes a smaller rectangle. This don't draw something, but it don't really matter. It becomes this, right? This side that was 2 is now 1. This side that was 10 is now 5. This is the image. What is the area over here? What is the area of the object over here? What is this area? 20, don't it? By your reasoning, you're thinking I should just half this area to get that area. No. When I apply the scale factor of a half this side becomes 1. I half this side becomes 5. What is the area of this image over here? 1 times 5. Area of this image over here is 5 centimeters square. Why is it 5 centimeters square? Because the area of the image is that value squared times the area of the object. See here? The area of the image is a half squared times the area of the object. Half is a quarter this time, a quarter times the 20. That is how we get the 5. That's why it matches the 5 here. That becomes the area of the image. So it's not we don't apply just a scale factor, we square it. When it comes to the distances, then this distance is just k times this distance. For length, the length on the image is just k times the length on the object. So then, for example, this one is just half of this 2. But when it comes to area, this area is a half squared of this area. That's what you have to remember. Right? If it's a scale factor of 3, let's do another example. Scale factor of 3. I'll show you another example. Just to clarify. Let's say we triple the size. I'm going to triple the size now. I'll show you with a scale factor of 3. I'm driving home the point. So if I apply a scale factor of 3 to this, then the dimensions will be tripled. This side is going to become 6 centimeters. And this side is going to become 30 centimeters. What is this area? This area of this object is still 2 times 10 is 20, 20 centimeters squared. What is this area? What is this area over here, sir? This area of the image is 6 times 30, that's 180 centimeters squared. Is more than just 3 times. Why is that? Because, don't put it in here, so here now. The area of the image is 3 squared, k squared, times the area of the object. What is 3 squared? 3 squared is 9. What is the area of the object? 20. 9 times 20 is 180 centimeters square, which matches what the actual value is showing us. So you can't forget this formula for area of enlargement. Make it stick in your brain. Area of an image of enlargement is equal to the scale factor squared times the area of the object. This is the formula for area. Good? I don't have to do it anymore. But I go to that.
You can go up a little bit and say something, please, quickly.
Go over here.
So as you just go up.
This way?
No, sir.
This way?
Yes.
Up here. All right? So it's not half of the 20, guys. It's a quarter because you have a squared half.
Okay, sir.
Half square becomes a quarter. This half square becomes a quarter. So it becomes a quarter of the 20, which is the 5. All right, plenty of people going to put 10 in now. I don't think the air going to half. Nope. Nope. You're not going half. All right, you have to square the half to see the change in the area. Area of image equals k squared area of object. All right, enough of that. Let's continue. Let's continue down here. This question now says, it refers to the diagram WXYZ and the image W prime, X prime, Y prime, Z prime, and this one over here. Double prime, the double prime one. After undergoing a composite double transformation. So there are 2 transformations taking place. So like you start at this one, transform over to this one that is shown in the broken line. And then you go to this one. All right, so clearly some enlargement take place, right? Now I can look at it and know, you know. So this go to this point, right? And this far one go to this far one. So I know there's a reflection in the y-axis. Reflection in the y-axis to go from this to this. And then now to go from this one, this big one to this one is an enlargement. What is the scale factor? Scale factor is a half because this was 2 and now this is 1. So it cut in half, the size changed by half. What is the center of the enlargement? Find the center of the enlargement, I can join the corresponding point like Z and Z prime. I extend it back, like so. Looks like the origin. Let's use Y and Y prime, or we can use W and W prime. So if I come through here, so show me that the origin is the center of the enlargement. So I know everything about me already now. I do a reflection in the y-axis to go here first. And then I do an enlargement of scale factor half to go from this to this about the origin. That's my observation. All right, that's it. Let's see what the question asks us. Question says, what sequence of transformation map this all the way over to that? Which sequence? What did we say? What did they think the first? We are reflection on the y-axis first. Our reflection on the y-axis, followed by enlargement, center at the origin, a scale factor of a half. This is the answer. That's what happened. Reflecting the y-axis to go from this to this first. And then do an enlargement of scale factor half about the origin to get to this one. That is the answer. Done. Question done. That's it. Next question is a rotation now. All right. This question says it refers to the diagram which shows the transformation which maps O, P, Q, and O prime, P prime, Q prime. So let's look at it closely. It says this one transform into this one. That's a rotation. What was a rotation? Glasgow. And the 90-degree rotation. Because this side that was horizontal, it is now vertical. And angle between there is 90 degrees. It's like you take this and you rotate it up like this. Similarly, this side that was vertical is now horizontal. So it's like you take this that is pointing upward this way, and you rotate it, and now it is pointing this way. Pointing this way. And the center of the rotation is right here. I want to know that's the center of the rotation, but it does move. Center of the rotation is what we call an invariant point, a point that does not vary, invariant, does not move. That is the center of the rotation. That's an anti-clockwise 90-degree rotation, about origin. Obviously, that's what they say. The type of transformation that has taken place. A rotation, 90 degrees about the origin. See, look at this now. See the positive and negative coming here now, guys. See that?
And you said that the center of rotation is an invariant. You said the center of rotation is an invariant point as it doesn't move?
Yeah, the invariant point, the center of a rotation is always the invariant point, the point that doesn't move, invariant. So in this case, I know that this was the center of the rotation because it was moved.
What is an invariant point?
A point that does not change its position when you do a transformation on it. Like this point. So when we do the rotation on this triangle, the point is not going to wait, stay right there. because it is at the center of the rotation, so it is invariant. This point changed to this, so. This point changed to this, so. This point no move at all. It is invariant. It's called an invariant point. So any point of any transformation that does not change its position when you apply the transformation is an invariant point. Center of rotation is always invariant. Center of enlargement is also invariant. Points on a mirror line are invariant points. So for example, if you have a mirror line here, let's say I have a mirror line here. I'm going to do a reflection of a triangle like this. Bang, I'm going to draw it in a different color. I'm going to do a reflection now, right? Let's say I'm going to do a reflection with a triangle like this. And there's a point on the mirror. This point on the mirror not going to move, you know. So this is O, this is A, and this is B, and this is C. B is coming all the way over here, sir. So B is going to go over here, C. B is going to go over here. And C is going to go over here up to the top of here, sir. So C is going to be up here, sir. So this will be C prime, this will be B prime. This point will stay A prime. That will be an invariant point under the reflection. So all points on a mirror line are invariant points of a reflection. See it? So A will be an invariant point because when you do the reflection, it don't move, it stay right there.
What were some of the other examples you were giving for invariant points? Points on a mirror line, points.
Center of rotation, center of enlargement. Center of an enlargement. You want the enlargement example now? I'm going to draw one and show you.
Yes, please.
I'm going to draw one enlargement. So that's a reflection example, right? Points on a mirror line. Center of rotation, you have an example of rotation right there. So you don't have to worry about that, right? All right. Enlargement. Let me do an enlargement one quick. So if you have an enlargement, let's say we have let's say we have y-axis, x-axis, right? Let's say we're doing an enlargement about the origin. And we're doing an enlargement on a triangle that breaks out, that comes out from the origin. Right? This is a triangle, right? So this is a triangle. This is a triangle like this. And I do an enlargement of scale factor 2 about the origin. All that will happen is that the image will go like so. That purple one becomes the image, you know. You see it? If I do an enlargement of scale factor 2, for example. So if this was A, and this was B, and this was O, and this is now A prime, and this is now B prime. O don't move because O is the center of the enlargement. So it don't move. So O will be an invariant point in this case. See that? Good? So that's an invariant.
Sir, can you just understand that?
Huh?
I think you just go over the diagram that you did again, just re-explain what you drew.
Which one? This one?
Yes, sir.
I'm going to just draw a triangle. So I'm drawing a triangle like this. Just randomly drawing a triangle like that. And let's say I'm going to do an enlargement on this triangle about the origin. So the center of my enlargement is the origin. If my enlargement scale factor is 2, then what will happen is that this point will go twice the distance from the center of the enlargement. So this point will go out all the way out to here, twice the distance away. This point also will go twice the distance away like this. And then this will be my triangle now. So that red triangle has become that purple triangle. This is now B prime, and this is now A prime. The origin never moved. So my object is OAB. My image is OA prime B prime. O no move, O stay right there. O no move. who is invariant. Why? Because it happens to be the center of the enlargement. So center of rotation, invariant, don't move. Center of enlargement, don't move. Right? Center of rotation is invariant. Center of enlargement is invariant. Mirror line of a reflection, any point on a mirror line of a reflection, as it did here, also is invariant. Those are examples of invariant points. All right? Those are examples of invariant. All right, so the positive and negative I'm telling about you, guys. Positive and negative. So we might look at this and say, okay, that's a rotation 90 degrees, you know. We look at these two answers. Then look almost the same, don't it? Rotation 90 degrees about origin. Rotation negative 90 about origin. Two angle them are 90 now, one positive and one negative. This not right and this not right. Right? Reflection in the origin. The reflection in the origin, the point here would end up down here somewhere. If you reflect through the origin, and the point here would have come and reflect through the origin and end up down here. So it's not a reflection in the origin. All right? It's not a reflection in the origin. Reflection line y equals x. So reflection line y equals x, x and y values will change, will reverse. X and y values will reverse. The reflection line y equals x. So this point, for example, this point, which is what? 4, 2. 4, 2. Line y equals x would be like this. I'm eliminating some of the answers in that guys. So it pass through 4, 4 up here. So this line y equals x. That's y equals x. If we reflect this point now, y equals x, it comes straight across here. So, to there, so that's where it will go. This point will go here. But over here, say gone. So it's not that. We know it's a rotation. It's just a positive and a negative we are discussing. Positive and a negative. It's one of these two answers. But you know which one it is? The positive or the negative? But you know which one it is? Come on, tell me. Which one is it?
Sir, would it be negative because the negative rotation is clockwise?
But this rotation is anti-clockwise. Let me see that. I say we'll go from this up to this. These are the object, these are the image. So clearly, we rotate it this way. For 90 degrees, that way they rotate now. What direction is that? What direction?
Yes, sir. Sorry, anti-clockwise.
And anti-clockwise direction in rotation is what?
Negative.
Negative.
No. I said anti-clockwise direction is
positive.
positive. Make it sticking on the brain. I know when I used to go to school and I learned it, I just said to myself, why is it not clockwise and not clockwise or clockwise? Why is not clockwise positive? Make it stick in your brain. Clockwise rotation is negative. When you do trigonometry at the advanced level and you learn about the quadrant diagram, you learn about rotation this way. Positive rotation is that way. That's positive rotation. This is anti-clockwise. All right, so we know we're comfortable with clockwise. We look for clock every day to go clockwise and repeat that clockwise is the main direction. But anti-clockwise rotation is positive. Anti-clockwise rotation is positive. Anti-clockwise rotation is positive. Clockwise rotation is negative. So if you see a question like this, the negative I mean clockwise. The negative means clockwise, which it is not correct because this rotation is anti-clockwise. The negative ratio means clockwise. So we mark them for you. This negative means clockwise. This negative 90 means clockwise. Means clockwise. I never learn nothing today, I don't learn this. Means clockwise. Which is so. That's a negative rotation. This positive rotation, they're not putting a sign on it. So if you want to sign on it, is staying as positive. This positive rotation, let me mark it for you. Means it's positive enough. Positive. You know, they don't put a positive, it's positive. If there's nothing in front, it means positive. That positive rotation means anti-clockwise.
Sir, the reflection into the image.
Huh?
The
Anti-clockwise is
reflection of an
so.
object is the image.
Say that again.
The reflection of an object is the image, right, sir?
Yeah, what you get after, yeah, the image is what you get after you do the reflection, the image. Not just reflect anything I get. What you get after the transformation is called the image. For any other transformations, what you get after the transformation is called the image. What you get before the transformation, we call it the pre-image. I would just call it the object. So anything that you get after, so for example, in this example, yes, this is the object. This first one is the object. The second one is the image of the rotation. But this example that I drew, this over here, so is the object, or what we call the pre-image. And this over here, so is the image. What you get after the transformation is called the image, regardless of the type of transformation. So what you get after is the image. What you had before is a pre-image, or we just simply call it the object. Instead of calling it the proper name for it is pre-image. What you had before, the proper name for it is pre-image. Pre-image means before the image. What you get after the transformation is called the image. Whether transformation is an enlargement, reflection, rotation, translation, don't matter. What you get after is called the image. What you had before is a pre-image. We'll just use object instead of the word pre-image. Just use object. So that, remember that, guys. So based on that, then, which one of the answers is correct? Based on what I just told you now, which of these answers is correct? Which of them must shade? A or B?
B. A.
I say B, man. If you say B, I'm say 90 mean clockwise, and this clearly anti-clockwise is going. No, look. You can't see some anti-clockwise this go. Mark it out again. Look. Anti-clockwise it go. Look. Look good. This is the original. So this is a Q, that means object. The Q prime means image. So the rotation is from the 1 year up to the 1 year. Put the arrow head on it. Let's put the arrow on it. Let's put the arrow pointing so. And put the arrow pointing so. And it rotate about this point. You know, so the rotation gone up the way, like so. It rotate gone up so. Rotate gone up the way. You know, see that? Rotate gone up so. That is the anti-directional rotation. You see it? You see that?
Yes, sir.
That direction is anti-clockwise, which is positive. Positive anti-clockwise is positive rotation. Positive 90 degrees it go. Because the angle between here and here is 90 degrees. So rotate 90 degrees about the origin. See that? So the positive one. Huh?
You could have swear some ear say negative. Anti-clockwise, negative. That I did hear.
You know, some rap on the paper.
Oh, let us
write it, I'm going to say it 50 times. I said to you, when I was growing up and I started learning this thing, but the first time I was used to say to myself, clockwise is the direction we're mostly familiar with. Everything turn clockwise. We are turning a screw clockwise, a clock clockwise. Why is clockwise the negative direction? That's what I used to say to myself. But the clockwise direction is actually the negative one, and the anti-clockwise direction is the positive one for rotation. Okay? Come on, we're spending enough time on that.
Yes, sir.
Right. So the answer is this one, right? The anti-clockwise one. The positive one. The one with the positive. So if you see a question like this again, you have to remember. Positive is anti-clockwise. Remember, the clockwise is negative, right? So anti-clockwise is positive. Clockwise is negative, anti-clockwise is positive. That's how I have to choose that one. So them two answer the close, you know. Because I get plenty of people trouble, you know. Because they know stand 90, but they just never know whether to choose positive or negative. So now you know. So if you don't remember nothing else from this class, you must remember this one. Clockwise is negative. Anti-clockwise is positive for rotation. All right, reach 56 now. 5 more pages to go. We're going to try to them fast. I'm going to have like 2 questions and 1 question for them. Not a lot. Let's go. This one. This one says, in each of the following diagrams, A prime is the image of A. So this is the image of this, right? A prime is the image of A. Which of the diagram shows a reflection in the x-axis? Instead of x-axis here, they could have said y equals 0, but the x-axis is y equals 0. Is it this one? If you reflect this in the x-axis, see the x-axis here, remember the x-axis, see the x-axis here. Reflect this in the x-axis, may I get this? Yes or no?
No, sir.
No. This one. Perfect. This in the x-axis. The mark x-axis again.
No, sir.
No. Let me reflect this in the x-axis. This. Let me again. I get that?
No, sir.
No. Let me reflect this in the x-axis now.
Yes, sir.
Yes, sir.
Beautiful. Beautiful. That one. Gonna come right down this, right? Beautiful. Obvious. This don't need no explanation. Everybody know mirror. Everybody know how mirror works. Look in a mirror every day. Mirror no work no different from how we do the mathematics, you know. Same how the mirror work in a real life, or same mirror working at the maths. Same question here, so. In each of the following diagram, OA is the image of OA. Which of the following shows the reflection now in the y-axis? See, a while ago the x-axis. No. So why you said x-axis? Same image, you know. But now it is y-axis. See it? Y-axis. So you have to, so you can't answer the diagram and assume it's the same question. Same information, everything, you know, guys. But this time is y-axis.
This is a B.
So ready? Eh?
B.
All right. Can you reflect in this line? Is that one right?
No,
So
sir, because that's the reflection on the x-axis.
No. This one is y-axis now. So this one, right? Come straight across us, don't it?
Yes, sir.
Yes, sir.
Yes. The answer is this. Beautiful. We are flying now. We're flying now. Flying. We want some 58 and 59 and 60 or 62 there now. This one not it, right? Supposed to go across the stuff. And this one not it either. Supposed to go across this. All right. Easy. We don't have to spend more time on that. Let's continue. Down here. All right. Some easy trigonometry now. Boom, bam. Quick and fast. Quick and fast. This one says.
C, sir.
B. Them ask me what is X. B, yes, sir?
C, sir. Yes,
C.
sir.
All right. So if it isosceles, the angle at 30, don't it? Because the angle opposite the side must equal the angle opposite the side, don't it? Because it's isosceles. Yes. So basically saying this angle down is 30. Them two add up to 60. Total angle of the triangle is 180. So X equals 180 minus 2 times the 30, which is 60. 2 times 180 minus 60 is 120. All right, 120 C. Beautiful. Them question are soft now. We're flying now. Let's go. This one, easy again. You know, the last question on the paper is easy. Next one, you know. Which one?
D.
D as in dog.
D. No. Oh, yeah.
Total angle triangle is 180. You have 2 of them already. You have 2 of them already in the triangle. I'm going to try it for you. Let's draw it. One angle is X, one angle is 2X. What is the third one? Third one must be 180 minus the sum of them 2 there, don't it? Minus them 2 there, which is 3X. Minus, not divide. Don't give it away. Answer the last one. Come on, we're flying now. We're flying. We are flying now. Up here, so. Same thing again. ABC. This time, let's say ABC. X and 2X again. Same thing again, you know. So the answer is A, don't it? Don't it? Same thing. This one's ABC. That one's the ABC. This one's a PQR. But same information. Same information. Shut up that. Next one. Boom, bam. Right here. Says. This one refers to the diagram which shows angle of depression. One thing you have to remember, guys. This is angle of depression. Angle of depression measured from the horizontal looking down. We'll always give about the same angle from the horizontal looking up. Angle of depression from one end looking down equal angle of elevation from the other end looking up. So this angle inside here is also 35 degrees. This angle inside here is also 35 degrees. Or you could basically just look at the Z angles to see it. See the Z there? This horizontal and this horizontal, you know, that's a transversal line. So you have the Z, see it? So you know that that angle inside the triangle is 35 degrees. Then, because that's a right angle triangle, we're going to run the so-called tower, don't it? So this side is the adjacent to the 35 degrees. Which side do they want in question? Question wants YZ, which is the opposite side. Opposite and adjacent. Which trick shall we use for that? Tan. That's all I'm going to tan there. Yes, you want tan answer there. That must be it now. So tan of the 35 degrees equal the opposite side that we want, which is YZ, over the adjacent side, which is 12. Just take the 12 and multiply it up here, so now you have the YZ, right? Let's multiply it up across. So the YZ equals 12 times the tan of 35 degrees. So the answer is D. D as in dog. D as in do it again. All right. So that is number coming to the end now, guys. Coming to the end. Coming to the end. So same question this now, but the value is different, right? 30 degrees and 10. So it's the same calculation. Inside this is 30 again. Z angle 30. So right here says 30 degrees again. Same information. Same information. Same information. 30 degrees right here. This is adjacent again, same here. This is the opposite. It's the opposite amount again. Yep. YZ again. Same thing. Same thing. 10 tan of 30. We set it out again. You're gonna have the tan of the 30 degrees equal the opposite side, which is YZ, over the adjacent side of 10. Multiply the 10 again, gonna get 10 tan 30. Let's stop it right here. 10 tan 30. Moving right along. Same question, different values. Let's look at this one now. This one says, refer to the right angle triangle below. Which trig ratio is equal to 4/8? So we're talking about this over this. Now, if we're focusing on this angle, then this is the opposite, and this is the hypotenuse, don't it?
Yes, sir.
So this becomes opposite over hypotenuse. Opposite over hypotenuse is sine, don't it? Sine of x, don't it?
Yes, sir.
Yes, sir. Sine of x. We know it could have been the cos of y, don't it?
Yes, sir.
Yes, it could have been the cos of y, because if you make y the angle under consideration in blue, then to the y angle, this would now be the adjacent. See that?
Yes,
See
sir.
that? And then this would still be the hypotenuse, and then the cos of y would be the adjacent side to the y angle would be the blue one, now, right? Would be the 4/8, just the same. So if they want to change the answer, they can change one of these and put cos of y instead, and to still be correct. But understand that?
Yes, sir.
That?
Yes,
Good.
sir.
Good. Think basically on the last now. This one says, a plane is flying in a direction of 0.45 degrees, changes its course clockwise in sun, right? Clockwise to a direction of 135 degrees. The angle through which it turn is what? It turn through 90 degrees. Let's sketch it up and show. So like you have a plane flying 45 degrees this way. Let's draw it up on 45 degrees. 45 degrees this way, going this way, right? Let's put in the bearing angle. Let's put in the north line here. This is the north line. That's our north line. So the bearing angle is this angle right here. 45 degrees. 45 degrees. We're just gonna put 45 degrees. Then when it got to this point here, it changed to 135 degrees. So I'm gonna put the north line again because we're going a new bearing. And it's now going at 145 degrees. So going clockwise 145 degrees. So going clockwise 145 degrees around here. So going down so. And this angle now is 135 degrees. I say 135. That is now 135 degrees. All right. So that is where it is going. So it was going this way first. And it's now going this way. So if we were to extend this and show what the direction was up so, this was the direction, this is a different color. Show the direction. The direction was this, you know, like so. This was this direction initially. This was this direction. And the bearing of this direction remains 45 degrees. Don't change. It's 45 degrees just the same way. And it's now going this way. So the angle through which it turned, I'm going to show it in black. It turned through this angle right here. This is the turn. clockwise. That is the term. That angle is this angle right here, which happens to be 90. Oh no, it's 90. 135 minus 45 is 90. So the term is 135 degrees minus 45 degrees. So it turns to an angle of 90 degrees. All right, so it's going here first and it is going there. That becomes this direction. So it turns. Think of that as the nose of the plate. It's not going this way. It's not going this way. So that is 90 degrees. I mean, just trying to give some explanation.
Sir?
Let's see. Yes?
Sir, go up a little bit. Like move to some place, sir.
Where?
Yes,
Over
the
here, sir?
question. Yeah, the question.
Oh, the question. See there? Going 45 degrees first. Then it turn clockwise 135 degrees to a new bearing. So I just sketch it out. So first was going on a bearing of 135 degrees, then turn clockwise and going on a bearing of 135. And I ask for the angle through which it turn. Angle through which it turn. It was going so, it turned 90 degrees and start. So the angle through which it turn is 90 degrees, that black line. That's how it turned. 90 degrees. Good?
Yes, sir.
Yes, sir.
Where are we now? We're at page 59. 2 pages to go. Let's finish this strong. All right. This one gives us this triangle. In triangle ABC, that angle is 30 degrees. AB is the hypotenuse 40. What's the length of BC? They want this side, BC. So this is the opposite to the 40, don't it? That's all? That is 40 sine 30. You can say sine of 30 equal the opposite side that we want. Opposite side that we want over the hypotenuse, which is 40. Multiply the 40 up here. So the opposite side, which is what we want, BC, is equal to 40 sine of 30 degrees. 40 sine 30. The answer is E. Easy questions. Always complete. So the number there 57, 58, 59, 60. Always easy. This one. So see these two lines cross like that. You know that you have vertically opposite angles and you have angles in a straight line.
Sir,
Also,
I don't think I get the one that you just did.
PM50.
Huh?
I don't think I get the one that you just did.
This one over here, sir? All right, we start over. All right, let's go again. Question basically gave us that diagram. And what they describe up here is in the diagram. And they want us to calculate the length of BC. BC is this side. So the only angle we have in the diagram is this one. The only angle we have in the diagram is this, and it's a right angle triangle. Once that's right angle triangle, we are free to use so, ha, power in it. This is if we want to use a sine. This is if we want to use a cos. This is if we want to use a tan. The one that you use depends on the angles and the sides involved. The trig ratio that you use depends on what is involved in the calculation. So this question wants the opposite side, BC. The side opposite to this angle is BC, so it's called opposite. So if this is the angle under consideration, this over here is the opposite. The angle opposite the 90 is always the hypotenuse. So we know that this is the hypotenuse. This is the hypotenuse. The angle that, the side that the one that is opposite the angle under consideration is called the opposite. So we want the opposite. So we want the opposite and we know the hypotenuse. So opposite and a hypotenuse are the sides involved. See here, opposite and a hypotenuse. See here, opposite and hypotenuse are the sides involved. See there? So because the opposite and the hypotenuse are the sides involved, means I want the opposite and I know the hypotenuse. It means that I'm going to use sine of an angle trig ratio to solve this question. That's what I'm going to use. Taking my time. So I'm going to set up the trig ratio. That says sine of the angle under consideration, which is 30 degrees, is equal to the opposite side. The opposite side is BC, you know. It's BC we want to find, you know. Let's call it opposite. You want to put BC is equal to BC, which is the opposite side over the hypotenuse. The hypotenuse is 40. I'm going to try to find BC. I'm going to make BC the subject. Let's cross multiply the 40 over here. Multiply it across. Simple transposition that. So the BC that we want is equal to 40 times the sine of 30 degrees, which is the answer in A. Better? Better now?
Yes, sir. Clear. Thank you.
Beautiful. Beautiful. All right. Next question now. So remember now, guys, when you get this diagram with line crossing like this, things you have to look out for are what we call vertical opposite angles. For example, angles across from each other like that, equal. So that is also 58. Vertical opposite. Similarly, these two are vertically opposite, these two. So they will be equal to each other. Then we also have angles on a straight line. So for example, that's a straight line. Angle on a straight line to the point completes 180 degrees. Right? So this is 180 degrees. So this angle in here that we don't know is going to be 180 degrees minus 58 degrees because total angle on a straight line to the point is 180 degrees. So those are the key things that happen when you have lines crossing each other. Vertically opposite angles are the angles that cross each other in the X, and they also have angles on a straight line is 180. So you look out to that, look out for that, and you look to use that. Ready now. Let's see what they want. First thing, say, what is the measure of angle ABC? We're going to draw it out. Angle ABC. Angle A to B to C. We're talking about this angle right here. Yes?
E.
E as in egg. Let's see, let's see. E as egg. Yeah, E, you sure?
Sir, it's angle ABE, not C.
Oh, I said C, but the ABE may draw still. The ABE may draw. See the angle ABE, that's what I drew. Might have said ABC, I don't know. But it's ABE I draw. So I'm finding the right one. All right, so how do I find this angle now? Mute your mic, please. Mute your mic.
58 from the 180 get to
Good. What am I gonna get? How much?
122.
122.
180 degrees minus the 58 degrees. Because total angle straight line is 180, 122 degrees. All right. So the answer is B. I thought you were saying the answer is C. All right, cool. All right, beautiful. Next question. Which of the following angles are equal? So we're going to mark them out now. Which of the following angles are equal? All right. Which of the following angles are equal? And the ones that are equal, remember, are the ones that are vertically opposite, right? Let's mark them out. Let's mark them out. So they're talking about DBC. Let's mark out that one. DBC first. DBC, that's this one up here. DBC and CBE. CBE. Nope, those two not equal. So this is not right? Agreed? They are saying this and this. Those two not equal, right? That is not correct. Let's go for the next pair. Next pair is CBE. Let's mark it out. CBE. That's this one right here. And ABE.
Yes, Daddy.
With the mic, please. ABE. This one. Again, this is not correct, right? Those two not equal. We're looking for the vertical opposite ones. Let's erase that and go for the next pair again. So you have to look for it until you find it. ABD. ABD. ABD up here is the 58 that they gave us. And CBD. CBD. Let's mark the CBD in a different color. CBD. Talking about this one. Again, those two not correct. One of the vertical opposite angles will be equal. So must be the last one, right? Let's make sure. Must be the last one. ABD. ABD is the one that they gave us, which was 58. And only this one equal to it, so it's not that we so we eat the supper. CBE, correct. CBE. CBE. Yes, it is true. Those two are vertical opposite. They are equal. So this is the correct answer right here. Bam.
There and them have one common point.
And a common point in the middle, but all them have a common point. B, look. B the one whole of them. See that? These are the These are the focal point of all the angles in all of the angles in this diagram. B is the focal point of all of them. B. In all the cases. Alright, so you have to look through. Alright, is there any other? Reach page 16 now, guys. Wow, we've done it. 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 This question says a ship sailed 8 kilometers due east. Due east means towards the east. Yeah, guys? Remember, guys, when you're setting up your coordinate system, you always spell we across here and you're not up here. So plenty of time people make the mistake and put the E on this side. Put E here, so, and W over there. So nope. Always spell we. Remember, spell we, west to east. Always spell we across here. So it's north, south, east, and west, right? That's coordinate system. We is what they put across here. All right. So the ship go due east. So if we go due east means towards the east. So we go 8 kilometers this way. Bang. 8 kilometers you go first. Sketching it out there. I'm not going to look which one is right. From A to B, you go 8 kilometers due east. It then sailed 6 kilometers due north. Due north means you go towards the north. Don't make the word due mix you up. Due just means towards. So due east means towards the east. Due north means towards the north. So now we're gonna go 6 kilometers towards the north. This way. That's towards the north. Bang. Towards the north. And I go to a point C. And this is 6 kilometers. So any of the diagrams that match this one is the answer. Any of the diagrams that match this that we just sketched is our answer.
Sir, and if they were to hypothetically ask, sir, if they were to ask us the total distance traveled based on the diagram in this question, would it be 14 kilometers?
Yeah, because I go 8 east and I go 6. You go 8 east and 6 north. But if them ask you what is the, if them ask you a question like what is the net change in position or something like so, it will be 10. Because it will be talking about this distance. They could have asked for the distance AC, you know, to be right across it. That will be 10 kilometers. How many know say it's 10? How many know it's 10? How many know that distance is 10? Nobody can tell me how many know that distance is 10 quick and fast. How many know that distance is 10?
Pythagoras theorem.
Pythagoras theorem, and this is called a Pythagorean triple. 8, 6, 10 triangle. You know what an 8, 6, 10 triangle is? 8, 6, 10 triangle is a 3, 4, 5 triangle that has been doubled to a 6, 8, 10 triangle. So if this is 8 and this is 6, then that must be 10. So if after the distance AC, it will be 10. All right, good question. Let's go. Let's go. They didn't ask us that. So we're looking for the diagrams. The question says, which of the following diagrams best represent the path of the ship? Anyone that matches this. Anyone that matches that. 8 to the right and 6 up. 8 to the right and 6 up. 8 to the right and 6 up. Voila. There you go. 8 to the right and 6 up. Right there. Everything is failed. That's it. But go to that. But okay.
Yes, sir.
Beautiful. Beautiful. I say ready for the 60?
Yes, sir.
Yeah, man, of course. Nobody get less than 58 in it. If you make only one mistake here and there, don't make no more than 2 mistakes. 58 or more. 58 or more. Anything less than that, not good enough. Anything less than that, not good enough for this exam. 58 or more. Binge it between now and Tuesday. Binge it today. Binge it tomorrow. Give yourself the best chance. It's the only paper they're marking. Give yourself the best chance. Don't joke. Spend all day, all night if you want. Just make sure you sleep tomorrow night, Monday night. And go to bed early and get a good rest. Shut it up Tuesday morning. Ready? Number 59 refers to the following diagram. A survey is set up. A surveyor sets up his instrument 12 meters from the foot of a building. See the 12 meters here? 12 meters from the foot of a building. All right, see this question multiple times. from the foot of a building and records the angle of elevation of the top of the building. So this is the angle of elevation to the top of the building that he records. It horizontal eye level, and he elevates the line of sight up here. That is the angle of elevation. This angle right here is the angle of elevation. All right, so it's just a diagram representing what he did. It says, an estimate of the height of the building can be obtained by calculating what? So the height of the building is the overall height here. So it is this height from here to here, which you know is 1.6. That is 1.6, right? And then you need this height up here. So we're going to get that height. To get that height up there, you're going to come and work in this triangle. Let me erase this. I'm going to come and work in this triangle. This triangle right here. What happened now is that this distance is the same distance right here. So we come on the triangle, then this distance is 12 as well. So this distance is 12 meters, which now is adjacent to the angle. All right. And what we would want to find is the remaining height up here, which is the opposite to the angle. So we're going to put OPP on this one, the opposite to the angle, OPP. For opposite. And then this height to right here, so we said is same height as the man, 1.6 meters. So this is 1.6 meters. So if we want to find the overall height of the building, right, we have to add the 1.6 to the height, the opposite height up here. So what we're going to use, the right angle triangle, so-called tower. Opposite and adjacent are the sides involved. We want the opposite and we know the adjacent. Opposite and adjacent are the sides involved. Let's do the calculation up here. So we're going to use tan, so-called tower, opposite and adjacent. So we're going to say tan of 40 degrees equal the opposite side that we want over the adjacent side of 12. Multiply the 12 up here. So the opposite side becomes 12 times the tan of 40 degrees. To get the overall height, now we're going to add this to the 1.6. So the height of the building, let's call it capital H. Capital H for the height of the building. Let's put over this side. Becomes equal to 1.6 down here, so plus the 12 tan 40. I know why they don't have to work that up, because I can't use a calculator, so I have to leave it like that, right? But you can't work it out. So I'm going to put plus 12 times the tan of 40 degrees. And this is going to be your answer. Let's look for it. 1.6 plus 12 times 40. Answer is B. 1.6 plus 12 times 40. Not very clean, but you can see it. And that is that. See, page 61. Is it? Page 61. Is that. All right, guys. That is it. We will have a session tomorrow. We can have a session tomorrow at
what
Telegram.
time, sir?
I'm not Telegram. It's gonna be 4 p.m. Jamaica time.
Yes, sir.
5 p.m. Trinidad and Tobago time. Those in Trinidad and Tobago.
So you're gonna have it face to face?
My students can come face to face to class. We set it up on the Zoom just the same. So those who online can attend. We're gonna work with a couple past papers. All right?
Is it the same link?
Huh?
Use the same link?
Same link. Yeah, it's gonna be the same link. And it's gonna be on YouTube as well. Same live. All right? So, and we're just gonna work out a full paper straight, 1 or 2 full paper straight, not the topic by topic. We're gonna work out a full paper straight. Full paper straight. All right? And have some fun. All right? So see you all tomorrow. Good night, have a nice day. Those are like check.
Hey, sir.
Bye, everybody.
Yes, sir.
Okay.
All right, sir. No more.
All right, yeah, man. Cool.
Tomorrow.
All right. Bye-bye.
Bye, sir.
God bless you, sir.
Bye, sir. You were really helpful. Learned a lot. Thank
Bye,
you.
sir.
See you tomorrow.
Okay, bye-bye.